Hello, everyone. I hope you all are doing amazing. Welcome to my channel, Best Math. I am Justin D'Souza, your math teacher. This is an introduction video for the EOT explanations for this term, term 1, this academic year 2023-2024. This is specifically for the grade 12 advance. We will quickly look into the exam scheme, that is the Heikel. I'm sure you might be thorough by now in all these topics. The first, which topics will be coming for the exam? The first 15 topics here are multiple choice questions where you can just do any methods and get the answer, and you can get the correct answer. You can just select the answer. So no need of writing any steps or anything. So you can use the calculator method or whichever method which easily gives you the answer for the first 15 questions. That's this two over here. But the last 5 questions are free response questions where you need to detail each and every step. Do every substitution. Make sure you show everything in writing. Don't jump to the answers. You won't get the full marks. So please make sure you write and practice everything, but be extra thorough in these 5 questions. And the questions are 20 in total. The exam is 2.5 hours. It'll be Swift Assist and paper based, and you're allowed to take scientific calculators. So many of the topics, the MCQ topics, can be easily solved. Now, how you can access all the videos easily is, if you go to my channel here, you will see this here. Now over here there'll be different grade videos as well, so it might be confusing. For all the EOT questions, I will put the grade like G12 advanced, that's grade 12 advanced, question 1, question 2, and so on. If it's grade 11, it'll be G11A and so on. But the best and the easiest way would be going to the playlist here, and you can see which is the playlist. EOT1, that's end of term 1, this academic year 2023-2024. And I'll mention it's grade 11 advanced, 12 advanced, and so on. As of now, since I just started with the grade 12 advanced, it's only grade 12 advanced topics over here, the playlist. You can click on the view full playlist. And as I complete the videos, I'll be posting it over here. And you'll be able to view all the videos. I'll try my best to do as soon as possible. I'll try to do all the videos. And for grade 12 advanced, I'll try to do many problems. I'll try to go through each and every problem as I can. If they're literally the same, then I would just skip through, or I will just go through them quickly. But I'll try to do each and every question in each topic. Now, say you click any topic like this. We move on to the second. Now here, you can easily access all the playlist, and you can see in the description some details, and this is the topic name, question number, and you can find the EOT presentation over here. This is a link to the Telegram, and if you click over here, it will direct you to the Telegram group, and if you just click on it, you can join the channel, or you can just access this channel in Telegram app, and then you can download the entire presentation. The presentation which I've used for the videos is available over here. And this link is put in literally each and every video's description. So just click on this and you can easily access it. I hope that's helpful, and I will see you all in the next videos. Before I finish, I just want to quickly tell you, please do write and practice the problems. Don't just go through it. Please practice by writing. And last thing, as I always ask you, if you have subscribed to my channel, I really appreciate it, and thank you so much. But if you're not yet subscribed to it, please do subscribe to it. It would mean so much to me. Thank you guys, and I will see you all in the coming videos. Hello everyone, I hope you all are doing great. I hope you all watched the first video, that's the previous video about the introduction of the EOT. And now we begin with the first part. And the first topic here, it is about estimating an arc length of a given question. Again, a quick reminder that the first part is question 1 to 15, and these will be in MCQs where you'll have 4 options. So I will stick to the shortcut methods over here. Here in this particular problem, we have been asked to find the arc length depending on n equals 4 or n equals 8, or you can find it larger n's. Now, the most easiest way for this is finding it with the integral formula. You will come to learn about integrals in the next term, but if you recall this, if you just remember this formula, it is more than enough because you can use calculator and directly solve it. Now, there are few things to be noted in this formula. That's this f dash. So the given function will be f of x. That will be given to you. You need to derive this function and then you will get f dash of x. May it be trigonometry or polynomial, you must use the laws, say for example power rule or trigonometry rules, and then derive it. And this a and b will be given, it's always ascending order, say the range is x less than or equal to 1. Then now here this will be the a value and then this will be the b value. It starts the interval where it's given. So that's it. That's the only three things you need to know. The derivative needs to be found out. A and B, substitute in this formula and you will get the answer all the time. You will learn more about this in the next term. Now let us look into the formula, look into the problems and solve. Please remember this formula. Try to remember it thoroughly. Now just look over here. Integral AB square root 1 plus f dash of x all square. The derivative is only squared. Don't extend the square. It's only for the f dash of x term. Now imagine the problem is like this. We need to use our calculators for this. But before that, let's derive the functions. What is given to us? F of x, right? What is the derivative? F dash of x. That will be, since it's cos, negative sign will start and then it is sin x. That's it. Here a value is given as 0, b value is given over here. The formula for arc length is given as integral a to b square root 1 plus, sorry, it's not a square root again, it's square f dash of x the whole square dx term, nothing, we don't touch it because that will be already there. Whenever you're taking an integral, this is naturally there. You will learn more about this in the next term. For now, just remember this formula. Use your calculator. All you need to do is type this. Where is that? Let me bring it at the center of the calculator. I hope it's clear now. You can see this. If you press shift and integral, it's derivative. But if you press the symbol directly, you're going to get integral. And you can see dx is already there. You don't touch it. You don't change it, sorry. Now all you do is put the square root symbol. 1 plus, what is f dash of x? It's most important to use a bracket here. Now it's negative sine x, right? Negative sine, use alpha x, close the bracket once, that is for x. And now one more time because you open the bracket. Remember there are two brackets. And now press the square. And now what is the a value? A value is 0, b value is over here pi. Now we know that whenever we use sine, we need to change this more to radian because it's in pi terms, that's radian terms. Shift more and 4. And now press equal to, you will get the answer. That is, what just happened? 1 minute. Oh, I just realized that I put pi here. I'm sorry for that. Okay, it's good to know the mistake. If you just change the value, the intervals, you get wrong, okay? Now, divided by 2, I thought I'll be editing that part, but I've kept it so that you don't do the mistake what I just now did. Remember, A is 0, B is pi by 2, and just press equal to, you will get the answer. Now, 1.9100, you can approximate to 9101. Now the other answers as well are very, very close to this. So you will have 4 options. One answer which is very close to this is the correct one. If they ask you the actual length, anyways, it's directly found over here. Now, as you increase the n values, you will come towards this value. Okay, if you increase maybe 4 more, you are going to get this value itself. Now, if you're thinking, how is this done? This is the detailed method. Now, how is this done? Here, the intervals are given, right? So basically, you're breaking those interval into 4 parts. Now, this is cos curve. Cos is some, if you have, wait, let me just do this. Now, imagine cos curve. It starts from here, from 1, and then it keeps on going like this, and then comes down, up, like this. Now, since we have 0 to this part over here, where it finishes, the period is 2 pi for a cos graph. This middle term would be pi here, and pi by 2 means over here. Okay, pi by 2 and 0. Now, if you're finding this curve directly, you approximate it as a straight line, linear line, and we won't get an accurate answer. So what we do is we take interval from 0 pi and we take 4 intervals. That means we break this line. The curve is there, right? This curve, we break it into 4 parts: 1, 2, 3, and 4. And then we consider this to be linear, and we solve them, we find them, and then add the length. So it is more accurate. Whereas over here in the second part, they are telling 9 intervals. That means this part is cut into, sorry, 8, n is equal to 8. That means it's cut into 8 little bit of intervals, small intervals, and you're finding 8 individual lengths, basically, and then we find it. That's how you get accuracy. As you cut into smaller and smaller pieces, it'll be more accurate. So that is the thing. But since it's an MCQ, just remember the calculator method. That's more than enough. The last part I just told that for your understanding. That's it. Let us go to the next problems as well. Let's just check this out. What about this one? Whenever you see any of this problem, first thing, what you do is find the derivative. No, first write the formula. Sorry, let me write it. Arc length equals, it would be integral a to b square root of 1 plus f dash of x the whole square dx. And what is the a value given over here? A value is 0, b value is pi by 2. Now, all you need to do is use your calculator and solve. Here we have, I'm just going to change over here because the interval is same. Just being lazy. Oh, I forgot to find the derivative, my bad. Now, what is f dash? F dash of x equals cos x. That's it. Now you have, because it's sign, it's positive. So now you have f dash of x, a and b. All you need to do is substitute over here. And instead of the sign, I'll just change cos. You need to type it out entirely again, but now since it was the same thing, I'm just typing it out. And the answer is 1.91. Let's just check. Yes, the answer is 1.91. Now, it should be the same because the first question was cos, second is sine. What is the difference between those two graphs? I mean, you can skip this part if you, if you don't want to understand more, but if you're just thinking it logically, let me just tell you. Here, cos graph just starts from here and it goes on. It starts from 0, 1. Whereas sine graph starts from 0, 0. That's the only difference, And now say till pi by 2. It's the same curve. Doesn't matter what. The same curve, right? The curve length is the same. It's just the alignment is different. So the answer must be same for the same interval. That's the thing, okay? Now then, you can check the answers are same. Over here we have, let me just solve this as well. Let me just first write the formula. We have already written it, so I'm just gonna, just change this part only. Okay, here we are. What is the derivative of root x squared x plus 1? I'm not gonna derive entirely, but you must know by now. Square root x, what's its derivative? This is the function. The derivative of that would be 1 by 2 root x. Okay, you might be thinking why, but this is from the power rule formula. I'll just tell you quickly for this one. Now, root x means it's x to the power half. Now we use power rule here. It'll become half into x to the power half minus 1 will give you negative half. But we don't usually keep the powers as negative, so we will make this positive by taking it to the denominator. 1 by x to the power half. This is it. Now we don't write x to the power half. We can write it in a nice way. 1 by 2 root x. So this is the formula. But you do not need to solve it every now and then for root x. Just remember this is the formula. 1 by 2 root x. So if you remember so much, you can directly substitute this. Now here look. What is the formula? What is inside the square root? Instead of x, we have x plus 1. That's fine. Just relate this 1 by 2 instead of root x, write x plus 1. And then it's a chain rule. You need to derive this. But look, when you derive this, it's going to be 1. So it's same, you know. What is derivation of x plus 1? It's just 1. So you can apply chain rule, but it'll be 1 itself. So you can leave it. Now this would be the answer. Here we know for root x it is how much? For root x it is 1 by 2 root x. But now we don't have root x, we have root x plus 1. So whatever was there instead of x, put that one. Chain rule applies here, but since it is just x, it'll be 1, and 1 is, this constant is 0. So this is it. This would be your answer for derivative. Let me just erase this. I hope that is clear. Now, so here I will just write, that is the f dash of x term. Now, what is a value? A value is 0, b value is 3. Now, all you need to do is substitute in the calculator. Let me just clear it off everything. Now, it's better to clear your calculator regularly, because in some cases I have noticed with my students, though they substitute everything, they won't get the answer correctly when they are using this x terms. So just clear your calculator by pressing shift 9 3 equal AC now and then, so that you won't get any error. So here now, this is the formula: integral square root 1 plus, what about f dash of x? It is 1 divided by 2 root alpha x plus 1, close the bracket, square, and now we need to put over here 0 to 3, and that is it. That's the answer. Did I miss anything? I think so. That's it, right? Yeah. Okay, the answer must be 3.168. Yeah, that's correct. So it's almost very, very close. It's almost the same answer. So yeah, here you just simplify and you take the round it off to 3 digits. So this is how you solve it. You can stop watching this video now and solve other problems by yourselves, but I'll be solving them anyways. I will solve them in detail, just if you have any doubts. But if you're confident enough, if you understood the topic, just use the formula by yourself. This is the formula. Just use it and solve it up. Okay. Let me do this one as well. But I highly encourage you to solve it by yourself from now. Here we have f of x as 1 by x. Now again, remember, if f of x is 1 by x, how do we solve it? Now what I'll do is I will show you in detail how we get the formula, but then try to remember the formula directly. See, in my mind, it's already ingrained that 1 by x is minus 1 by x squared, right? Yeah, 1 by x squared. But anyways, let's prove this. You know this is the 1 by x. How do you derive it? Is basically bring this x to the numerator. It will be x to the power minus 1. Sorry, this is not dash. Wait, let me just write it over here. This f of x can be written as x to the power minus 1. Now, use power rule here. Minus 1 will be brought down. X to the power minus 1, minus 1. You will be getting negative, because minus 1 means negative sign, negative x to the power minus 2. But now I told you, right, we generally don't we try to make all the powers exponents positive. So what we do is negative 1 by x squared. Now it's positive. That's it. That's the derivative. So you do not need to do this all the time. Whenever you see 1 by x, just write the derivative negative 1 by x squared. Now, instead of x, you had away x plus 1. Then this would be negative 1 by x plus 1, the whole square. That's it. I hope this is clear. Now, the answer for the derivative over here is negative 1 by x squared. Let me just clear the other things. So, it's very important for you to remember this. It will save a lot of time in the exam, you know. So, f dash of x. What is a value? 1. B value is 2. Now just substitute everything in the calculator. I will just rewrite. I'll just change this over here, you know, because you know how to write this, right? The same thing we have done a while ago. Here, I will change this all to alpha x squared, and this is negative sign over here. And what about the intervals? The upper interval is 2 and the lower interval is 1. And there you go. This would be the answer. Let's see. Yes, that's the answer. So this is how we basically solve it. You can see 1.32 and it's approximated instead of 0 as 1. Okay, we have two more problems. I'll quickly do them, but right now I would highly encourage you all to solve them by yourselves. Here I'll write the formula afresh. It will be arc length, that's equal to integral a to b square root 1 plus f dash of x the whole square dx. Dx term will always be there in the calculator directly. Now let's find f dash of x from the given. It'll be 2x plus 1 becomes 0. This is the a value, b value. Substitute in the calculator. All you need to do is use this symbol here, integral symbol, and use the square root 1 plus. This much is constant. It will be the same for everything. Now here, what is f dash of x? It is 2x. 2 alpha x, close the bracket, square it. And the interval is from -2 to +2. That's the answer, 9.29. Sorry, 9.29. And another problem here, the same thing. Let's derive it. A value is -1, B value is +1. Formula is the same. What is the derivation over here? F dash of x will be 3x squared plus 0. So I'm not going to write plus 0 again and again. Use the calculator here. It's okay, I'll write it afresh again. Integral symbol here. Square root 1 plus, open the bracket, 3 alpha x squared. Close the bracket and square it out again. The interval starts from -1 to +1. That's the answer. Make sure everything, the interval, all this is clear, properly written, because if you do the wrong intervals, you're going to get wrong answer. I'll just show you. It's just going to, now if I flip this, instead of minus to plus and plus to minus, I'm going to get negative answer. Say this is wrong, okay? Now you must remember this was lower limit first, then the upper limit, that's the greater number, and it is 3.0957, and that's the answer. So this is how you solve the first topic. I hope it is clear. That was about estimating the arc length of a given function, easy one using the formula. We move on to the second topic, that is to find the limit algebraically or graphically if it exists. Here, there might be problems where the graph is given or you need to draw the graph by yourself and find it out. Anyways, the method, numerical method is same, algebraic just substitution, it's going to be the same because equations will be given. But when it's graph, you'll be only given this much and you need to find the limits at all these places. First of all, there are a few important things to know in this topic. Continuity is something that is like, a smooth curve and it's continuous, where you can draw a graph without moving your pen. Say, for example, a sine graph. It's continuous. Now, if you have a point like this and then a hole and then it continues the graph, this is not continuous. Or you can see there is a point over here and this, but that particular function is defined somewhere over here. There is a point over here. So say this is x value of 3. So f of 3 is defined at this particular point, but x minus value and plus value, if the limit x tends to 3 from the negative or the positive side will be different, whereas f of 3 will be different. So in such cases, the limit is having a jump discontinuity. It's kind of like that. But anyways, we will start solving these problems. You'll understand better. Limit as 0. See, where is 0? X is 0, right? That's the center over here. From the left side, that's negative side, means the left side. As x tends to 0, minus would mean from the left. Whereas if it was a right, as x tends to 0 from the positive means right side. Now, here it is minus. So just look at the left side part of the graph, left side. Where is it? It's over here. The answer must be -2 here. Why? Because it's at the left side. Whereas at the right side, if you see the right side, what is the answer? It's a whole, but the answer is 2. Okay, we are not exactly seeing this point, we are seeing this nearest point where it is corresponding or approaching. Therefore, what is the limit over here? Do we have a single point? No, we call it undefined. This limit does not exist over here, okay? Limit does not exist. So this is the answer. Now let's see another point, -2. What is the value from the left side? Whereas over here you can see left side is corresponding to 2, even the right side is corresponding to 2. Both of these are corresponding to 2. And what is the exact limit? It is 2 itself, because left and right limit correspond to each other. They are equal. Now g over here is at -1. The -1 is over here, it's at 0. And at 1, this is 1 from the plus side, it is also 1. So this is it basically. 1. Just see which point is asked, x value, and then look into the graph. These are the answers. You can see it's -2, 2, then 3 2's, and over here it was 0, and right side over here it was 1. This is how we basically solve it. Now over here I just realized h is -3. Let's just do this as well. What about -3? It's 1 also. So even 1 from negative side, from left side, it's the same thing. Even 3, it's 1. The answer is 1, doesn't matter. I mean, in this case, coincidentally, it's the same thing. But if you understand the method to solve, it's very easy. Now over here you have more problems. I mean, more same graph, but more different points. So please make sure you understand the concept of this being left side. If it's minus, it's being left side, plus is right side. Then it's very easy. So try these out by yourselves. You can pause the video and try it out by yourselves. I hope you got the answers right, which is very easy over here. 1 from the left side, x is 1. See this value, don't think this is -1, it's just this value. And then the sign tells you from the left or right. For 1, it's over here. So this is around 1 itself. This will be 1. What about from the right side? It's the same thing because it's continuous at this point. So it's also 1, and the limit exists over here at 1 itself. What about 2? 2 is this part, 1, 2. From the left side, yes, you have an answer that is -1 here. But what about from the plus positive side? It will be +3, isn't it? Right side, it's +3, and this does not exist. Limit does not exist. That's D and E. And what about 3 negative? Let's see, where is 3? 1, 2, 3 negative. It's somewhere over here, right? It's not so straight, but anyways, I think so. It's about half. I'm not sure. It might be 3.5 here. And what about -3? -3 is this. Let's. I think so. It is about -1. Sorry, positive 1.25, or nearly half, I guess. I'm not sure about this. It's somewhere over here in the middle. So these are the values. Just look closely. Whereas -3, draw a straight line. If you use a scale accurately and then draw a straight line here, you will get the exact point. Same thing over here. +3, this thing. Okay. You use a scale because you need to be accurate. Let's look. Oh, this is 2.5. Look over here. It's between 2 and 3. I don't know why I wrote 3.5. My bad. It is 2.5. This one. It's, see over here, I've drawn the line. It's between 2 and 3, so it's 2.5 clearly. And this is 1.5. I was not so sure because I thought it's 1.25. But if you draw a scale, draw it properly, you will get it correct. All the others are same. This is very, very easy and straightforward. This is the method if the graph is given, because you will have does not exist and everything. But if the graph is not given, You can sketch the graph later, but we can define them easily from the piecewise. See, they have given you identify each limit. So we will define each limit because over here it's given, right? So how do we do this is 2 from the left side. Now, what does this exactly mean? Let me just write it over here. This x tends to 2 from the negative side means left or less than equal to. If it's a right, this is minus. Plus means it's greater than or greater than equal to. Now, whenever you see 2 minus, where is x less than 2 here? Use this equation. So you will have to use 2, right? X is 2 over here. So 2 into 2 will be 4. This is the answer. Now, what about this right side? Here, plus means this equation, it's going to be 2 square. 2 square is 4 again. Doesn't matter. And what is the answer over here? See, both are same. So you directly write the answer. That is 4. You don't write undefined because it's the same. What about this one? Limit at 1. 1 over here, it will be 2 times 1. That is 2. So left side limit over here at x equals 1 is 2. Sorry. Okay, this is the answer. And what about the positive side? See, now over here, oh, sorry, 1 second. Let me just reiterate it because I saw this and I directly chose this upper value. Why? Because x equals 1, where does it fall in? Which equation? X is less than 2, right? It falls in the first equation. That's why I directly took this equation. But now look over here, 3. X is greater than or equal to 2, right? So 3 will fall over here. That would be 3 square is 9. So these would be the answers over here. You should know which equation for where depending on the x values. You can see the answers are 4, 4, 4 and 2 and 9. That's it. And this is the graph over here. You can check the graph as well. Graph is very simple. Till this point 2, there will be one graph that is a linear graph of 2x. Then it is a quadratic graph, x squared graph. Again, we have a similar problem, but there are 3 piecewise defined functions. That means there are 3 points over here, 3 different differently defined at different equations or different inequalities. Okay, so over here you can see less than, greater than, equal to also is meant. Let's solve them one by one. When 0, negative, left side, see all these are defined at 0. Yes, these points are 0, but which is less than 0 here? So all you need to do is put this as 0. Answer would be negative 1. Now what if it's a right side of 0? Then this is the answer, greater than 0. X is 0. 0 plus 1 root 1 is 1 minus 2. That will be again minus 1. Why? Because this is 0 plus 1. It's 1. Square root of 1 is 1 itself. Minus 2 would be negative 1. Now what about the limit at x equals 0? It's not negative 1, it's given as 0. So basically the limit over here does not exist. It can be a jump discontinuity because the graph over here, both the sides are coming. See, both the graphs are coming like this, but actually at 0 the point is defined at this particular value. Okay, here it is a hole. Then that is the thing. I don't know how exactly is the graph, but that's a rough denotation. Now, okay, let's just anyways, we will just continue from here. What about minus 1? Minus 1 will fall less than 0, so just put over here minus 1. It will be minus 1 cube minus 1. When you take odd powers of a negative number, the minus sign remains. You can put in calculator directly, but anyways, it will be minus 1 minus 1. This will be minus 2. And what about 1 from the negative side? 1 is x is greater than 0, this one. Just that you have to substitute over here. Square root 1 plus 1 minus 2. That will be square root 2 minus 2. Okay. That will be some value. Did I do anything wrong? That's it. I'm not sure about the question. Let me... Okay, see, the thing is over here. I'm sorry. The question is supposed to be positive 3, not 1 to the power minus 1 left side. This is wrong. It's supposed to be 3. Let's see when it's 3. This is not the exact question. I'm sorry for that. Now let's quickly look over here. If it is 3, that means it will be greater than 1. So it will be square root 3 plus 1 minus 1. What is square root of 4 minus 2? Square root of 4 is 2 minus 2, that is 0. So this would be basically last one. It should be supposed to be 3 over here. That's equal to 0. All the others are correct. Now we can see the graph. You can see over here in the graph. Now if you had graphed it accurately, I just knew the point 1 would be a hole. Why? Because I'm having minus 1 from the left side, minus 1 from the right side, but they are not touching over here, because when I substitute this x value here, I know that's 0. That means there's a jump discontinuity, because there's a hole over here, but the right side limit and left side limit are approaching that value, but this particular thing is at a different point. So here f of x is defined at 0 because it's of the jump discontinuity. And that's it for this topic. It's a very simple one. Please do go through more type of problems on the same topic, because the topics are same. It's just that you will have a different problem altogether. Try to find different cases. If you have any doubts or questions, please do ask them in the comment. I'll get back to you soon. We now move on to the third topic. The third topic is finding limits of polynomial, rational, and trigonometric functions using theorems. But this topic can be easily solved in calculator, and since it falls in MCQ part, that is question 1 to 15, I will solve it directly using calculator now. Your problems might arise like this. All you need is a scientific calculator, no need of writing anything. We can use this. Now, initially you might seem the direct method, the solving method is so easier than calculator method. But I'll tell you, if you learn the calculator method, it can be solved. It can be used to solve any of the problem. So let me take out the calculator. Now all you need to do is, the best and the easy way would be type this out entirely. Okay, type this equation. Now this is a polynomial equation, so that it is continuous everywhere. You can just substitute the value, but instead of that, let's type it out. Alpha x, sorry, it's over here, alpha x squared minus 3x plus 1. And now what you need to do is remember to check. See, they have told indicated limit if it exists. That means you need to check for the left side limit and the right side limit. What does that mean? That means, say for example, this example, limit x tends to 0 from the left side and limit as x tends to 0 from the right side. Okay, these two conditions must be met. They must be equal. Then you can tell that is the answer. Now also there would be another thing, that is f of this particular x value, but this will be true in all these cases, so no worries. So all you need to do is just focus on this much, okay, and then that indicates whether the limit exists or no. Okay, so now what we do is we just substitute. I'll just erase this one, and now here you've done the x part, right? You have put all the given equation, given function over here. Now press calc. What does that calc do is, it will allow you to put any value for x and calculate. That is calc. Now it is 0. In this case, because it's polynomial, it's fine to put 0, but otherwise you should not put 0. What you need to do is, you should put a value which is left of 0. That is very, very close to 0 in the number line. If this is 0, this is 1, this is negative 1. What is very close to 0? Not negative 1.5 or not positive 1.5. You can say 1.1 is very close, but I'm so sorry, it is 0.5, 0.1. Here, the closest value would be something like 0.0001, isn't it? Same way, left side would be negative 0.0001. So select one of those values. I will put calc, since I'm starting from the left side, I'll put negative 0.0001. Okay, press equal to. What's the answer? It is almost 1. It's 1.00. Just consider the whole number 1. Now press calc. Do it from the right side. 1.00. Sorry, it's 0.001. It's just 0.001. And what's the answer? You got 0.999, which almost corresponds to 1. And so you can see the answer is 1. But since it's polynomial, you can directly substitute and still get the answer. It's fine, but not in other cases. Let's do the same method everywhere now. All you need to do is put this equation. This is a cube root. So you can either use shift and this symbol, or since it's cube, power 3 is already directly available, shift and this symbol. Now you need to press 2 alpha x plus 1. And what do? Calc, instead of 2, take two values which are very close to 2. So if it's 2, the closest values to 2 would be, from the left side would be 1.999 and from the right side would be 2.001. Okay, so these are the two very close values. And now just press calc. I pressed already calc. What is the x value? It's asking me what is the x value. Let me start with 1.999. What is the answer? It's 1.709. Let me check the right side as well. Calc 2.0001. It's the same thing. But what if this particular option is not there? Your option like this. Don't worry. Now this, it's very, there is one way, I think so it might work by pressing calc, and you need to press like, 1 point, a lot of nines. In sometimes you get it as fractions, sometimes. But in this case, it's not going to be. So what you do over here is, you should write this number down. Say, write it just over here. 1.7099. Don't think your answer is wrong. Your answer is correct, but just that it's not in the correct form. What you can do is solve all the 4 options. Use this. Shift 3 and now 5. What is the answer of that? Cube root of 5. It is the same thing. 1.709975 and so on. You will get the exact same value, but you won't get it in terms of radical form. You will get as decimal. So write the answer and check all the 4 options. One of the option will definitely match, and that's your answer. Now let's do the same thing here. Type this, cos inverse, shift and cos. Now what about x, alpha x square, and then close the bracket. Look, the square is inside the bracket. Now if you press calc, I will get wrong answer directly because it's in degrees. So change it to radian, shift 4 and mode and 4. Now it's in radian. Press calc. Don't go to 0. Take a value which is very close to 0. That is negative 0.001. It's 1.5707. You might recognize this value directly. 1.57 is pi by 2. Okay. And now let's take another value that's positive. That is 0. You can take many zeros, and that time sometimes it will show as pi itself. Okay. So you can see it's half pi or pi by 2. So the answer over here must be pi by 2. Similarly, you can do this one. All you need to do is type this equation as it is, alpha x minus 5 divided by alpha x squared plus 4, and then calc at which is close to 2. You have here 1.999 and that is negative 0.375, and also do right side 0, sorry, not 0, calc at 2.00001, and you're getting, okay, what did we get? Did we get the same value? Let me just double check. Oh, it's negative 0.375. Let me press calc and go to the left side, 1.99999. And yes, we are getting negative 3. I thought it was positive in the first case. Both the cases, it's negative itself. Yes, it exists, and the answer is, now again here, we don't have the fraction. We have negative 0.375. What you do is write this out down somewhere and then check for the answers, all the options. Negative, it's the same. Just check for the 3.75. We know it's one of the negative answers. Just 3 divided by 8 must be 0.375. And that's the correct answer. So that's how we choose it. Now, I'm sure you know this by now. You can try the remaining problem by yourself. It's the same thing till the 28th problem. So you can stop watching the video now and you can just pause the video and solve these by yourselves using your calculator and check the answers. Also, I've already told in the first introduction video, you can get the presentation from the link over there. You can check the presentation from the link, download it, and try to, go solve all these problems. The answers are there, but you can just check for the questions. Just look at the question, try solving it by yourself. Now, I will be solving all the 28 problems, but it is not recommended for you to just watch. If you have already understood, solve them by yourselves. Now, we will continue over here. The fifth question, limit is 3. So what do you need to do? First thing, I will write this x value down, 3, and it goes, what's the closest value? It's 2.999 and 3.001. All that requires over here is substituting this value. It is alpha x squared minus x, that is over here, and minus 6 divided by alpha x minus 3. Now you need to press calc and type in 2.999, and the value is very close to 5, so I'll just consider it 5. But let me check it on the other side as well. And yes, it is 5.001, that is 5. So the answer is 5 here. Let me just write it out here. The limit would be equal to 5. Both the sides must exist. Both the sides, sorry, must be equal. Only then you get the answer. Here also, let's do this quickly. Here we have, I'll just change this. It's plus 2. That is, sorry, alpha x squared minus 3x. Let me change the above as well. It's minus 2, and this will be plus. Just be careful when you change. What I did was just to save time, but it's just that me being lazy, I just wanted to change it rather than type it out entirely. So be careful, double check it in your exam. If you're doing that, just double check it and make sure you're getting it correct. Now what you need to do is see what is 1. How can you write 1? You can write it. The closest value would be 0.999 and 1.001. And here, calc 0.999. What's the answer? It's negative 3. And let's check the other value as well, 1.001. Yes, it is negative 3 itself. So that's the answer. The answer over here is negative 3. Here again, it's 2. So 2 would correspond to 1.999. That's the lower value, and 2.001. Now remember, when it is 0, it will be negative 0.001 and 0.001, which is positive. Only when it is 0, you get negative and positive, because it's in the middle, it's neutral, right? It's in the middle, left side, right side. But all the others, you will have 0.99 or 1.999, and one more will be 001, because only 0, it will be 0.001 and negative and positive. That's it. So over here, all you do is substitute again. So it is minus alpha x squared, down it is x squared minus 4. So all you need to do is put this as 4. Now calculate at 1.999, and the answer is 0.75. And same thing, do it over here. Calc 2.0001. See, the answer is 0.75. So very close to 0.75. If you put more zeros or more 9s, you will get 3 by 4. The answer over here is 3/4. Same thing, let's do the last one as well. I'll erase it. All you need to do is type it out as it is. X cube minus 1 divided by alpha x squared plus 2x minus 3. Make sure you type it correctly. If you do even a silly mistake, say minus to plus, then the answer will be entirely wrong. Now then, calculate at 0.999, and calculate, it's again 0.75 here, and calculate at 1.0. I'll increase the number of zeros here, so I'll get 3 by 4. So that's the answers. Both are 3 by 4. You can see it's 5, 3, negative 3, sorry, here, 3/4, 3/4. Similarly, we will go to trigonometric functions now. Again, if you have understood it thoroughly, please move on and try to do by yourselves. Otherwise, you can continue watching. I will start directly substituting in the calculator now. Here we have sine and tan. Doesn't matter. It's already in radians, so I will just use sine alpha x, close the bracket, tan alpha x, close the bracket. If you don't close the bracket, it'll be an error, syntax error. Now calculate at 0.001. Let me start with negative sign, negative 0.001. The answer is almost 1. And let me calculate it at 0.0001 positive. It's 1 itself. So the answer over here is 1. Next, we come over here with tan x by x. So again, tan x alpha x, close the bracket, divided by alpha x. Calculate at negative 0.0001. The answer is 1. And calculate, sorry, I took it off. Let me just put it out again. Alpha x, close the bracket, alpha x. And now do calc 0. We did negative, so I'll do positive now. It's 1. So this is also 1. Let me try this below 1. Doesn't matter how scary looking these equations are. All you need to do is just substitute them as it is. Everything is available in the scientific calculator. X multiplied by e, it's shift and ln, natural logarithm, to the power negative 2 alpha x plus 1. Alpha x plus 1. And now you need to go to the denominator, alpha x square plus x. Okay, what next? That's done. Let us quickly check the calculate at negative 0.0001. The answer is 2.71. Can anyone think of what is this number corresponding to? Sure, some of you have told it in your mind. It is Euler's number, and that is correct. Let's see, 0.000, many zeros and 1. This is the Euler's number. It's 2.7182. It goes on. See, this is E. So when I look at it, I realize it's Euler's number. How do you check? You don't have this value, so you can just put alpha and this symbol E and check that is 2.7182818, and it goes on. So that is E value. Now, what about this problem? Here, we do not have cosecant, isn't it? What to do now? In such cases, it's very simple. All you need to do is type whatever is easily typable, that is alpha x squared, multiplied with, we know cosecant, that is cosecant. Sorry, let me write over here. Cosecant is reciprocal to what? Is it reciprocal of? That is equal to 1 by sine x. If it is c, it is reciprocal with s. If it was secant, it is reciprocal of 1 by cos x. So that's the thing. Now all you need to do is 1 divided by, instead of cosecant, put sine x. That's it. Now this is very important where it is squared. Look at this. This square is for the trigonometric function. It's not to the x. This means you need to put the bracket around the entire trigonometric function. See sine x, then use the brackets and then square it up. This is how we write this out. Now calculate. It's in radian mode, so calculate at negative 0.0001. What's the answer? It's 1. Let me calculate it at positive 0.0001, and again it is 1. So that is the answer. So it's very, very simple. You should just remember what is cosecant. Cosecant is 1 by sine. Then all you need to do is put it out in the calculator and solve it. If it was cotan, then it was 1 by tan. If it was secant, then 1 by cos. That is it. And the square is for trigonometric function, so it will be for the entire term. Now we have more problems. Again, I will repeat. If you know this topic, please stop over here. Do it by yourselves. You can see this. You can just forward the video. But if you are still confused, then do keep watching it. All we need is the calculators. Just type it out. Square root alpha x plus 4 and take it out, minus 2 divided by alpha x. Now here calculate at x 0.0001. Let me start with always minus. I like to go from the left side to the right side. It's 0.25, it's a quarter. Now let me start take the positive value 0 point. Also, you can directly do 1 into 10 to the power a few, oh sorry, it should be 0 point, okay, 0.1. No, no, just ignore what I told. What I meant to say is you can use this over here, 1 into 10 to the power minus 5, okay? But if you're getting confused, I just now got confused. I'm sure some of the students might get confused. You can use it if you're very confident with the scientific numbers. It's very easier. But otherwise, you can just type it out 0.000. And now here you go, it's 1/4. Let's do the right side as well directly. Type it out, 2 alpha x divided by 3 minus square root alpha x plus 9. And now what you need to do is calc at 0.00. Again, I forgot the minus sign. You can do even the first positive one. Let's just do this first. It is how much? It is 12, minus 12. Don't forget the negative sign. And now we will do from the left side. Calc minus 0.00001. And it is minus 11.9. And that's negative 12 itself. So here we got 1/4. Here we got negative 12. More problems, I'm sure you must be used to it now. I will just do till the 28th problem. If you're thorough with it, please do skip it up and start solving by yourself. It's alpha x by root x. Okay, I've pressed two roots, sorry for that. It's only 1 root x minus 1. Here calc 1 will be 0.999. The answer is 2 because I can easily see it's 2. And then now calc 1.001. What is the answer here? It's again 2. 1.99 and 2 are the same thing. Let's do the right side one. It's alpha x cube minus 64 divided by x minus 4. And now you should just do calc at 3.9999 and the answer is 48. Let's do calc at positive value, that is 4.00001, and yes, it's same answer, 48. So both the answers exist. It's 2 and 48. I hope you are well used to it now. Let's do it over here. Use the brackets. However is the question, type it out exactly like it is. Alpha x minus 1 minus over here now 2 divided by alpha x squared minus 1. Now close the bracket here. Calculate at 0.999. The answer is 0.5. That's 1 by 2 half. Let's check the other side as well. 1.00001. Okay, what happened? Calc 1.0001. Okay, it's 0.5. I don't know what happened. Maybe a lot of zeros will not give you the correct answer as well. Let's just check this out. Yes, it's half. So just be careful. Let's just try it again. Why didn't it show up just now? Okay, see, that's the thing. Don't put a lot of zeros. So start with, limited amount of zeros, check it, and then you can extend it. But anyways, the answer is 0.499. That's 0.5, which is corresponding to half. Let's try over here the next problem. 2 by alpha x minus 2 divided by magnitude x. Now, how do you get this magnitude symbol? That's absolute value. That's shift and this symbol over here, okay? Shift and HYP will give you absolute ABS. That is the absolute value, 2 lines, alpha x. Now, everything is there. So all you need to do is calc at negative 0.0001. What's the answer? Negative 4000. Okay, this is going to be negative infinity. Let's try the other side now. Calc at positive 0.001. It's going to be 0. Okay. Oh, wait. It's undefined over here. Okay, why did I... it's basically undefined. See now, over here, what happens? Sorry. No. I just got confused again. Let me just try it again. 0.001. What is the answer? It's 0. Let me try it at the negative 0.01. Okay. At one side it goes to negative infinity, one more side it's going to 0. This is undefined. You can see the limit from the right is 0, but from the limit left does not exist. Why? Because it's negative infinity, right? It's undefined. Okay, that's the thing. Only when the limits are same on both the sides that will exist. In this case it did not exist. Now let's try this one as well. 1 minus shift and this natural logarithm symbol, power 2 alpha x divided by 1 minus e to the power x, and x value is what? 0.001. I'm doing the positive side first. It's 2. Let me calculate at negative 0.001, and again it's 2. 1.99 is corresponding to 2, so the answer is 2 here. Very straightforward. Now we will do these problems. Here again all you do is press this symbol, shift and this hyp, and you're getting it alpha x and close the brackets divided by alpha x. What about now? You need to press calc and 0.001. The answer is 1. Now, okay, which side did I do? It's positive I did. Let's do negative 0.00. Okay, in the negative it's going to be negative, I believe. Yeah, it's not going to be same. It's negative 1. Why? Because look here, it's 0. So minus and plus, this will be changed, right? It'll be minus plus. But up over here, what happens? It's going to be a plus all the time. Because this absolute means even if it's a negative value, it will be positive answer. So over here, it's minus 1 plus 1. So limit does not exist. See, this property of absolute value is, if you have any value, it's the same answer. But if you have a negative answer also, it's the same thing. It's just the distance of that value. It's the quantity. They don't consider the sign. So therefore here the limit does not exist. You can see it's left and right. It's not equal. So therefore limit does not exist. Now we have a piecewise equation. I hope you remember this piecewise. What do we do here? Here it's 2. It's defined and they're asking us to define it at 2, right? Find the limit at 2. So don't use the method we just now did. You can, but it's just that it's very simple because there are two different equations. You're not going to use the same equation both the time. Sorry. Here, when it's less left side, I'll write it out over here. When you're finding limit as x tends to 2 from the negative side of f of x, you need to use which equation? This equation, 2 into x. When you're finding the limit of x as it tends to 2 positive from the positive side of f of x, then you have to use the second equation, x squared. Is that okay? So now what I do is I will substitute 2 into x value is 2 itself. I know this is a polynomial, it's defined everywhere. So even if I put this value, you're not going to get an undefined answer. It's 4. The first is 4. What about the second one? Square is also the same thing, right? 2 squared is 4. Yes, the limit exists. So this is the answer. Now, if you're wondering, why do I not put the value directly of x value and find it out? Let me show you. Look at this example. It is sine alpha x. Instead of shift modulus 0, instead of x I'll put 0 because that's what they asked. Let me close the bracket, divided by 0. Now look over here, if you are dividing anything by 0, it's infinity or undefined, so you're not going to get the answer. But if I just change it to near value to 0, 0.001, and same thing up above, 0.001, you're getting some value. So this is the reason we take limits which is very close. This means x approaches 0, but it's not equal to 0. It's very, very close to 0. Okay. If it's negative over here, means it's from the left side, positive is from the right side. Again, few more piecewise equations. Let's quickly solve them up. I'll directly solve them now. It's at -1. So just substitute this -1 over here first. It'll be -1 instead of x, it's -1 squared plus 1. You can definitely do x squared plus 1 and calc and do it. But since we are not going to change this value, we are not going to use this value again, I directly substitute -1. The answer is 2 here. What about the second thing? When I look at it, I can see it's going to be a negative answer. It's not the same, but because it's minus, so it'll be 2 into -1. plus 1. The answer is minus 2. It does not exist. Above was positive because there was square. The negative sign dissolves. Now let's think of the next problem. It's at minus 1. Again, it's simple, straightforward. When it is less than 1, all you do is 2 into minus 1 plus 1. It's a good habit to put the brackets, but I know it's going to work over there because it's everything, right? So, but anyways, it's a good habit to put the brackets. From x over here, this is the thing. Minus 1 is the answer over here. When it's greater than negative 1, it's 3. Can you see over here? So it does not exist over here also. Why? Because we found the answer over here was minus 1. But what is it from the right side? That means it's greater than, x is greater than negative 1. Your answer is defined. You don't have to substitute. It's already told it's 3. So at left side it's minus 1. Right side it's 3. It does not exist because these are not same. Don't be confused. Don't think, oh, okay, this is the equation, right? No, this is not. Look, they are asking at x of minus 1. So be careful. This is minus 1. This is plus 1. So you need to take minus 1 and minus 1. These two equations only. Now we move on to the 24th problem. Take out your calculators and let's try this. So here again it's at 1. Now let's see where is 1 exactly? At this point. At 1 it is 3. At the left side of 1, see, x is less than 1. That means you have to use this equation. One answer is 3. What about the right side? The right side of 1 is this equation. It will be 2 into 1 plus 1. It's 3. It's defined. Yes, this is correct. The limit over here is 3. See both the cases. 3 is given, but 1 more 3. It's 2x plus 1, where x is 1. It'll be 3. Now the next one over here, just that they have changed instead of x as h. Doesn't matter. All you need to do is type it out. Instead of h, you don't have the h symbol in this calculator. You just use it as a variable x. Okay, it's 2 plus alpha x whole square minus 4 divided by alpha x. And now calculate at 0.0001. I'm doing the positive side first. It's 4. Now let me do the negative 0.001. Sorry, it's 0.001. It's 3.999, which is also 4. So yes, the value exists over there. Let me try the next one. It is 1 plus x the whole cube minus 1 divided by alpha x. Calculate at, you can't directly substitute 0, it will be undefined. So we calculate at 0 minus 0.0001. The answer is 3, nearly close to 3. Let me calculate at positive side. The answer is again 3. So yes, the exists over here was 4, over here is 3. Okay. Now, next one again, last two ones, we'll directly do them. Sine alpha x square minus 4, close the bracket. Important to open and close the bracket properly. That is very, very crucial. And now this is the substitutions. Now all you need to do is calculate at 1.999, because 2 is very close to 1.999. We are getting 1 as the answer. And calculate at 2.0001. Again, we are getting 1 as the answer. Yes, this limit exists at 1. The last problem in this topic number 3, it's tan x, that is alpha x, divided by phi alpha x. And now what we do is just substitute. Instead of 0 as 0.0001, and the answer is 0.2. Let me substitute again over here as negative 0.0001. And the answer is negative 2. So here it was 1. Here it's 1/5. 1/5 is 0.2. And that's how we solve these problems. All the problems are explained in detail. I mean, sorry, not in detail, the calculator method. Since it is falling under the 15th topic, we can use the calculator directly and choose the correct answers. You will have 4 options. Choose the correct one. Please do try to practice more problems on yourself without help, and then check for the answers. And if you have any doubts, do ask them in the comments. I'll try to get back to you soon. We now move on to the question number 4, that is to determine the continuity of function at a given point. The first set of questions is to tell us, for us to explain why exactly it is not continuous. Now, the easy and the simple way is just look at the given x value. They're telling us why does the continuity fail? Why is the function not continuous at the given x values? If you substitute the x value over here, it'll be 1 divided by 1 minus 1. That means it's undefined over there. It's not defined. So basically, there is no point over there. It's undefined. Okay, it does not exist because it's not defined at this particular value of x. You can check the limit as well. Now, what about over here? If you substitute over here, it's discontinuous. You'll come to know there is an asymptote, vertical asymptote. So if there is, whenever the denominator becomes undefined, basically it's not continuous. That's it. That's simple as that. Okay, we are not finding the limit over here. It's not, our intention is not to find limit. Even if the limit exists, that doesn't mean that it's continuous. It's discontinuous because, there is a vertical asymptote. If you have vertical asymptote or jump discontinuity, then it is not continuous. Even over here 1 by x, what happens? It'll be undefined, right? And lastly over here, see, at x equals 0, what is e to the power 0? It's 1. So in the denominator, you do not even need to look at the numerator. This is fine. E to the power minus 1, there is some value. It is defined in the numerator. But denominator will be 1 because e to the power 0 is 1 minus 1, that's 0. So it's not defined. It's very straightforward, the first part. And over here now, they have given piecewise equations. That's fine. Now, how do you find the continuity? Basically, in order for a function to be continuous, I'll write it out over here. There are two conditions. First, the limit as x tends to this particular value 2 from the left side must be, this is f of x. Okay, must be equal to limit as x tends to 2 from the positive side for that same function. Okay, now this is the thing. And if this exists, this is true. If this is true, if this is false, over. It's not continuous. But if this is true, then it whatever we get, right, the limit as x tends to 2, it will be the answer. If this is all, see over here. Now, as limit 2 from the negative side less than, what is the answer? X squared. So let's substitute over here x squared. Instead of x, we have 2. The 2 square value would be 4. Same thing, from greater than, plus means this one. Let's substitute over here as well. 3 into 2 minus 2, that will be also 4. We got 4 and 4. Therefore, what is the answer? Limit f of x would be 4 here. But this is not over. This must be equal to f of this given point, f of 2. See, whatever the limit is there, right? This is the y value basically. This is the y value. If there's a graph, you're going to get, now imagine this is the graph, just a rough figure, it is not correct. But anyways, so imagine like this. At 2 it was. So imagine this is x equals 2. This point is at 4. Okay. Now, what happens? F of 2 means you're finding what is the y value directly from the function at the x value 2. It must be same. It must be coinciding with this. Otherwise, it is not continuous. That means otherwise there's some jump discontinuity, Now look over here. F of 2. What is the function f of 2? F of 2 is given as 3 here. Can you see? At x is equal to 2. What is the answer of the function? It is 3. Which is not equal to 4. Therefore, it is not continuous. This, yes, over here it's correct. Very good. The limits are true. It's 4. But look at the function. At 2, it is not. That means, now imagine the function is something like this. At 2, right? So I will consider this to be the point 2. Here you can see the graph is coming something like this. From here also it's coming. But this is coming at 4. Look, this is the value of 4. But exactly when you reach this point x equals 2, there is a hole over here. Why? Because the point of x equals 2 is at 3. This is the answer. There's a jump. So this is the answer. So this is what this particular graph would mean. Because from left side, you're closing in on the value number 4. Right side, yes, 4. Limit exists. But now, because we have been given at exactly f of 2, what is happening? The value is 3. It's not 4. Here we get 4. Here we get 4. But you can see over here it is 3. It's not 4. Therefore, it is discontinuous. I hope that is clear. You can see here left side is 4, right side is 4, but at that particular point it's 3. Now, the limit, this limit at x equals 2 is not equal to f of 2. Therefore, it is not discontinuous. Now, what about this one? Okay, you have less than. Let's substitute over here. So if you're finding the limit, same thing, limit x2 minus, that would be, substitute over here, 2, it'll be 2 square, that is 4. Here it'll be 3 times 2 minus 2, that is also 6 minus 2 is 4. Yes, but did they define anywhere it's less than or equal to here? Can you see, is it less than or equal to? No, that's never defined. So that means we cannot tell, we don't know this particular part. See the middle part, right, which was given, that's not at all there. So we don't know. It's discontinuous because it's not at all defined at this particular point. So we cannot conclude it as continuous. We just tell it's discontinuous because it's not defined at x equals 2. That's the reason. So we cannot find f of 2 in this case, in the second problem. Now comes the interesting part. Okay, we need to find the intervals where they are continuous. I realize that the answer over here is kind of wrong. It's a closed interval over here. This is also closed interval. I just realized it. But anyways, now let's see how exactly we solve it. See this particular part, there are many ways to solve it. There are theorems, use the theorem again and again, check whether it's continuous, like long theorems, you know. But what I would suggest is, I usually follow this method and it works almost all the problems. So look at the question and understand the question first. We will do this first. Is there any denominator? No, it's just a square root function. It's just a square root function. So just focus on its domain. What's the domain? Greater than or equal to 0, because this particular function will be defined at the corners. In fact, to find continuity, there are two separate theorems. There are things you need to memorize. If it's polynomial continuous every way, if this is the case, it's greater than 0, then you need to use another theorem and check the limit at both the sides. Now imagine this, you must check these 2 points. Less than, if it is, valid over here and over here, then we will use less than or equal to. It will be a closed interval, otherwise it's an open interval and all that. It's very confusing, but now I'll just directly tell you a shortcut method, because anyways this will be MCQ, right? What you do is look at the function. If there is no denominator, just like this, consider the inner part, just find the domain of this. X plus 3 must be greater than or equal to 0, isn't it? So x, 3 goes to the other side, must be greater than or equal to minus 3. So it will be negative 3 comma infinity. That's the answer. It is continuous over here, all this part. But what about elsewhere? So now this over here must be, sorry, let me just go back over. It must be a closed interval here. Now what about that's the thing. What about the other parts? If it is less than negative 4, say if it's negative 4, let's substitute over here. Square root negative 4 plus 3, what happens? It's a root of negative 1, which is an imagined number. It's not in the real number domain. So this is the thing. The second problem, how do we do this? I hope you remember how to solve the squares. This was taught in grade 11. You can see some of the videos in grade 11 term 1, because I have already explained this. You can find detailed explanation of that. Grade 11 term 1, you have to study this about inequalities. Okay, how you basically do it is, whatever is inside the square root must be greater than or equal to 0, right? Okay, that's fine. Now, how would you solve this? You cannot directly take this to the other side and solve. It would be an error, because you will have two values. You won't understand that exactly. So what you do is, you solve it as equating it to 0. So you equate x square minus 4 to 0. You can use quadratic mode phi 3 in your calculator and solve, but since this is a perfect square, I'll just take 4 to the other side and now take square root on both the sides. What am I going to get? I'm going to get x equals plus or minus 2. So this is the answer. Now you need to draw an interval like this. You need to draw. So it should be proper. Okay. And what are these points, x values you found out? See, there's no denominator or anything. It's just these values, minus 2, 2. Now, these are intervals. See, from here to here, it's all the values between minus 2 and 2. If it's over here, it should be less than minus 2, that is up till minus infinity. And if it's greater than this, it's positive infinity, okay? Now, these are the cases. Here, you need to choose some test values. Whenever you have 0 as a test value, where is 0? It falls over here. Choose that. Even you can choose 1, 2, 3, anything, it's fine. It will be the same thing, okay? Here, choose a small value. Don't go to big values. I usually choose just next to these, okay? Even if I take 100 or 1000, I'm going to get the same concept. It's going to be either true or false. It's going to be same, any number. I'll show you also in a while. So now this is the diagram. Here, these are the test values. What are you testing? Since it's inequalities and since there is square, we are not sure which interval is true. So we use this given question to test the values now. What do I mean? Whatever is inside the square root greater than or equal to 0, right? This over here, let's take it. X square minus 4 must be greater than or equal to 0. Now apply this test value over here. I'll put this test value inside x instead of x. I'll put this 0 minus 4. 0 square is 0, minus 4 greater than or equal to 0. Is it true? Minus 4, is it greater than or equal to 0? No, it's false. Wrong. Same thing now. Try the other test values. Let me put minus 3 instead of x square. I'll put minus 3 the whole square minus 4 must be greater than or equal to 0. What about minus 3 the whole square? It will be 9 minus 4 greater than or equal to 0. Yes, phi is greater than or equal to 0. This is true. What about the right side? It's going to be same because you know if you substitute positive, negative or positive 3, when you square it, it's going to be positive. It's going to be 9 minus 4. But now what if instead of this, I'll take another value, test value. Anything greater than 2 is open to test. So I'll choose a test 10. Why I'm doing this is I'm just proving that you can choose any value. Once you find the x values, you can choose any point in this range from 2 to infinity. Because there are only a 2x values, plus or minus, minus 2, 2. So you'll get 3 regions, 1, 2, 3. Any single point within this, even over here, you can take it as 1. So if you put 1, it will be 1 square. 1 minus 4, it's minus 3. It's not greater, it will be false itself. Now, last one over here, let me just take 10. The whole square minus 4 must be greater than or equal to 0. 100 minus 4 must be greater than or equal to 0. Yes, 96 is greater than or equal to 0. True. Now, why do we do this is to find what is the intervals or the domain intervals. Now, basically what we found is all the intervals over here is true. This is wrong. This is true. That means the answer for this basically is from minus infinity to minus 2. Now, since it's greater than or equal to, we use the close bracket, and from positive to infinity. Whenever it's infinity, we always use the small bracket, that is open interval. This would be the answer. You can see over here, I apologize again, it should be closed interval, big brackets. The intervals are very, very crucial. Closed interval over here will be like this and like this. I hope this is clear now. So that this concept is really important. Okay, now that's how we find the test values, and that's the thing. But always remember, when you have x squared minus 4, because this might come often greater than or equal to 0, remember it's all the values less than negative 2 till infinity and from 2 to positive infinity. Anything within this does not work. Okay, now what about a cubic? See, cubic, it's literally all real numbers. You don't have to worry. Now, only when it's square root, it's a problem because there might be some values like negative values, you can't get a square root, right? But if it's cube root or any odd power, if it is 5, 7, 9, then it is all real numbers. It's basically continuous everywhere. That means all real numbers, negative infinity to positive infinity. Whereas if it is even numbers, even power roots, 2, 4, 6, 8, 10, then you need to do this. Interval. You need to be cautious. It must be greater than or equal to 0. What about this one here? Now, this is again tricky. It's not tricky, sorry. Just rewrite it, arrange it and rewrite it. How do we write this? Whatever is down, that means that's the square root. What is down is over here. What is up is basically on them. We know for cube it's all positive everywhere. But what is the problem here? Since there is a square root, you need to understand that x minus 1 should be greater than or equal to 0. Okay, so this is the only concept over here. Now what happens? It will be greater than or equal to it's greater than or equal to positive 1. Yeah, minus, sorry, this is minus 1. Take it to the other side, it will be positive 1. Here just remember, if there is nothing, that means there's 2. Okay, this 2 I mentioned because it's given over here, but if it's nothing, it's already 2. And also you can write this x plus 3 whole power half. That's the same thing as square root. So that would be the answer for this one. It's basically, take this x equals to 0, I mean greater than, you just take it to the other side, becomes positive, so it's 1. Now sine inverse, this is a bit tricky. What is the answer for sine inverse? First of all, what is exactly sine inverse? Now we know sine theta, right? Say sine theta is equal to any value. Let me take it as x plus 2. Okay. If you take sine inverse on both the sides, sine inverse sine theta, that is equal to sine inverse of x plus 2. Okay, this cancels and theta equals sine inverse of x plus 2, isn't it? Now basically whatever this you see over here, x plus 2, is equal to sine theta. Why? Because now if you understand like this, because whatever is over here, imagine it is equal to sine theta. Now take sine inverse on both the sides, this sine cancels, you're remaining with theta and sine inverse of x plus 2. So this is the thing, so what this value is, x plus 2, is basically equal to sine theta. So what is the domain of sine theta? Sine theta graph, we know it's like this. It starts from 0, it goes on like this forever, right? Now here from 0 to 2 pi, it's the period, but that's all not required. What we know is the range. What's the maximum and minimum value? It's plus 1 and minus 1. So the range is always given. Sine theta can only have answers which is less than or equal to 1 or greater than or equal to minus 1, right? That's the thing. Now here, what is the thing? We have, instead of sine theta, x plus 2 less than or equal to 1, less than or equal to minus, greater than or equal to minus 1. Now we need to find the x, right? What is happening for x, not only not x plus 2. So we know this will be within this range. So what you do is just subtract 2 everywhere. Why? Because I want for x not exactly x plus 2. So what you do is minus 1 minus 2 less than or equal to x plus 2 minus 2 less than or equal to 1 minus 2. What's happening here is minus to minus 3 less than or equal to, this cancels, you're remaining with x less than or equal to minus 1. So this would be your answer. It is in the range minus 3 to minus 1. Can you see that? Continues on the interval. So whatever happens, remember, whatever is the sign, when you have sine inverse, even for cos inverse, it's the same thing because it's always 1 to negative 1. Just whatever is given over here, you need to put like this. This value in the middle, It should be less than or equal to 1 or greater than or equal to minus 1. And then you need to solve for x, find x. Now here, since it's plus 2, you need to subtract everywhere by minus 2. Directly looking at this, I can guess, okay, I know it's going to be, this is x plus 2. So subtract, what should I do to get x? I should do minus 2 on both the sides. So I know negative 1 minus 2 is minus 3, over here 1 minus 2 is minus 1. So that would be the answer. Now here it's closed brackets because it is less than or equal to. It's just all the domains, it's understanding a bit. Now what about this one here? Okay, this is a little bit tricky. Okay, I'll just try it anyways because it's sine inside of LAN. Now that'll be like periods and all that stuff. You should understand what's the period, where it is positive, negative. Anyways, let's do it now. I will just clear these other questions. We are doing the last one, 26th in this. Oh, sorry, it's not the last one. There's two more. But anyways, in this page, the last one over here. What we do is, first we need to understand where is natural logarithm defined. This value over here, whatever is the value, if it is x, should be greater than 0. It can't be 0. You can try, test it in your calculator. Take out your calculator, put ln of 0, you will get math error. If you put ln of negative 1, you will get math error. Let me just do it. Let me do it in the calculator and show it to you. Over here, this is the natural logarithm. Now let me put 0. What is happening? It's a math error. What if I take it to negative 2? Again, it's math error, any value. But what if it's positive? You have an answer. Okay, even if it's just teens a little bit more than 0, you have an answer. Okay, but if it's completely 0, no answer, it's math error. So that's the domain. Now that's why you should know it's not just greater than or equal to 0, it must be 0, whatever is the value. But now we don't have over here x. It's not x, it is what? It is sine x. So sine x must be greater than 0. I wish it was some x or y. It would be very easy. That's it. But now, when a sine x equals to 0, you need to find all the possible values when sine x equals 0, right? Because this is the domain. Now what you do is, let's see the graph again, sine graph. It starts from 0. It goes like this and it ends at pi. And then it comes down like this. It should be, same. Let me just try. Okay, still it's not the same, but anyways, it's 2 pi. Then again, it'll go up like this and it comes down. It's over here 3 pi. And then it will be 4 pi and so on. This is the sine graph. The difference between sine and cos graph is it's just sine starts from 0, 0, x is 0, y is 0, whereas cos starts from here and then it goes like that. Okay, let me just remove that for now. Now we're just dealing with sine. So this is the answer. Now what are the answers? This is our answer. See all this region, right? From 0 to pi, from 2 pi to 3 pi. But we can't keep on writing because it goes, see, 0 to pi, one answer. Then 2 pi to 3 pi, okay? Then what is the answer? It is 5, sorry, it's 4 pi. 4 pi to 5 pi. Then 6 pi to... It's crazy, right? How do we write it? We need a form. So what do we generally do is we don't start with 0. We use the coterminal. Coterminal angle is basically if you have, say, 0 degrees, add 360. Even minus 360, that's also a coterminal. That is 360 degrees. This is degrees in terms of radian. It is 2 pi, okay? Now here you can see this is 2 pi. We know this is positive. So let's use this as standard, 2 pi. Now I can't write 3 pi because that doesn't make sense, right? Because I can't keep on writing 2 pi plus 3 dash 3 pi like this. It can't be repeated. So let me write this also in terms of 2 pi. What I mean is, from here to where, again it's 2 pi plus pi. Is this okay? Why did I write like this? Because I know here, if I start at 2 pi, all the next values of sine until the next pi, that means 2 pi plus pi will be positive. So 2 pi to 2 pi plus pi. because this is positive. All the see now over here 0 to pi, right? So I should just do 0, comma 0 plus pi. But now this wouldn't be making sense because 0 is there. Now first value is like nullified. Now here it makes sense because now if I write say n and over here also n, what does this mean? 2 pi n, comma 2 pi n pi plus pi. Now this is my interval. This is the interval where which I want. What does that mean? This means that n is any integer. Integer why? Because integer is whole numbers like -1, 0, all negative and positive numbers, right? 1, 2, 3. Now imagine if I tell n is integer, then I'll just erase this. If I use any value, say I will use n as 0, then what am I going to get over here? N is 0, so it will be 2 pi 0, comma 2 pi 0 plus pi. So the interval would be 0 to pi. Yes, that's correct. Now what if I put over here 1? Then I'm going to get 2 pi, comma 2 pi plus pi. That is 3 pi, isn't it? 2 pi, comma 3 pi. Yes, that's correct. From 2 pi to 3 pi, it's defined. Now what about if I put 2 over here? Then I will get 2 pi times 2 comma 2 pi times 2 plus pi. That would be 2 pi times sorry, this one over here, yeah, it's done correct. This will be 0 0, yeah, and pi remain. So sorry, back over here, I just got distracted. 2 times 2 is 4 pi, and this is again 4 pi plus pi is 5 pi. You can see I am getting all the positive domain of sine x. So this is why I write this as this. Okay. Now, if you're thinking, how can I do it in short? It's just that don't start with 0, start with the. Now, you should see which is the first positive value. I know it's 0 and pi, right? So the coterminal for 0 is 2 pi. I know that. Why? Because you just add 2 pi, 360 degrees. That is 2 pi. So start with 2 pi till where it goes. From 0 till pi. See, how much is the distance from here to here? It's pi. So the next one will be the same thing, but you should write plus pi. And don't forget, the first part, only the first parts will have the integer. Okay, that is any integer. So this is how the answer over here should be 2 pi n, comma 2 pi. It will be like this. This is the answer. Okay, let's just check the answer. Okay, it's just given k over here. See, it's not integral, it's integer values. Okay, this should be integer values. I'm sorry, there are some errors in this. Integer, okay, integer. Now this is true. Why? Because this must be greater than 0. Sine x must be greater than 0. So you can't have a closed interval. Now, if you're wondering what happened over here, let me show you. What did I tell? It is 2 pi n, comma 2 pi n plus pi, isn't it? This is the answer. But here they have simplified it. Instead of n, that is k. That's fine. It can be any number. Okay, it depends on the option. It won't be x and y, but it will be a, b, like that. Generally, n or k is used. Okay. Now here, left side is same. 2 pi n. It's fine. 2 pi and k. Comma, here the pi term is removed common out. You're using distributive property. So you're remaining with 2n plus 1. Then what is removed out? Pi is removed out. But now look, if you multiply this inside, you're going to get the same thing. It will be 2 pi n plus pi. Now if you multiply over here inside, you're going to get same thing. It will be 2 pi k plus pi. That's the thing. It's distributive property. You're removing a common term out. Basically, that's called distributive property, common factor removal. That's the reason why it's like this. But remember to mention that k is integer values. Now you must select the correct answer. So that's the thing. That's about this. It's a bit lengthy. Like to understand each one, it's different. It's not the same concept over here. Now we go on to the 27th problem. Here, again, it is simple, it's straightforward. It's just that there are two things. One is the denominator, one is square root. I'm sure you know how to individually solve the square root, how to individually solve the denominator. Now here what you do is, see the square root, right? x plus 1. Whatever is inside the square root must be greater than or equal to 0, isn't it? So this is greater than or equal to, sorry, let me write it down. This term inside it, x plus 1, must be greater than or equal to 0. So x must be greater than or equal to negative 1. This is the continuity term. So it should be continuous anyway from negative 1 to infinity. I hope this is clear. It will be open interval for infinity. Now this is the answer. This is continuous everywhere. But look at the denominator. There is a denominator. Whenever the denominator is 0, it's undefined over there. That's a problem, right? So let me just erase this. See, the first part of the question is found out. But what about over here, right side? This is important now. Look at this. X squared minus 2 cannot be equal to 0. It cannot be equal to 0. Okay? So let's solve that. X squared cannot be equal to positive 2. Or what about x squared equals? X would be not equal to plus or minus square root 2, right? Take square on both the sides. It will be plus or minus 2. Okay, but look at the answer. It's only plus 2. Why there is no minus 2? I will reiterate this. What if I put over here in the denominator root 2, positive root 2 minus 2, it will be 2 because square root and this cancels, minus 2, that's 0. What if I put negative 2 root 2 whole square minus 2? You can try this in calculator. This cancels, but the square will dissolve this negative sign as well, right? So you will be remaining with 2 minus 2. What is the answer? 0. Then why don't we use it? Can you think for a while? Answer is over here. What is the value of square root? Square root 2, sorry. Okay, it's 1.4 something, right? I guess so. It's somewhere near over there. Oh God, I can't remember it exactly. Anyways, it's around there, I believe. Now, positive plus or minus means 1 is positive value. Now, negative root 2 would be negative 1.4. Negative 1.4 is not there in this interval in the first place itself. So that's why we have only positive root 2. That's the reason, okay? So don't consider it to be plus or minus. It'll just be positive root 2. Why? Because we already found the continuity over here. Whenever this should not be equal to root 2, okay? That's the thing. Just for understanding. And the last one over here. See, whenever I see squares, I know this over here. What is it going to be? It should be x squared minus 1 greater than or greater than only, not equal to, because it's natural logarithm. You can't have 0. It should be greater than 0. Now, what happens? Remember the interval. So looking at this, I know it's going to be x squared minus 1 equals 0, x squared equals 1, x is equal to plus or minus 1. Okay. Now here the two values, minus 1 plus 1. Let's take the test value 0. Let me take over here 2 minus 2. Let me substitute over here. First, let me substitute minus 2 the whole square. Sorry, whole square minus 1. That must be greater than equal to 0. What happens? Minus 2 the whole square is 4 minus 1. It should be greater than 0. It's 3. Yes, it's greater than 0. It's true. So this is true. I'll just put a tick. Next, put 0. 0 square is 0 minus 1 must be greater than 0. Minus 1 is greater than 0 is wrong. This is wrong. No, that doesn't work. Let's take the next one. What if it's 2 square minus 1 greater than 0? Yes, it is 4 minus 1 greater than 0. 3 is greater than 0. It is true. So these are the intervals, okay? So you can see it's till minus 1. And then, over here, I just forgot about the denominator. How can I do that? Now, anyways, let's just quickly see. I hope this is clear. The first part over here, we got continuity of, let me just write it, minus infinity to minus 2. Okay, this is open interval. And we got from 1. Sorry, this is minus 1. What am I doing? I'm just getting confused because I took, let me write this. See, this is the x value, right? It's still minus 1. And over here it is 1 to infinity. What about the other thing? This one also needs to be found out. This also needs to be continuous, right? Solve the same thing here in the denominator. But just be careful. It should not be less than or equal to 0. It should be only, sorry, it is not greater than or equal to 0. It is only greater than 0. Why? Because it can't be equal to 0. It will be undefined as well. So the same thing what we just now did, do over here as well. Now in there you will see that this will be removed. I'll just show you. See the first part, I'll just show the answer over here. This first part is correct. Now why this 1 comma infinity is not there, I will now tell you. Let me just write it out over here. It was minus infinity comma minus 1 and 2 sorry, it was not 2, it was 1 comma infinity. Now let me do this one. It will be x squared minus 2x greater than 0. So how would you do it? You can take it to the other side, make it equal to, or you can just use the calculator. It's much easier, right? So let me just use the calculator over here. I'm a bit lazy now. Here we have to just press mod 5 and 3, and now it's 1 minus 2 and 0, so that you know it's 2 and 0. Okay, we got the two values, 2 and 0. So let me use them. X is equal to 2 and 0. We have to do the interval 0, 2. This test value would be 1. Over here, what is the test value? It can take it as 3. Let me change the color, sorry, so it'll be much easier to understand. The test values are 1, 3, and minus 1. Now substitute these values in the inequality over here. That is this inequality, okay? So let me put minus 1 the whole square minus 2 times minus 1. It must be greater than 0. What is the answer here? It will be 1. Minus of minus will be plus 2 is greater than 0. Yes, 3 is greater than 0. It's correct. This is correct. Now let's go to the next one. 1 square minus 2 times 1 must be greater than 0. It's 1 minus 2 greater than 0. Negative 1 is greater than 0. It's wrong. This is wrong. Let's try the third one. Over here, I'll put 3 square minus 2 times 3 is greater than 0. It's 9 minus 6 greater than 0. Is it true? Yes, 3 is greater than 0. Yes, this is correct. So here we come to know one important thing. The intervals are from minus infinity to 0, but we already got the interval till minus 1. So look over here. Let me just write the intervals which works over here, and from 2 to infinity. Now compare, because both of them must match. You can't just take this one or this one. Now it's very close over here. See, minus 1 and 0. So if you remember in grade 9 in that inequality we graph, right? If you have two things, we used to do one thing. What is that? We used to see, compare. Okay, this is minus 1, this is 0. So from 0, it's the solution. But in this case, it's not like that. Here, we are very, very careful about which values we choose. Okay, that is very important. We can't choose, if over here, you can have anything till minus 1. And here the 0 value is not at all included, but here 0 value is included, which does not make sense. This is okay. Take the lesser value, because over here 0 is not included. Don't take this. Take this one. Why? Because over here they're saying all the values from here is possible. One more thing is saying all this value is possible. Now if you choose this answer, the minus 0.5 is not possible for this range, so it will be an error. So if you put over here minus 0.5, it will be an error. It is not continuous at that point. So don't take that overlapping. Only this region can be taken. Why? Because minus infinity to minus 1 is true in both the cases, right? Only this part you ignore. This part you ignore. That means we are not going to take 0. We are going to take this value over here. Now, what about 1 to infinity? Same thing. We have 1 over here. So imagine this is 1 to infinity, right? This is true in this case. But now in the next case, it says 0 to 2 is wrong. So 1 is not defined over here, but 2 to infinity is defined. So don't take this, because over here you can see 1 to 2 is undefined in the second part. So you just choose the second one. So the answers would be negative infinity and minus 1 and 2 to infinity. You can check over here. Yes. See, this is the thing. It's from minus infinity to minus 1 and 2 to infinity. That would be the answers. I know it's a little bit complicated, this part. I hope you'll get an easy problem, a direct problem. But if you get like this, try to do it when you have plenty of time. Don't spend too much time if you're getting confused on this. Try to do it for the last, but understand the domains. Whenever you see a square root, whenever you see ln, you need to know when it's a square root what. When it's square root, you must use greater than or equal to. When it is ln, you must use greater than 0, greater than or equal to 0. Now, what if it's in the denominator? Then it should be not equal to 0, okay? But now in this case, it's in the denominator, square root and denominator. So you can't use greater than or equal to 0. Why? It should be greater than 0, because greater than is fine. It can be anything greater than 0. But if you are writing this equal to, it would make sense. It would not make sense. It's undefined at 0. Denominator cannot be. So if you see square root and something over here like this, so in such cases it should be greater than. Otherwise, whenever you see square root, it's greater than or equal to 0, and so on. So you should just remember the domains. If it's sine, so we have already done that. So please make sure you understand that thoroughly, and then you can solve any problem. So that's the end of these topics. I know there were short number of topics over here, but they are a bit tricky. Please try to go through them thoroughly. And if you have any doubts, do post them in the comments. I'll try to get back to you soon. Moving on to the question number 5, it is to find the horizontal, vertical, and slant asymptotes using limits. Now, finding asymptotes can be done in various ways. If you know the conditions, you can find the horizontal asymptote, and there are other ways as well. But the best and the easy way is the limits method. Now we will see this. First, let's look into the horizontal asymptote, and then we will see it. See, I will write the conditions just for your general knowledge, because this might be useful somewhere else. There are 3 conditions to find horizontal asymptote. First one, when I will write an example, if the degree in the numerator and the denominator is same. Say the degree is 2 here, 2 here. Then the coefficients of the leading coefficient means the highest degrees term, whatever is before, the leading coefficient of the numerator divided by the leading coefficient of the denominator is where you will have your asymptote. So what is the coefficient here? 1, 1. So it's at 1. Let me change this. Let me write 3 over here, 2 here. So the answer would be the horizontal asymptote is given as y, because it's horizontal like this. So it's given as y equals 3 by 2 or 1.5. That is the first condition. Second condition is if the degrees in the numerator, say x squared minus 3x, okay, this is the degree, is less than the denominator x to the power 3 plus 2x. Here in this case, directly you write the asymptote is at 0, horizontal asymptote. Now look over here. The degree up over here is smaller than the below. Directly I know the word horizontal asymptote is 0. I will tell you the calculator method as well, but sometimes this will be much easier, so that's the reason. And lastly, the third one is when the degree in the numerator is greater than the degree in the denominator. Okay, this is the last case. Here there is no horizontal asymptote. So this is the conditions. Here no horizontal asymptote. Okay, here you just remember the degree above is greater than the denominator. In such case, there will be a slant asymptote, which we'll see in a while. Now these are the 3 conditions. But now there is one more way, easy way, that is calculator method. But those conditions are important. See, now if I know that condition, like these conditions, look here, I know the horizontal asymptote is directly y equals 0. Here, what about here? It'll be 1 divided by minus 1, because the leading coefficients are, degrees are same, so leading coefficient 1, and over here it's minus 1. That means y equals minus 1. That's the answers. But anyways, we will now see the calculator direct method. First of all, what I would suggest is don't go with horizontal first, go with the vertical asymptote. That's the easiest one, because vertical asymptote is directly got by this. Whatever is the denominator, make it equal to 0. It's the same, so I'll just solve once. Now put this, you can use mod phi 3 and solve in calculator. That is 4 minus x squared equals 0, or 4 equals x squared. Take square root on both the sides, you will get plus or minus 2 equals x. This is the thing. Otherwise, let's use calculator. Press mod phi and 3 and then put in the coefficient. Now first comes before x squared. What is before x squared? It's minus 1. Then what is before x? It's 0. And lastly we have positive 4. See, the answer is 2 and minus 2. This is one way. Now the next thing is, say over here they determine whether f of infinity. This is not required directly. I mean, they're not going to ask this, okay? Basically over here, this is finding the limits. Now whatever the answers you found out, put over here in this equation. See, we have done this in the previous question, the same thing. That is not finding the asymptotes, basically, because since you use calculator, that step is not required. It's only that you type this equation as it is, and you can't put 2. Calculate near 2. Say you put 1.999 and see what is it. The answer is, sorry, let me just check. What did I do wrong? Okay, I've forgotten the square here. Now let me calculate at 1.99999. The limit, see now here, if I'm writing this, the limit as x tends to 2 from the negative side, because I used 9.9999, 1.999 for this function, okay, f of x is infinity. This is it. But this is not required, because over here we are mainly focusing with the vertical and horizontal asymptote. So first thing, vertical asymptote, plus or minus 2. You can see here, that's it. That's the thing. Now this is not so important, but now the next thing is finding the horizontal asymptote. I'll teach you a shortcut. You need to type this equation. Now remember, let me just draw a graph first of all. When the denominator is 0, it's like having a straight line, isn't it? When the denominator is 0, okay? Now, when you consider this x to be infinity, let's take x as big number. Let's see what's happening. It is going towards the right. So it tells us what is happening. That is the asymptote. That's the horizontal asymptote. When you extend this x into infinities, you're going to get horizontal asymptote. So what we do is we'll calculate x as a big number, 9999. This is positive infinity. Now what is this answer? Minus 1 into 10 to the power minus 15. That means it is, sorry, let me write it over here. It is, negative doesn't really matter here. It is 0. There are 14 zeros. There will be 14 zeros, and then, okay, I lost count anyways. It will be many, and then it is 1. Okay. This is equivalent to 0. So that means it's 0. Okay. The horizontal asymptote is 0 over here. And don't do only for 1. We did calculate for 999 positive infinity. Now do for minus 999. That's the negative infinity. Again, we are getting 0 itself, because 10 to the power minus 13 means there are lots of zeros. So you can consider the horizontal asymptote is at 0. That's the answer. When it's at 0, or I've told you, when the numerator degree is less than the denominator, it's always at y equals 0. So that's how we solve it. Now look at this part, problem. Second part. Only the thing is it's x squared. So just change it over here to x squared. Okay. Now I'll calculate at a big number, infinity, positive infinity. What is the answer? Minus 1. Calculate at negative infinity. What is the answer? Minus 1. So y is equal to at minus 1. Okay. Now here the denominator, the same part over here, the above first part. X is at plus or minus 2, and that's it. Now, here we have only one horizontal asymptote. Okay, there is, see now, this has a square root. So here it changes. First of all, let's find what is the horizontal asymptote. Step one, sorry, vertical asymptote, vertical, the denominator. Make this denominator equal to 0. Okay, so it will be square root 4 plus x square equals 0. Square both the sides, it will be 4 plus x square equals 0. Now, what you need to do is take this 4 to the other side, it will be x square equals negative 4. Look at this. Can you square a number and have negative sign? This is wrong, undefined. It's a math error. Now, if you take square root on both the sides, here it's imaginary number. That means there is no vertical asymptote. Whenever you can't solve a problem, look over here. Can you take negative this one? It's a math error. Or you can just type this equation out. Alpha x square equals negative 4 does not make sense because it cannot be, square cannot be a negative number. It will be a positive number. Okay, it can't be solved. So here there is no vertical asymptote. Can you see there is no vertical asymptote? But what about the horizontal asymptote? Let's try. Type this equation. Alpha x divided by square root 4 plus alpha x square. That's it. Now calculate at infinity. Positive infinity, it's 1. Let's do negative infinity just to double check. Since there is square root, it might be 2. See, it's minus 1. So there are two vertical asymptotes. You can do this method, but since it's MCQs, I'm telling you the shortcut now. See, plus 1, minus 1. These are the horizontal asymptotes. Now let's do the next problem as well. Here, same thing, but only it's minus sign. Let me just check. Calc at 99999. Okay, if you're getting a math error, that means it does not exist. Let us check this one. Minus. Okay, yeah, it does not exist. There is no horizontal asymptote. But what about the vertical asymptote? Oh, I forgot to do that. Here, look, here it was plus, so it will be not there. But here, 4 minus x square equals 0. This is x equal to 0. You square both the sides. The square root cancels. Okay, when you square both the sides. And 0 will be 0 only. Now take x to the other side. 4 equals x square. Plus or minus 2 equals x. So the vertical asymptote is at plus or minus 2. Okay. X is at plus or minus 2. That's the thing. And now the problems are the same thing. Please do try it by yourself. The remaining ones are the same. Just type it out. First, whatever is the denominator. Here, if it's too huge, don't worry. Go mode. Just press mode 5, 3. Whatever is the denominator, put it over here. It's 1 minus 2, the coefficients of each term, in the standard form. Standard form is highest degree first, next the lower degree, and then last the constant. Now this is the answers, 3 and minus 1. So the vertical asymptotes are at 3 and the vertical asymptote is 3 and minus 1. You don't need to write in detail like factoring out. No, direct answer, because this is an MCQs. And what about the horizontal asymptote here? Okay, first of all, if you look at this, the degrees are same. See, I personally, right, I don't do that. You putting this, making to infinity checking. I just look at the degrees over here. X square is the same, so it is coefficient 3 by 1. Answer is 3. But the calculator method is the same thing, okay? But it's, calculator method is easy because you do not require to remember all the 3 conditions and everything. So please do solve the others by yourself. Please do try this by yourself. You can pause it and solve and then check the answers. So here's the answer. Even these are the same thing. Here's the answers. Okay. Now, wait a minute. I just realized these two are different. The previous ones are same. Okay, we will do this. I thought 23 to 28 will all be same. We'll quickly do this. The method remains the same, but only thing is here, you should know how the graphs are. Do you remember how is tan graph? Tan graph is something like this. You have asymptote every now and then, like, okay, that's very wrong. But anyway, something like this. You can use Desmos to see it. But The tan inverse graph is something like this. It keeps on going till infinity over here. Do you recall there is no vertical asymptote in tan inverse? Wherever tan inverse is there, there is no vertical asymptote at all. So in the answer, it must be written there is no vertical asymptote. Okay. See, there is no vertical asymptote. But what about the horizontal asymptote? Just use calculator. Now, here, let me take the calculator. Just put this equation as it is. 4 tan inverses by shift and tan alpha x minus 1. I'm doing the shortcut calculator method. That's why it's direct. Now here what you do is, okay, first thing, if I do calc anything, it'll be wrong answer because it's in degrees. So shift mode 4. Okay, that's the first step. Change it to radian whenever you have trigonometric functions. Now press calc. Let us keep x as infinity, positive infinity, 99999. What is the answer? Now write this down. Obviously your answers will be in pi. There won't be a proper answer. So write this down. 98 at where? When x tends to positive infinity. Now change this calc to negative infinity, minus 99999, and here is the answer, negative, let me just write it, minus 7.28. Now there is something very important. Okay, did I write this first one right? Calc, okay, it's 28. I'm sorry, it's not 98. It's 28 because 2 pi is 6.28, right? So always remember. So whenever you end with something with 28, you know there is something to do with pi, okay? 2 pi. Okay, if it was 1 4, then it's only pi. So it's easy to recognize the patterns. Now here you won't have these two answers ever. Now you will have y equals to something and something, right? Now the correct answers are these both. How would you find this? Very, very simple. Just put them in the calculator. 2 shift pi minus 1 equal to, here's the answer. Is that correct? Yes. For positive infinity, we got this. Now, what about the negative infinity? It's just minus 2 pi. Here, negative 7.28. So these are the answers. So that's how we get it. And there is no vertical asymptote here. But now look at the right side. Natural log. Do you recall the graph of natural log? It's something like this, right? In grade 11, this is term 1, they have it for the exams. So you had studied it 1 year ago, but it's important to, just remember a few of the important things. The asymptote over here, the vertical asymptote is when x is 0. Ln x, when x is 0, it's the vertical asymptote. But here, do you have 0? No, whatever is inside that must be equal to 0, okay? At this particular point, you will have a vertical asymptote. Now the problem is, see this trigonometry. Now I will use the calculator. I'll show you it's not possible. It's 1 minus cos x, right? So cos alpha x equals 0. Okay, what is the answer? Shift and solve. The thing is, wait, what happened? Let me just see. Let me just clear the calculator for a minute. Shift 3 equal AC. Let me type 1 minus cos alpha x equals 0. Okay, it can't be shift and solve. Okay, that's the correct answer. Let me make it to radian. For radian 0, it doesn't matter. Radian or degree will be the same thing. It's 0. Now, when x is 0 degrees, you have the answer. But this is misleading, right? Because, we know cos graph is something like this. It keeps on. So, 0 means there is another answer again. So, how do we understand exactly? So, let's rearrange this. Let me take this cos to the other side. It will be 1 equals cos x. Now, what does this tell you? When the graph of cos x is equal to 1, it's the answer. When is it at 1? At 0, yes, it's at 1. It's at the peak, it's 0. So 0 degree is correct. But then again, after 360 degree, it repeats, right, at 2 pi. Again, it's there. Then again, after 4 pi, and it continues. We had a similar problem previously where we had written like this. See, Now here, because it just continues at 2 pi everywhere, right? So the answer is basically 0, 2 pi, 4 pi, 6 pi, 8 pi. We can't keep on writing like that. So what we do is we tell 2 pi n, but in your textbook it's generally 2 pi k. It's the same thing, where k is an integer value. That's the answer. That is the vertical asymptote. Okay. So 2 pi k, what is that? Where k is an integer value. That means every time when cos touches 1.1, that is there is a vertical asymptote for this particular thing, because land 0, right? When we equate this to 0, we get that. So this is the thing. And what about asymptotes? Is there any horizontal asymptote? Let's try it. Let's put it in the calculator. Natural logarithm 1 minus. If you know the graph, you'll realize there is no asymptote, right? Horizontal. Let's just put this alpha x, close the brackets, and calculate at infinity. You're getting an error at minus infinity. Also an error. Oh, okay. Sorry. One second. Let me just increase the numbers of 9. Now it will be, sorry. Now it'll be an error. Okay. If you know the graph, natural logarithm, there is no horizontal asymptote because it just keeps on going, right? So that's the thing. That's the answer over here. Okay, now I hope these both are clear. The other ones are very, very simple. Here also you translate the same idea. It's just that this problem, no problem at all. We can directly do it and we will get, instead of pi, we get it as a decimal number. Here, only for that, you will get x value is correct, it's 0. Yes, x degree is 0, but you should know the period of course is 0, 2 pi, 4 pi, and so on. So this is important to understand. So because there are many types of problems, so you need to remember which type is which. Now we will come to do slant asymptote. Vertical asymptote is very simple. We have done this already. Just equate this equals to 0. So here it will be 4 minus x squared equals 0. 4 equals x squared. So you have 4x is equal to plus 2 minus 2. This is the answer. Okay, plus or minus 2. What about the slant asymptote? It is basically long division now. Let's do long division. I hope you remember the long division. It is, say for example, you have to divide this by this. So we need to have the standard form. So minus x squared comes first, then plus 4 is dividing with what? X cube. Okay. Now, okay, let me write it properly. Sorry. X cube. Here it's x cube. This was divided by minus x squared plus 4. Now what you need to do is you need to multiply minus x squared with a number to equate this. In other words, you just x squared divided by minus, sorry, this is what? X cube, right? Divided by x squared. Now the problem is you don't have a calculator method for this. You have to do this. But the problems will be easier. It's simple. I will tell you a shortcut in this, but this step you need to do. The answer is minus x, isn't it? Because this cancels, minus x remains. So multiply with minus x. Now multiply minus x and this one. It will be plus x cube. Then do 4 times minus x. It will be minus 4x. What is the answer? Now you need to subtract, take away, change the sign. If it is plus, it becomes minus, plus, minus becomes plus. Cancels, you're remaining with plus 4x. Look, here the degree is more, this is small, you can't do it, this is the remainder. You don't need this remainder. So basically, this is your answer, that's it. The slant asymptote is over here. Vertical asymptote plus or minus 2, very straightforward. Slant asymptote is this. So now what I usually tell is, so if you have this, see, first of all, the degree in the numerator must be greater than the denominator by 1. Then you can use, you should do long division to find slant asymptote. So whatever is this, x squared plus 1 divided by x minus 2. Just focus on these two terms. See, the degree is differing by 1, right? Just focus on these two. How much you have to multiply? You have to multiply by x, you'll get x squared. Now you know this cancels. Whatever remaining is only a number. Oh, sorry, 1 second. Let me just do this. Minus 2. This is x squared minus 2. And what are you getting? Yeah, it is just a number. Okay, I just got confused. Sorry. This is it. The answer is x over here. The second problem, the answer is x. So, oh, I forgot to write this. Sorry, I apologize for that. I realized my mistake, and I thought I'll edit it out. But it's good that I made that mistake because this is one of the mistakes many students do. Look, the way I wrote the question is completely wrong. After x squared, the standard form x squared. Let me just write it. Sorry, x squared plus zero. After that is x. Sorry, after x squared, it's x. Then it is any number constant. What is the question here? X squared plus 0x plus 1. This is crucial. Let us write it like that. X squared plus 0x plus 1 divided by x minus 2. Now you multiply with x. So x times x is x squared minus 2 times x is minus 2x. Now sign changes everywhere. If it is positive, it becomes negative. This cancels. Negative became positive. Over here, you're remaining with 2x. Bring the next term down, it will be plus 1. You don't need to solve the entire thing. Just see what is required to cancel this term. You just have to multiply with minus 2. Why? When you, sorry, not minus 2, it's plus 2. Why? Because your intention is not to cancel this, your intention is to make the same, because then the signs change, right? So this will be plus 2, not minus 2. X times plus 2 will be 2x. Your goal is to make these both equal. See, x squared, x squared. Then what is this? This you don't even need. Now we know this cancels enough, because then this is your answer. We just try to get, see, now over here your x term, right? There can be a constant term, that's it. If there's a constant term, well and good. If there is no, this would be answer. In this case we got x plus 2, that's it. We don't want the remainder, so I'll stop it over here. So here you can see the answer is basically x plus 2. Okay, the vertical asymptote is 2 because you take x minus 2 equals 0 and you'll get it. Now what about this? We will do this next term quickly. 1 second. Let me write it. X cube, and there is so many terms over here to solve. X squared plus x minus 4. This is having 0x squared plus 0x plus 0. Now first thing, you need to multiply x to get x cube, and then what are you getting? This multiplied by this will be x squared minus 4x. This cancels. What are you getting over here is minus, and this becomes plus. It will be minus x squared. And what about over here? When you add 0 and 4, you will have just 4x. You don't even need this, because you know x term you got. So if you just get one more constant term, that's it. That will be the answer. So just focus on this. This is not even required. Only this two terms. X square, and this is minus. So if you multiply minus 1 with x squared, you balance this out. It's gone. The answer is x minus 1 here. That's it. So you can see the answer is x minus 1. What about this? Here you just put in the calculator. Always vertical asymptotes are from calculator. It's mod phi 3. Let's put this denominator in the calculator. 1, 1 and minus 4. What do we get? Minus 1 plus root 17.2 and minus root. So it's plus or minus. Same thing here. Do this by yourselves and you can understand. I will put a link to the long division method. If you want to know it in detail, you can follow that link and understand long division very well. So try to make use of it. Now, one more thing, the last one, I'll just do the long division over here. So it's same, it's easy, it's pretty easy as long as you follow the simple rules. Here, x to the power 4 plus x cubed, there is nothing, so it's 0. 0x squared. I'll just stop writing, that's enough. Now here, what do we have? X cubed plus 2. Left side, don't write all that, 0, 0. Just over here, what do you have to multiply this with x to get x to the power 4 plus 2x. This cancels. Now 2x over here, okay, it'll be way ahead, but doesn't matter what. Look here, after x cube, whatever the answer you get, do you get x cube here remainder? No, 0 x cube. What you get over here is something like minus 2x. Look, whatever happens wherever over here, actually I have not written it properly. See, here it will be 0x plus 0, right? This 2 times x, where is x term? It will be over here, so it is plus 2x. These are all 0x cube plus 0x square. Then this becomes minus 2x plus 0, right? Look at the degree. This is 3, this is x. Can you solve? It's not possible. So you just stop it over there. Only x is the answer. Because now when you can't, this will be the remainder, because the degree over here of the divisor is greater than whatever. You can't continue. Once it's greater over here, you can't continue. So that's why y is equal to x. That is the slant asymptote. And this one over here, it's very simple and straightforward. Just solve it up. Now, when you solve this in calculator, you won't get this answer. You will get a decimal value. But then see the options. Simplify this, you will get the correct answer. Now, let me just tell you what I'm saying. You have to just make this equal to 0, isn't it? So x cube plus 2 equals 0. So you can take this 2 to the other side, x minus 2. Take cube root on both the sides. It will be x equals minus cube root 2. Now, if you're thinking, oh, it's minus, you can't take cube root. No, you can't take square root. Negative can't be inside square root, but you definitely can have cube root. That's how we do it. The last type of problems over here we have, say they have told, suppose they have given a certain condition and we need to solve them. Suppose that f of x is a rational function, the given p of x is the numerator, q of x is denominator, with the degree of p of x greater than the degree of q of x. They are mentioned here, this degree here is greater. If I give 3 here, it will be 2 or anything else. Determine y, whether y as an y equals f of x as an horizontal asymptote or no. Now, if the degree of the numerator is greater than the denominator, there is no asymptote. Sorry, no asymptote. Okay, no horizontal. Basically, I'll just show this. Okay, it is no horizontal asymptote. That's it. Because we know there are the conditions. Now, since this is an MCQ, I don't exactly understand how this will be asked. If you focus on the first part, that is more than enough. This is just the application of it, because the first part we saw calculator method. Here now, nothing is given, so you need to know the condition. Basically, the 3 conditions which I wrote at the beginning, you can rewind, go back in the video. There was 1, 2, and 3. First one was the coefficient divided by coefficient. Let me just see over here. If the degrees are same, this is also not an example, but if the degrees are same, x squared by 2x squared, then the coefficient 1 by 2 would be the asymptote. If the degree in the numerator is less than the denominator, then the asymptote is horizontal asymptote y equals 0. If this is the case, x squared by x, then there is no horizontal asymptote. These were the 3 conditions which you must remember for this, okay, like the word problems. Suppose that f of x rational function f of x equals p of x by q of x with the degree largest exponent of p of x less than the degree of q of x. Then it is at 0, because over here they have given the condition number 2. The numerator is less than denominator, so it's at 0. That's it. And suppose the rational function, same thing over here. Oh, they have told if it has a slant asymptote, how does the degree of p of x compare to the d of, okay. When does slant asymptote occur? When the degree in the numerator is greater than the denominator, right? So this is greater, is 1 greater than, okay, one more important thing which I mentioned earlier. For slant asymptote, it must be exactly 1 greater, only 1 greater, okay, 1. It can't be x to the power 4 and x, no. Okay, so it must be greater than, numerator must be greater by 1. That's basically it. Then let's see the other one over here. What is this? Suppose that f of x is a rational function given over here. If y equals f of x has horizontal asymptote at 2, how does the degree? Okay, if it has y equals 2, then what happens? Then, the degrees are same and the coefficient of the upper degree is 2. Basically, the degrees are same, okay? The degrees are same. That's it. See over here, the first case. When do you get any number? When you have, say, 2x squared by x squared. The degrees must be same. Then the coefficients are solved. Or it can be 4 by 2 x cube x cube. Then you do 4 by 2, that is 2. That's the case. It's just asking questions, simple ones. Now find quadratic function. Okay, now this will, you can do trial and error method, but see, this is in topic number 5. You will have 4 options. Just choose the one which is correct. Let's directly see the answer. Over here, this is minus 2, x minus 2. I'll tell you why this must be the answer. Look, the numerator is given already. I'll split it out. If you use the calculator, you'll get to know it's x plus 2, x minus 2, the factors, okay? Divided by. We need to know what is denominator, provided there is one horizontal asymptote at minus, okay, this is important. There is a horizontal asymptote where at minus 1 by 2. So there must be a term 2 here. And the degree must be x squared. That means there must be 2 terms below also. But they have told exactly one or a vertical asymptote. See, they have given one term already. X minus 3 must be there because why? X or vertical asymptote is at 3. Take this inside, it will be x minus 3. This is one term. Okay, fine. What is the one more term? Now, one more term is required because they have told the horizontal asymptote is how much? Negative half. So this must be minus over here because up there is no minus. See, there must be one more term. So above term and below term will be having square. So when you multiply, you will have power 2. And now this minus 2 is there. So the coefficient up is 1, 1 by 2 minus 2. So that's why this minus 2. This is from this. And one more term which cancels off because they have told only one vertical asymptote, right? So now what I do is I'll write this term here, x minus 2. So basically this would satisfy this. Okay, even if this was plus 2 also it would satisfy. But provided when you simplify and solve it, you will come to know that. So it's easily found out. This much can be easily figured out from the question. And this, whichever is the appropriate one, which cancels with the numerator, is the correct answer. So look into the option, look into the question, easily you can find it out. Okay, now here also they have told similar thing. There are 2 vertical asymptotes at over here. So that means when I look at this 2 vertical asymptotes, I know it will be x plus 3, x minus 3. Okay. And the horizontal asymptote. Okay, now this is a bit tricky over here. Why? Because they have told there is a horizontal asymptote of 2. Horizontal asymptote, and this has no coefficient. Look, whether there is any coefficient, no, nothing, right? So how can we get it? That means we have to divide this by 2 basically, okay? So this is the answer, okay? This would be the answer. Let's just see over here they have just simplified it. I'll just show you how to get that. Just multiply over here. Multiply this. Here you will get x squared. This will be x squared minus 9. Okay, when you multiply, divided by 2 must be there. This is also the answer. This is also the answer. But now they have just split it off. So it became x squared by 2 minus 9 by 2. Why? Because see, now this is the correct answer. Now, most of us would prefer this. Why? Because see, x is plus or minus 3. That means it must be x plus and minus 3. Okay. Now there is a horizontal asymptote at 2. Now can you see any 2 over here? No, I can't have 2 in the denominator. It must be in the numerator, right? So what I do is I'll divide over here by 2. So basically when you rearrange, it goes up over here to the numerator. So that's the reason I divided by 2. But now this option is not there. So, x plus 3, x minus 3 is given. If you do multiply over here like this, you will come to the answer of x squared minus 9. Or you can use the FOIL method, sorry, the the identity x plus b, sorry, x plus a x minus b. Okay, what am I writing? X minus a. Okay, x plus a x minus a is given as x squared minus a squared. This is the identity. So here 3 squared is 9. I directly wrote it. And then divide the 2. You will get this answer, x squared by 2 minus 9 by 2. So this is how you solve these. They are pretty straightforward, just a little bit tricky. So the initial part, 23 to 32, were mostly in calculator, easy to understand. The last one, you should just apply few of the things, say the rules of horizontal asymptote and everything. So that's the end of this topic. I'm sorry it's been too long. The videos are getting too long, though it's a single question, because the reason is there are lots of lots of different type of questions in a single topic. It's not just the same thing, right? Now, if you see, this is entirely different methods. Now, these were different methods altogether. Long division, this is different. So that's the reason it's been a bit long. I hope it is clear, and do practice more problems. And if you have any doubts, post them in the comments. The sixth topic is easy and a simple one, also a short one. It is to understand the link between the slope of a tangent line and a non-tangent line to a graph geometrically. Let's look in the problems. See over here, they have given an equation and they have asked us to use graphical and numerical evidence to explain why tangent line doesn't exist at this particular point A. Before this, we need to recall what exactly does this mean. This is about whether it's differentiable, whether the graph is differentiable, whether the lines are continuous. Now, though lines are continuous, say for example, this one you can see over here, this is a absolute value function. The graph of it, the standard graph will be something like this, right? Sharp corner. Everything will be in the positive side. Now this is continuous because, you can consider this to be continuous, but continuity, though it can be continuous like this, it is not differentiable. Why? Because there is a corner. For differentiability, it must be smooth curves. It's very important. It can't be something like this. No, it can't be a straight line and a curve. This is not possible. It must be smooth. Now here we can see, if we graph this, -1 in the sense, basic understanding of graphs, over here x minus 1 equals 0, x equals 1. So at 1, there is a sharp corner, isn't it? So generally they ask you this point, and at that point there will be something. So for example, this point is differentiable everywhere else, but not at this particular point where x equals 1. So over here they have told a is 1. It's not differentiable over here. Why? Because it is basically having a corner. That's the reason. There is no tangent line. Tangent line can't be drawn at that particular point. So that's the thing. Basically, you just have to select it's not possible at this point. Why? Because of a corner. It doesn't exist. Now, what about over here? Here, say they have told at x equals 1 and the denominator. Look at the denominator. When you make this equal to 0, solve for it. It's x equals 1. That means at x equals 1, there is a that's not a vertical asymptote. It should be a straight one. There's a vertical asymptote. You can see in the graph. This is a rational function. Two numerator, denominator, there are functions. But the thing is, at this point, no matter what, there'll be a vertical asymptote. So it's not defined over there. It's not defined at x equals 1. Tangent line cannot be drawn. Now, what about this? This is a piecewise equation. We need to draw that. Here there is a less than 0. So 0 is a very important point here. Now x plus 1, that means it's sharp. This one over here, it is x squared minus 1. That means it's a quadratic equation over here. So quadratic is something like this, but since it's -1, it moves to the other side, and then it should be drawn something like this. There'll be a jump discontinuity, I believe. See, there's a jump. Okay, I just realized one thing. It should go down, not -1. Sorry, my bad. It is down over here at -1. So like this. So anyways, even if we had drawn over here, there would have been a jump discontinued at the upper point. But now look over here. This is not at all continuous, okay? Why? Because there's a jump. The previous problems were continuous. Continuous is drawing a graph without moving your pen. Say, for example, without lifting up your pen. In the sense, there should not be a hole, there should not be like this tangent line, oh sorry, it should not be asymptote, or it should not stop at one point and continue somewhere else. These are the things for continuity. The previous ones were continuous but not differentiable because of corner or asymptotes. Now here this is not continuous at all. So yeah, one second, even this is not continuous, sorry. The first one was continuous but it was not differentiable because of the corner. This is because of the vertical asymptote, here because of jump. Okay, it's there's a jump discontinuity. You can't draw a tangent line at this point. You can draw somewhere other points, but at x equals 0, it's not possible. Now here also same thing, you need to draw the graphs and then get it. Now over here you can see it's a sharp, it's called a I can't cusp, I guess, this point where it is sharp and then moves on. In one of the lesson explanation in the derivatives, all these different cases where differentiables are not possible are mentioned. So this is one of the condition. And at a equals 0, that is over here meaning the x-axis, at 0 there is a cusp and you can't. This is also not differentiable. So basically it's not smooth, you know. Smooth means it should be very smooth for a tangent line. So you can have exactly one point touching the tangent line. But over here you cannot draw a tangent line. And now this one, this is, see, a smooth curve. It is continuous and it is differentiable everywhere. We can differentiate sine x. I'm sure you know this by now. You have used the differentiation. Now, where do they want is at pi. Now, what happens is when you draw the tangent line, you must just be careful. It'll be something like this, you know. See, it's very hard. Okay, that's wrong. But anyways, it'll be, it's a bit hard to draw in the sense, say, for example, let me just try this. Okay, like the, no, it should be very close, okay? Anyways, it should be very, very, very close like this. Okay, this is also not true, but I'll just show you what's the exact answer. See, that's the answer, okay? It should be so close that it touches only one point, but it's very, very close to this. The touching point is exactly at pi. Pi is 3.14 at this particular point, okay? This is how we draw a tangent line. Now, what about over here? The same thing. Somewhere over here, the line will be like that. Say this is the line for tan inverse. See, tan inverse graph, it keeps on going. And now over here, you cannot draw a tangent line at x equals 0. It's not possible. Other places, yes, but not at this point because it's a corner. So it does not exist. We have seen that before as well. What about this? This is very simple because the tangent line just falls over this. In the sense, you just draw a line over it. You know, it'll be just a line like this over it. I mean, God, my drawing skills. It's just, it'll just be over it. You know, it overlaps it. That's the thing. You can see over here. I mean, you can't see the line because it's overlapping, right? So that's the thing. Tangent line means, now because this is a linear, if it was a curve, if it was like, say, a quadratic, then you will have a particular point. Sorry, this is not, this is a secant line. It touches 2 points. Tangent line only can touch at 1 point only, and then it doesn't touch anywhere. But you can't, you know, if you zoom in, say now, for example, you draw a tangent in Desmos or other graphing calculator and then zoom in, you can see there is always distance between them. So that's how we solve it, and that's the end of this particular question. If you have any doubts, please do post them in the comments. Moving on to the 7th question, to find average velocity and instantaneous velocity at given point. This is again very easy since it comes under the MCQ questions. You will be given 4 options. You can directly use the calculator. For this first part, they are just asking you to find velocity at these 2 intervals. So take your calculators, just use direct derivative formula. Now you have been given the position. position function, that is s of t, or displacement, if you derive it, you will get the velocity. Now all you need to do is derive this position. Shift and dy by dx will give you, you should type the function as it is, negative 4.9. No t over here, it's only x. The variable is always x, x squared plus 5. Now first find at this interval at 1, the answer is negative 9.8. You can see the answer is negative 9.8. Second interval would be at 2, and the answer is 19.6. That's it. You do not need to use this entire formula to solve. You can just use the calculator method and get the answers. Same thing over here. You can try it. Now I'm just gonna change it over here directly. I'll go with the interval 1. And now all you need to do is change this up. It is negative 4.9 t squared. Over here I'll just add 4t. So this is it. Press equal to. You can see the answer is negative 5.8. And what about the first interval at 0? A is 0. It'll be 4. That's it. So you can easily solve these problems. Doesn't matter square root, doesn't matter trigonometry, just directly in calculator. You can see this is the answer, and over here this is the answer. Okay, now I'll just do this quickly because you won't be getting the exact answer in your options, in the sense the form will be differed. Now it's square root x plus 16. At 0 you are going to get 0.125. This is simple to understand. 0.125 is 1 by 8, so you can easily understand this. But what about the second one? If I change this interval to 2, I am going to get answer 0.117, like this, right? So write this answer down in a rough page and then check all the 4 options. You will have 4 options. Start solving them like this. 1, first of all, I'll just go with that option, 1 by 8, and compare. Ours was 117. No, this is wrong. So change 1 divided by 2 root 18. And I'll just remove this. Okay. Is it correct? Yes, this was 11785. So write about 4 to 5 decimal digits somewhere and then compare. So this is your answer. Similarly, you can do this one. It's very simple, just in the calculator by using shift and dy by dx, and then you will get the answer, and you can check it out over here. Now again, over here the answer will be, in terms of decimal, negative 0.25. That is 1/4. That's quarter. The second part now is a little bit different, because they're not asking you just the instantaneous velocity. They have asked you instantaneous velocity, but they have asked you other things as well. Say, for example, they have told this function which is given to you is position. That's fine, which was the same thing. Now find the average velocity between 0 and 2. 1 and 2, 1.9 and 2, 1.99 and 2, and then estimate the instantaneous velocity at 2. Basically, when you, what is derivative? Derivative is basically finding the tangent line, right? Tangent line of function. So what is tangent, sorry, not tangent line, slope of tangent line. So basically derivative is using this formula, y2 minus y1 by x2 minus x1. Now here they are telling to find the average velocity. That means from here, find the positions at time 0, at time 2, and then this is the x value. Find the y value by substituting over here, and then substitute over here the required ones and find the velocity. I will do it in a while, but I just want to make one thing clear. Using this formula, you get the velocity because this is the slope formula. Derivative is basically finding the slope of tangent line. So that means this is also equal to derivation, okay? But when you use the formula over here, the derivative formula, it gives you more accurate answer. That's the only thing. Now I'll tell you how to do this. First one, let's do for A. So what is the given value of x? That is t. So I will take the first value is 0. What is the y value? This is x. This is y, right? Given function. How do you find the y value? Just substitute this 0 instead of t and solve it. You can use your calculator, but I can, for this one, don't go to use 0. It's very simple. It'll be 0 square is 0, 0 times 16 is 0, only 10 remains, so the answer will be 10. And then, what about the next point? 2, comma, now here, substitute this in this, substitute 2 over here instead of 16. I'll just use the calculator here. So all you need to do is 16 into 2 square plus 10. What's the answer? It's 74. So when x is 2, the y is 74. Now take this as x1, y1, x2, y2. Even if you interchange this as x1, y1, x2, y2, it won't differ. The answer will be the same. Put them in the formula. The slope m equals y2 minus y1 by x2 minus x1. If you substitute that, that is 74 minus 10 divided by 2 minus 0. You're going to get the answer 64 by 2, that is 32. That's the answer. You can do it in the calculator. That's the first part. How much we got? 32. Okay, all the answers available. Now the same thing is repeated over here, but what's the difference? In the second case, this is 1. Then substitute 1 over here, solve, and you will get the answer. You'll get 2 answers. Then put 2. 2 will not change. Okay, I'll just do the second one also. I'll do the third one, C. Okay. Over here, instead of 0, they have given us as 1.9. So all you need to do is change this one. X1 only. I'll change the color as well of the pen. It is 1.9. And now substitute over here 1.9 instead of 2 in the calculator. Say this one, right? It will be 1.9 square. Now this is 67 instead of 10. I have to substitute 67.76. Okay, 67.76. Now just substitute over here. What changes is only x1, y1 changes. These two values changes. Okay, so x1, y1. So x2 is 74 minus, because 2 is same, right? It's going to be same. 67.76 divided by over here 1.9. Put this in calculator. This is the previous one. So all you need to do is put in the calculator and you will get the answer. So we will substitute the values here. 74 minus 67.76 divided by 0.1. I'm getting very sloppy. 0.1. It's 2 minus 1.9 is 0.1. The answer is 62.4. So you can see the C answer is 62.4. So what you can see is, if you see carefully, the average velocity we need for the time interval 2. But you can't find at one specific point. What is, the slope requires 2 points. Okay, so you got 2 intervals, but as you're coming closer and closer, here you can see it's 1 to 2, 1.9 to 2, 1.99. Can you see over here 1.99? You're closing in on a certain value. See, 32 became 48, 62.4, 63.84. This instantaneous velocity is very important. That is the value you get from derivative. So now, how to find the instantaneous velocity is just like the previous problem what we did. All you need to do is put this equation in this dy dx, 16 alpha x square plus 10. Okay, and what is the interval? It's at 2. So the answer is 64. That's it. This is the average and this is the direct one. For the average, you need to do the slope formula. There's no other option. You need to plug in this value over here, write it out, plug in this value over here, write it out, the values xy coordinates, and then use the formula. The formula used, I'll just write it over here, the slope formula. It is y2 minus y1 by x2 minus x1. This is the formula. So that's how we solve over here. Same thing goes over here, but I'll just do the instantaneous part. All you need to do is shift and dy by dx. When you press the symbol, you get a d by dx. Now type it in, that is alpha x cube plus x. Then you will have to put the interval 2 here. and the answer is 37. You can see the answer would be 37. Whatever the answer is, even if it's a decimal, let me just do this one quickly. Shift dy, only the instantaneous part, it's square root alpha x squared plus 8 alpha x, and the interval is again at 2. So you can see it is 1.31. It's accurate enough. So this is how you easily do it. Whereas if you're doing the slope, you close in on that value as well. So that's how we can easily solve. Okay, what about trigonometry? Don't worry, it's the same thing. Let me do one, say I'll do the D, okay, for this trigonometry, because we are using radians. If you already know it, just do it by yourself. You can stop watching the video, pause the video, continue by yourself, and then check the answers. Now, your first thing, you need to consider the given value as x, 1.99. Okay, this is x1. What is y1? We need to solve. And what about x2? Is over here, and 2 comma, we need to find this. How do we find that? Is basically here. Now it's already in radian mode. That's great. So here you just substitute 3 sine. What is x? This value 1.99 minus 2. Minus 2. Close the bracket. What's the answer? It's negative 0. I'll just round it off to negative 0.03. Same thing, now do it for the second interval. It's 2, it's going to be 0 over here. Why? Because 2 minus 2 is 0, sine 0 is 0. So this would be 0. Now use the formula. Slope formula is given by y2 minus y1 by x2 minus x1. This is y1, y2. All you do is substitute 0 minus of minus 0.03 divided by 2 minus 1.99. Plug these values in the calculator directly. You're going to get negative 0.0. Sorry, it will be positive. Let's 0 minus bracket. I'll type it as it is. 0, 3. Oh, what am I writing? Yeah, it's 2 minus 1.99. The answer is 3. Say the D value, yes, we got 3 itself. And now what about the instantaneous? Really, we round it off to 3 over here. It would have been not exactly 3. It'll be 2.9999, because if we had taken 0.02999, but we round it off, that's the reason we're getting the accurate answer. Now checking the instantaneous velocity, it's very simple. Shift dy by dx, type this in, 3 sine over here alpha x minus 2. Close the bracket because there's already one bracket open, the sine 1, so 2 must be closed. And now at the interval 2 directly gives you the answer 3. So this is the instantaneous velocity. This is how easily you can solve this topic. It's a very straightforward one. Use your calculator and solve it easily. If you have any doubts, please do post them in the comments. Moving on to the question number 8. This is to understand the relationship between continuity and differentiability. Here we start with differentiation chapter. That's the chapter number 3. Now we need to know the power rule and all the different rules. But the first type of problem here, the question 8, is pretty basic. Okay, they are using the formula of the derivative from the left side, the right side, and then finding whether this derivative exists or no. Now basically the concept is of limits. See, when it's less than 0, you need to find the derivative over here. Greater than 0, find the derivative. If they are equal, then yes, it exists. Otherwise, no, it does not exist. Now this is not limits exactly. You need to do derivative. That is, say, imagine you have x squared plus 2x. The derivative of this would be 2x plus 2. Power rule. Okay, don't take 0.00. No, this is not the thing now. And one more thing is you can use this formula. This is given already, or you can use the calculator. So we will do the calculator method. Because this topic is in question 8, you can easily solve it in calculator. What do you do is, see, they have specified the interval less than 0, greater than 0. But it's fine, just that when you write, say, why this is important is, I'll just tell you. When we are considering the derivative, see the limit, this is the derivative formula basically. limit of from 0 minus, then you have to consider this one, the first one. When it is 0 plus, it's the second one. Just do it for both and then check whether the derivatives are equal or no. So I'll use this derivative symbol, this one over here, and type this out. 2 alpha x plus 1. Sorry, I've used the integral symbol, my bad. It's shift and this symbol over here now. 2 alpha x plus 1 and x is equal to 0, just press equal to, the answer is 2. This is the left side. You can see the derivative from the left side, f of 0. See, this d minus means, sorry, I told limits, sorry. I should have written this one. It's d minus means from the left side, d plus from the right side, derivative from the positive side, derived from the negative side. So this is basically we are finding differentiability. Now here, just change this to 3x. What is the answer? 3. Are they equal? No, the one-sided limits do not agree, so derivative at this particular point does not exist. It's not differentiable. Let's try the next one. All you have to do is same thing. Just change it. I'll change it to 2x first. I'll find the positive d plus first. It's 2. And what about 0? 0 is 0, right? It does not exist over here also, okay? Because 0 and 2 does not match up. Now, what about these? Now, if you remember derivation, you will understand when you substitute 0, because there is no plus or minus, it will be 0 and 0, both the cases, okay? At the point 0, they are both 0, and even over here, it's 0. So it exists, okay? This is the thing. And now same thing over here, just do it in the calculator, you will get the answer directly. Very straightforward and easy problems. 2x at 0 is 2. Now the other one will also be 2 because x squared will be 0, right, when you substitute 0. So the answer should be 2 itself. It exists over here. So 2 and 2. Now, okay, this is the last problem, but the last problem is a bit different. What can you see over here is for f of x, this is given, but the second part is ax plus b, and they told find all real numbers for a and b such that the derivative exists. So derivative exists means if I solve this and this, I should get what? Equal answer. So let's do the first part over here. I already done it. The answer is 2 here, isn't it? The derivative over here in the first part is 2. So doesn't matter what, if I derive this, I must get 2. That is one clue. Now, if you understand derivatives, we can analyze few things and learn better. First thing, sorry for that. Okay, first thing is, let's just use power rule over here. What happens when you use power rule? Let's use power rule. It becomes 2x plus 2, and then you substitute x over here, substitute the value of x, it becomes 0, and that is how you solve it, isn't it? Now there is one important thing. Now, sorry again. Okay, this is how you solve it, and then you substitute 0, the answer is 2. Now let's just imagine the second one, okay? Ax plus b. I do not know what are these values, but what if I derive this? This is a constant value. It's a real number. A and B are real numbers. So let it be any number. It's going to be gone. What is remaining? A, X. Sorry, only A remains. Isn't it? Why? Because if you let me do it again. The derivative of this we already got. The answer is 2. So this is the first part. 2x plus 2. How do we get it? We use the power rule. It will be 2x plus 2 and then substitute x as zeros because over here x is defined at 0 plus 2. The answer is 2. So now they have told the derivative of at 0 exists. That means now use the second one, ax plus b. We can't use the calculator. You do not need to know the long method. I'll just show you the long method. This is a little bit confusing. You don't need to do that. I'm telling you a shortcut, but not exactly calculator because over here A and B is not given. Just derive this. Okay, I will derive it. It'll be A, because x is 1, plus b will be 0. So a must be equal to 2. Do you agree? Why? Because this is derivative. So when I derive this, this is, I'll write d by dx, okay? Over here, this is d by dx. We know the answer over here is 2. So already derived answer is 2. So this also is, they both are differentiable. The derivative exists. So this a must be 2. True. Okay. So let's just check the a value. Yes, a is 2. Now what we do? We have to find the b. Now here b is a constant, so it's basically you can consider it to be 0. Now think for a while, because you can also see over here, this is 2x. Now this, how can you equate it? It can be 0 value, right? So that's x is variable, yes, but when it's 0, it would be kind of balanced, So that is one way to solve it up. Or, basically find one derivative and then equate it, and then you will easily find this, and then the other one, so it can't be any other value. If it's any other value, it won't be balanced. So it must be 0. Otherwise, you can use the formula. Over here, they have used the formula, but ultimately you will get the same answer. It's just that the formula is the derivative formula without the power rule and everything. In the first two lessons, we had this. So what happens is over here, you have to memorize this formula. It will be given in the previous problems. It's given already. It might be given, but if it's not given, it's always f of h minus f of 0 divided by h. Now what happens is, instead of this given thing, you write in terms of h, and then instead of instead of second part, instead of x, you put 0. That's how you do it. Just substitute 0 and solve. You substitute h and solve. So then you just substitute and solve it. But if you do the calculator method for all these problems, it's very, very straightforward. Even for this, you can just apply the calculator method and directly solve it up. So that's how we solve this particular problems. And mainly remember, from here on, when they ask differentiability, don't use limits. Now if you're going to think, oh, I will use calc and 0.00, no, it's not going to work. You can try, it would be an error. So make sure you use the differentiability here. The question number 9 is to find the derivative of a function at a given point using the power rule. I wish it was simple as this, but the questions seem to be different. Let's go into the question. In this particular question, they are asking to determine the values of x for which the tangent line is horizontal. Then we need to graph and understand the graphical significance. And then we need to derive the values of x for which the tangent line is 45-degree angle. So now there are so many things. Now you can skip the next part. It's just for knowledge purpose, but it helps you to solve this problem. Let me just recall what does a tangent line do. Now say for example, you have this equation. It's a cubic equation, something like this, right? When you derive it, you get a quadratic equation. But what is differentiation exactly? Differentiation, if I derive this, right, if I derive this, it's gonna be 3x squared minus 3. This is the slope of the tangent line for this equation. It's the slope of the tangent line. Now here they have mentioned when the tangent line slope is horizontal. When is the tangent line, horizontal? It's not the slope. When the tangent line is horizontal. When the slope m is equal to 0. And when we derive this, we are getting the slope of the tangent line. So horizontal means we have to just make this equal to 0. Okay. Now, when it's 45-degree, what does this mean? When is the line 45-degree? When the slope is 1. So whatever this derivative now, 3x squared minus 3 must be equated to 1, and solve the x values. That's it. So that is what we require. It's not just derivative. We need to find derivative and solve it. Now this is the basic knowledge behind it. Now let me start from the beginning. The first part, A. So we need our calculators over here. The thing is, now what if you don't know what is the when what is the slope when the tangent line is horizontal? It's very simple. Tangent line is tan. Horizontal means slope is always zero. It's a flat line, right? Tan zero. How much is it equal to? It's zero. So for A we use zero. Now over here they have told 45 degree. So tangent line will be 45 degree. What must be equal to 1? So derive this and make it equal to 1. Derive it, make it equal to, accordingly. If they had given you, say, 90 degree, which is not possible. Why? Because it's undefined over there. It's a math error. Okay, it's undefined. It's a straight line, isn't it? Vertical line, it's undefined. But if they ask you, say, 30 degrees, this is the value. This is, depending on the question, you need to equate it. Very simple. Let's start solving it up. First thing, derive this. Derivation f dash of x will be equal to 3x square minus 3, and then this becomes 0. Okay, I hope you're very, very thorough with this. Now, the A part over here will be, the graph is horizontal, right? This is horizontal, sorry, over here. F dash of x equals 0. So whatever this f dash of x is there, we found out at the beginning, derivative, 3x square minus 3 will be equal to 0. You can solve it manually, but since you can use your calculator and save time, I'll use the calculator now. Go to mode phi 3. This is quadratic. What is before x squared? It's 3. Then we have no value for x, so it's 0. And lastly, we have minus 3. So what are the x values? It's 1 and minus 1. So the x values over here would be 1 minus 1. Now, what does this say? If we graph this, right? If we graph this quadratic power 3, it'll be something like this, okay? So I can see it's 1 and minus 1, so it might go like this. Okay, cubic. Sorry, it's not quadratic, it's cubic. I'm telling graph the given function. Now, here you can see at 1, there will be change. There will be change. Not at 1, sorry, change. You can see it will be a flat line. Basically, can you see that? And over here also minus 1, it will be a flat line. Let's just look into the graph, because there is graphing as well. Now, graphing, I'm not so sure how exactly this question will be asked. Mostly these values can be asked, or these value can be asked, the part C. Now, graphing, it's an MCQ. If you're given 4 graphs, you can easily find out which graph it is. So I will just go through it. The first part we found out, what was it when it was horizontal? 1 and minus 1. Now we got an approximate, the similar graph. See over here, where is minus 1 over here? The slope is 0. You can see it's a flat line. Here at 1, it's a flat line. This is the important things, what you need to know. Okay. Now, if they ask you to graph this, which is very unlikely, but you know how you can graph, making tables of x and y. Make tables of x and y and just graph it. Assume some values of x, minus 2, minus 1, 0, 1, 2, plus 1, plus 2, and put this over here and find the y values. Or the better way is, shortcut way. Now you have your calculator. If you have 4 options of graphs, what you do is choose any one point, 0. Substitute over here x as 0. This is gone, your answer is 1. So is y equal to 1? Yes, it's at 1. Choose one more point. I will choose, say, minus 1 here, okay? Instead of x, I need to put minus 1 everywhere. Minus 1 the whole cube in the given equation. Minus 3, sorry. Here, minus 3 into minus 1. And lastly, we have plus 1. What is the answer? It is 3. Is it 3? Yes, it is equal to 3. Only one graph will give you correct answers at all the points. Now, if there are two graphs in the same thing, then choose one more point. I'll choose 1 over here. I'll just remove this negative signs off. And we will see the answer. It's minus 1. Yes, it's minus 1. This is how you can graph it. But I don't think they're going to ask you what to graph it, They might ask you the part A or part C. We will see that in more detail. Now over here, the graph shows, say over here, the maximum value and minimum values at these particular points. Why? Wherever the tangent is horizontal, it's flat line. So those are turning points, right? Maximum or minimum values occur at those 2 points. That's basically it. And the last part, what is the f dash value equal to? I told you right at the beginning, it will be equal to 1. How? If you just see the tan, 45 degrees is equal to what? 1. So now let's first derive the given function. The function is over here. So what you need to do is derive it. F dash of x equals 3x minus 3. Now f dash of x, the slope of the tangent line will be equal to 1. So equate this, 3x minus 3 equals 1. Now you can manually solve it or directly taking it to the other side. 1 second, I've written it wrong. It's square over here, 3x square. Okay. Now it's better to use calculator to solve this now. What you do is take this to the other side. It'll be 3x square minus 3 minus 1 equals 0. 3x square minus 4 equals 0. Why do we need 0? Only when all the terms are at one side and you have equated to 0, you can use mod phi and option number 3. Look over here. Ax square plus bx, it's not this, so it's 0. And the constant term minus 4 equals 0. That is the option 3. Now substitute 3, 0, x term is not there. Last term is minus 4. The answer is 2 root 3. It's 1.15 and minus 1.15. Now you can see the answer is, okay, they have written in terms of 2 root 3. It's fine. Even we got the same thing. Okay, now you can see this is a little bit different. I'll tell you why. This and this is the same answer. If you solve this 2 root 3, it's going to be same. I'll tell you why the calculator writes it like this. Now here, right, they simplified further. Usually they don't like to keep the denominator with the root 3 in the calculator. So they multiply and divide by root 3 by root 3. What happens? The numerator will be 2 root 3. Root 3 times root 3 is 3. This is the simplified version. It's always the same. Don't worry about it. It's the same thing. Now, if you simplify this, try this in calculator, it'll be about 1.15, whatever we got over here. Another way to check the answer is, if you have graph. Now, what is this answer? 1.15, right? Look at this. Where is 1.15? Plus and minus 1.15. 1 point somewhere over here and over here, right? Sorry, it's 2, 4, 6, 8, 10. Sorry, it's not there. It's 1.2 is this somewhere over here. 1.15 somewhere over there. And this also, it's somewhere over here. Middle. Okay. Now, if you look carefully, the tangent line over here at this particular point, somewhere over here, right? It'll be 45 degrees if you draw a tangent line accurately, okay? At that point, if I draw 1.15, you can see its slope. Now, if I draw over here, it's not 45 degrees. It's not slope of 1. No, only at that particular points, okay? That's what we have done, 45-degree tangent line. I hope that is clear. So that's about it. Now, we will look into other problems. It's the same thing anymore, the same concept. First thing, let me just do it very, very quickly. This one again. What do you do? First, find the derivative, f dash of x. That is equal to what? It is equal to 4x cube minus 4. That's it. Then, first thing is at horizontal. That means a will be f dash of x equals 0. C will be f dash of x equals 45 degree. We saw it was 1. Now substitute over here, 4x cube minus 4 equals 0. Put it in the calculator. Over here it is 4x cube minus 4 equals 1. Take this 1 to the other side. It will be minus 4 minus 1. It will be minus 5. Should have written it directly. 4x cube minus 5 equals 0. Just use your calculators to solve it now. You will get mod phi. Now, which is this? It's cubic. It's mod phi 3. But do we have x square term? Do we have x? No, it will be 0 and 0 over there. Let's, not 3, sorry, 4, option 4. Mod, phi and 4 now, okay? Let me just show it again. Mod, phi is for equations and 4 is for cubic equation. Now, what is the coefficient? It is option 4 is the cubic. Now, there is no x square term, so it's 0. C is for x term 0. Last D is the coefficient minus 4. What is the answer? It's 1. And then the imagined number. So only 1 is the answer in the first place. Okay. The imaginary number means it does not exist. So x equals 1. There it will be the turning point. Now what about the next one, 45-degree thing? Same, 4, sorry, 0, 0, but this changes to minus 5. So the answer is 1.07, and then we got imaginary numbers, okay? These are imaginary. So the answer is 1.07 over here. So x equals 1.077. Now we will just check the answer. The B value is to graph it. Now, what just happened? Let me just see. Oh, this is the previous question. We got this previous right. I'm so sorry. That has been put over here. But don't worry, what I've written over here, up over here, the part A, that's the correct answer. And you can see this is around 1. See, 1, it's the turning point. It's not so accurate, but at 1 is the, turning point. You can see over here at 1. It's not very accurate, but that would be the answer, whatever answer you get. Then others are imaginary, so just ignore it. So that'd be the turning point. And what about this? At 1.07, you will have a 45-degree line. See, this is somewhere over here. Really, this graph is not smooth, but you can use Desmos to check properly. But they have told over here exactly where is the global minimum at x equals 1. Okay, you don't need to find this minus 1. This is at 1. What is the value? Y value is minus 1. In the last problem, what did we find? Only the x values. That's it. Here, this is just for understanding. This is to describe the graph. How we can find it is, if you put over here everywhere 1, 1, then you will get the answer minus 1. So that is how we do it. Yeah, that's about it. And the last one over here is given in terms of this. We will solve this and check. In your calculator, you can type, your answer must be that. So it is 5 by 2, that is 2.5, the whole power 1/3. So that is equal to, wait a minute. I just realized here there's another error. 1 second, we need to make this 5 by 4. Now we are getting it correct. Again, there's another error in the solution set. See this. What happened over here? 5 by 4. This much is all right. Now they have solved it manually, but if you do it in calculator, you should be sure this is the correct answer, what we got. Now here, 4x cubed minus 4 equals 1. You're removing 4 outside common and then divide 4 both the sides. You'll get 1/4 x cubed minus 1. All right. Then you're taking this minus 1 to the other side. It'll be added. It's 1/4 or 5 by 4. Now you take cube root on both the sides. Cube root means power 1/3. Now here, 5 by 4, it should be 5 by 4. That's the mistake here, okay? Now, when it is 5 by 4, what happens? You'll get the correct answer. It was 1.077. So this is the correct answer, okay? Or you can just do this. Cube root over here, 5 divided by 4. Sorry, I did 4 by 4. It's 5 by 4. The answer will be 1.077. Okay, that's how you do it. It's just that the same method, what we did, here it is in more detail. I don't think so graphing will be asked, but if it's graphing, you know how to check the values easily. This graph is a little bit, they have told the answers are correct, but not so accurate. So you can use Desmos for this. Now, another problem. Here, look at this. It's a squared function in the top, and then there's a cube root function. So what happens? It's basically cube root x squared. You can write this in a different form. This is a cube root function. Now, what is about cube root function? It comes like this, right? There is a horizontal asymptote at 0, so it's never defined at 0. 0, the value is undefined. So we will just quickly go through it. You must know at x equals 0, the derivative is undefined, okay? Now, how do you derive this? We have done it before. Let me just show you. With the question over here, it changes a little bit. Slope of the tangent line. You're just finding the slope. Sorry, you do not need to graph and everything, but graph and signify. Okay, this is important. Now over here, I don't think so they will be asking you to graph. Over here, all they want you is this thing. Okay, this is it. This is not like the previous two problem. 33 and 34, we did A, B, C. C was at 45 degrees. A was at horizontal, that is at equal to 0. Now over here, the thing is they are asking only to find the slope of the tangent line. Only this will be your answer, okay? Because this is not differentiable at 0, so you're not going to do all that. But when you graph it, you have to just tell it. But when you graph, I don't think so they'll be asking you to graph this. But at graphing, you always remember when there is a cube root, here it's undefined. At 0, it's undefined. That's what it's mentioned in the graph. Now, how do we do this power rule? It's a power rule. We have done it before, right? So we have a given question, 2 by 3 f of x. Just derive this. F dash of x would be this power rule. This comes down 2/3 x to the power 2 by 3 minus 1. So what happens? 2 by 3 minus 1, yes. Solve this. X to the power 2 by 3 minus 1 would be 1/3. But this will be negative 1/3. Why? Because you can see 2/3 is less than 1. 1 is greater. So I did 1 minus 2 by 3 is 1/3, but with the negative sign, okay? Now, this is your answer, but I'm sure this won't be in the options. So they usually simplify this. They don't like to keep the negative powers. So they take it in the denominator. It will be 3x to the power 1/3. Check for this option. If this is there, that's your answer. If this is not there, then they will write this x to the power 1/3 by what? Cube root, okay? Cube root x. Now, this must be your final answer. There's no more simplification. You can't do anything else. See over here, this is the final answer. That's it. That's how you do this one. And then please do, okay, there is, wait a minute, there is wrong even over here. I just realized it now. The question is correct, I believe, or if maybe the question is wrong, I'm not sure. Anything can be wrong. Now, if this is phi, right, x minus phi, remember, where is the corner over here? At phi. See, minus phi x equals phi. So it will be at phi, this value over here, it should be like this, okay? Now, I will just change the question over here to 3. It will make more sense because the answer will be true. Otherwise, if this is the question, minus phi, everything must be over here at phi instead of 3. Okay? And this must be, it should be, rearranged. 1, 2, 3, 4, and 5. This is 5. Okay, so that is the thing. If this is 5, otherwise just change the question to 3, and that's the thing. Over here, the graph, the tangent line is continuous at x is equal to 5. At phi, it does not exist. Over here, can you derive it at phi? No, it's a absolute value function. It's a sharp corner, and you cannot have a derivative over there. There is no tangent line over there at that point. Now, how do you do this? See, there are various ways. Now, I will tell you the easy way to remember. Just derive what is inside this. Derivation of inside term will be 1. That's it, right? Why? Because when you derive over here, it's gonna be x. Oh, sorry, I forgot to tell you the cases. The first, never mind. This is the easier method. Okay, f dash of x is 1. But remember, there are always 2 cases. If you recall grade 9, there are grade 9 videos in that we have absolute value function. How do we solve case 1, case 2? This means it can be plus or minus. So this answer basically is plus, or it even can be minus. But the answer will be only positive. It will be written as positive. So if I have, wait a minute, if I have minus phi inside this, the answer will be phi. Or even if I have phi, it will be phi. So there can be 2 answers within, right? Now, since x is variable, we do not know. There can be 2 possible answers. So we write 1. And 1 more is minus 1. Both can be the answers. That is about absolute value. Oh, everything went off. It's better I'll just change this to 3. Okay, this is 3 over here for this particular problem. And now what you do is basically solve it. You know the derivative over here is 1 and minus 1. Now, where is it positive? Always remember this is like this. So this is 3. More than 3, it will be positive. Look at this, it's positive. Less than 3, it's negative. That's it. So 1 is basically x greater than 3, whereas negative at less than 3. Now, one more thing, I'm just wondering how this will come for the exam. See, there is no derivative. We have done that before. It's a sharp corner, so that doesn't exist. But you will have to just choose this correct answer. When you choose, just see over here, x greater than 3 for positive, yes, less than 3 for negative. Let's look at this next problem. It's again similar. Now what you need to do, the derivative, right? Let's derive this. Oh, one more thing. How will you find this x value? What did we do over here? I will just use that negative thing. See here, x minus 3 equals 0, right? X is equal to 3. This is the thing. I make it x is equal to 3. That's how I do it. Same thing over here, but it's a big term. X square minus 3x, the given question, right? Just, sorry, let me write it right. X square minus 3x minus 4 is equal to 0. All you need to do is this. And now you can use your calculator and solve it, isn't it? Let's take our calculators. Here, all you have to do is mod 5 and 3 and put this 1, minus 3 and minus 4. And then x equals 4 and x equals minus 1. So these are the limits, but now how will you know where it's positive or negative? Now over here, in fact, if you have the knowledge of this graph, it's much easier, okay? We know that if it's a single term, it will be like this. So every time when it's positive square, when it's positive, it's like a W. Okay, so if you remember this, it's easy. If it's negative, it'll be something like this. You can use the Desmos and just check it out. So you might get generally positive, and this is how we do it. Okay, so what I would suggest is just remember this part. And now we know one of this will be minus 1 and one more answer was 4, right? Yeah, it's 4 and minus 1. This is 4. So you can see at minus 1 and positive 4. Okay, that is helpful. But now we need to do the derivative. Let's derive this. F dash of x will be 2x minus 3. This is the derivative. And what happens? F dash of x, the same thing. There will be two answers, right? Negative of this, say minus of 2x minus 3. Minus sign multiplies inside, it will be minus 2x plus 3. Now sometimes you might just think it's minus 2x minus 3. No, the minus sign is for the entire thing. Okay, so that's why it will be signs change. Basically 2x minus 3 minus 2x plus 3. And now what you need to understand is what is downwards. Look at this. This part, it's negative, right? Because it's a quadratic, x squared minus x squared, like that. It's a inverted parabola. If it was positive, it should have gone up. So this part from here, from minus 1 to 4, the x values from minus 1 and less than 4, so this one will be the negative part, minus. Okay, you have to multiply minus. The other part, look here, from less than, it's going upwards. Over here also upwards. So anything that is greater than, see, greater than 4 or less than minus 1, all these parts are this part, positive. Okay, it's 2x minus 3. This is the thing, 2x minus 3. This is the things. I hope this is clear. It's very straightforward. Just find the derivative, which will be negative whenever it's negative part. The upside is positive, so we write positive. So that's how we do it. That's for graph, but you know, if you do this much, it's more than enough. Okay, now you must always remember this won't change. So if it's just the options, you have to choose the correct option. Always remember the positive part is when it's greater than the second term. You will get this right when you solve it. We'll do one more problem on this. Now when you solve this, right, you will get two answers. See which is the lesser value. Okay, the graph will always be like this. See which is the lesser value. Negative 1, bigger value is 4. So for the positive, it will be either x is greater than 4 or x is less than negative 1. The negative part, it is always within this range. So x must be within this, less than 4 or greater than negative 1. That's the thing. I hope that is clear. And where is the maximum? It's over here. That's from the graph, basically. I don't highly think that graphs will be asked over here. Now, if you're thinking about where's the maximum or minimum point, we have done this before as well. just make the derivative equal to 0. Derive this, it will be 2x minus 3, make it equal to 0. It will be take this to the other side, will be 2x equals 3, x is equal to 3 by 2. That's the point maximum they have told. You can see over here at 1.5 you have the maximum point, but that's yeah, if you need it. But mostly just focus on this derivative part. Since this is an MCQ, question 9 MCQ, so I'm not exactly sure how is that going to be asked. Again, we have a cube root. How do we do that? We have just done it a while ago. You can see a cube root will always have, it's not differentiable at this point. Why? It's a vertical tangent. It's undefined over here. Okay. Now, how do you derive this? That is important. Derivation. We have done this before. Okay. The question again might be wrong because the answer solution set over here is 9. Okay. It's 1 by 9. Anyways, if it was 1 by 3, it's very simple. I'll do for both now. From the question over here, from the answer I saw this is 1 by 9. If it is x equals 1 by 3, what happens? 1 by 3 comes down. X to the power 1/3 minus 1. 1/3 x minus 2/3. And this will be 1 by 3x 2/3. Now you can write this, you can stop over here, the answer is like this. But if at all this is not there, you can write 1 by 3 x square, write it, only this divided by goes out, it will be cube root. This will be the final answer. But now this is not the question, it's supposed to be 9 here. Okay, I should have written it later. This is supposed to be 9 here. So what we do is 1 by 9 comes down and you will have x to the power 1 by 9 minus 1. So 1 minus 9 is 8. So it will be 8/9 remaining, but it will be negative because 1 is negative. So 1 by 9. If you're getting confused with all these, just use calculator. 1 by 9 minus 1 is minus 8 by 9. Take that down. 1 divided by 9, x to the power 8/9 positive. So this is the answer. Okay. And from the graph, you can see it's not derived at that point. Same thing over here. Here you can so there are, see now, don't get confused. Oh, this is sub question. We know these are separate questions altogether. You need to do two parts. Derive it by using the slope of tangent means derivation, and then graphing. Here also, we have done this just now, just a while ago. Same concept. It's greater than minus 2, it's positive 1, less than minus 2, negative 1. And now, okay, we have a square function. We will do this now. You need your calculator for this. Mod phi 3, 1, phi, and 4. So x values. What are the x values? I'll just use this. So x is equal to minus 1. And let's just quickly check over here. And minus 4. Okay. X is equal to minus 4. See, the textbook method might vary, but this is very simple. Okay. So now you know the graph will always be like this W, and you have at minus 4 lower value minus 1. So anything that is within this, that is minus 4 less than x, minus 4 is less than x is less than minus 1. Because minus 1 is bigger than minus 4, you should write in ascending order, is having the negative part. Let's derive this negative part of the derivative. It's 2x plus 5. Now change the sign, will be minus 2x minus 5 at, you can see it's written when, but it's fine, at this range. Now the positive part, 2x plus 5 at where? When it is greater than, x is greater than negative 1, or when it is less than minus 4. You can see over here, it's written the other way around. X is less than minus 4 is written first and greater than. Okay, that's it. So this is how we do it. Very, very simple. We just did it a while ago, the same concept. Now, if you're going in more detail, I've explained over there why it is downwards. This is positive upwards. That's why the signs matter, you know. But you can just remember this and directly do this. Okay. So that's the thing. You can solve this and find the, so it'll go to the other side. Negative 5 by 2 is negative 2.5 is the relative maximum. Now we have few more problems. Again, it's the same concept. Over here, look, they have told the tangent line at 45 degree. Let me go back to the computation mode. Tan 45, what is it? 1, we have done this. The next part is tan 30 degrees. You must equate at this. That's the thing. Let's quickly do this. Here, derivative of y is f of x, okay? Derivative would be 3x square minus 3. Now I have to equate a would be equating 3x square minus 3 equals 0. B would be 3x square minus 3, that is equal to. Now when I look at this, I know root 3 by 3 is equal to, divide both the sides, it will be 1 by root 3. Why? Root 3 is fine. You can write 3 as root 3 times root 3 and this cancels. So you're remaining with 1 by root 3, isn't it? So that's the thing. Or if you're getting confused, just put this. It's fine, because I have to type this in the calculator. So I just simplified it. This is equal. Take this inside and then you can simplify. You will get the answers. We will do it now. This can be easily solved first. I just realized there's no 0. It's supposed to be 1. 45 degrees, right? Tan 45 is how much? 1. Look, I'll just do it. Tan 45 is 1. Okay, my bad, I just forgot it. Because in the previous case, we were doing 0 and 45. That's why. Now take the other side. Will be 3x squared minus 3 minus 1 will be minus 4 equals 0. Put this in calculator. Mod phi 3. It's 3, 0, and lastly we have got minus 4. The answer is 2 root 3. It'll be 2 root 3, yeah, or 2 root 3 by 3. It's the same thing. Over here we got 2 root 3, where there are two answers. They are same. Why? Because I can multiply both the sides by root 3 and see over here, root 3 by root 3. What's the answer? It'll be 2 root 3 by 3. Whenever you see such things like without root 3 and you're getting root 3 up and a whole number down, just remember they're equivalent. Just make sure you know how to solve it. One is positive, one is negative. That's the answer. You do not need to do all these steps. You can directly use calculator. It's question number 9. That's why, in short. Now the next one over here, let me just complete the part B, will be bringing this inside. It will be 3x squared minus 3 minus 1 by root 3 equals 0. You can put this entirely same thing in the calculator. It will compute for you. Mod phi 3. The first part is 3. There is no x part. It's 0. And last one, I'll use the bracket minus 3 minus 1 divided by root 3 close. This is the 3 bracket and then one more bracket which I opened. Okay. That's the answer. Let me just check the answer. It is 1.091 and negative 1.091. Now over here okay, they have just written it directly. They have not even solved it. But over here, I will just show you. If you solve this, you will get the same answer. Let me do it. 1 plus 1 divided by 3 root 3. The whole power, half is 0.5. Okay, did I do something wrong? I think so. I did not put the brackets properly when I solved it. Let me just, oh no, over here it is wrong, sorry. Okay, I did not put brackets over here. It just made this power for this part only. It's for entire thing. We got the same thing, 1.09. I remember the answer. So what I solved over here and what we got is the same thing. But it may not be exact. So what you need to do is whatever you get in your calculator, write it out. 1.09199 and then solve the options and then you will get it. One answer is this, one more answer will be just minus over here. So that's how you do it and that's how you can easily solve it. I hope this is clear. We have done the similar problems. It's just the same thing over and over now. And now they are asking us, okay, the answer is you've been asked to find the tangent lines which are parallel and perpendicular. Now for this you need graphing calculator or a software. So that's the thing. So this should not be asked. That's the even in the solution thing because it can be very, very complicated. It's not very easy to solve this by a simple calculator and graphing calculator is not allowed for you guys. So that's why we can leave it. But please be thorough with the previous ones. The concept, the method is same over here. Derive it by using the power rule and then equate it accordingly. If it is 30 degrees, it will be this over here. What is tan 30? Just put that tan, because the tangent lines degree over here, it's equivalent to 1 by root 3, or this is equal to 3 root 3 by 3. If it is 45 degrees, equated to 1. Horizontal or 0 degrees, it will be 0, and so on. That's how you solve it. And that's the end of this question. Question number 9. It's a lengthy one. I hope it is clear. Do practice more problems and try to be thorough in it. Question number 10 is a simple topic. It's easy. You have to just use differentiation 2 times. It is to use differentiation rules and higher different derivatives in solving real world problems. Let's look into this. Here you can see they have given you the position function, s is the position. We need to find the velocity and acceleration. We must recall position, like displacement or height, is static, like just as given value, that is given as s of t. Whenever you derive this d by dx of this, what is the answer? It is the velocity with respect to time. Now when you derive the function of velocity, you get acceleration. So this is the thing, given thing, static, height or position, derive it, you will get velocity, and when you derive velocity you get acceleration. Now let's look into the units. This is in terms of meter, this is meter per second, this is meter per second square. Okay, that's the thing. So please remember. And now sadly we can do one part of it up to velocity, we can do and calculate it directly, but not this. If they just want you to find the equation, it's not possible. But if they give a x value in the coming problems, you can see this one can be solved in calculator, but not this. So it's best to know the method exactly. It's only power rule, so it's not that difficult at all. Let's find derivative of this s dash of t, which is equal, this is equal to velocity, is the derivative of s of t. How would you do it? Power rule, the power comes down, multiplies with 16, it will be minus 32t to the power 1 plus 40. Since it's power 1, I don't write this. And t, just power 1 will be 1, so we don't write it. Plus 0, we don't write it. This is it. I'm sure you're thorough with this by now. And what about acceleration? Acceleration with respect to time. That is derivation of velocity, or you can write double derivative of the position. Now here you need to derive it again. It will be minus 32. This is the acceleration. That's it. That's the answers. So you can see here negative 32 and minus 32 plus 40. That's how we do it. Now you can just use the power rule and solve few others. This is again straightforward, so you can do it by yourself. But now this one, best would be to write this position in terms of how you understand it well. Okay, let me just write it properly. S of t, only t will have bracket. It's position with respect to time. So t root would be half plus 2t square. Now what do we have? Here, derive this s dash of t, that is the velocity. Half comes down, t. Okay, now I hope you remember, you can always do the formula. So square root t is always 1 by 2 root t. Okay, I will just use the formula and show, but we will come to this 1 divided by 2 root t. How? Here it will be negative half, because 1 minus half is negative half, plus 2 comes down, this is 4t over here. We can simplify this, rearrange this, 1 by 2t to the power positive half plus 4t, or we can write it as 1 by 2 square root t plus 4t. This is the answer. And now over here, what do we get? That is the velocity with respect to time. Okay, so you can see that's the velocity with respect to time. And next, what do we need? Acceleration. So derive this again. Now it's gonna be crazy, isn't it? deriving this again. So what I would suggest is whatever you have over here, just derive this again. But your option may not have this as the answer. So you need to simplify to the final form. This might be your option, or this might be option for velocity. This might be your answer for velocity, or this might be your answer for velocity. But now when you're deriving for acceleration, use this form. It's easy to understand. Now let's do this. Bring the negative half down. So it'll be negative 1 by 4 because half times half is 1/4. T to the power negative 3 by 2. Why is this? Negative half minus 1, it will be negative 1.5 or 3 by 2 plus 4. And then you can rearrange it and write negative 1 by 4 t to the power 3 by 2 plus 4. This might be your correct option. You might have this, or if this is not there, then you will definitely have this. It's negative over here. It will be square root. You do not need to write the 2 because square root it's understood. If it's just a square root, it's enough. It's understood it's a 2 over there. T to the power 3 plus 4. These are your answers. So these are the steps to do it. Now you have to do the steps. There is no other way. You have to do the power rule. Okay. Now over here you can see they have very basic answers, like they have not simplified, but it's better to know the simplification. They have just done not these two steps, only the first two basic steps. But please remember, sometimes these won't be your answers. This is the correct answer, but there will be more simplification, so please make sure you do it up. So that's the thing. You can see over here, these two are the answers. Now what about this? It's the same thing, just take the t to the upside, it will be t minus 1 and then solve it up. So it's again simple. Please do it by yourselves and make sure you understand it. Power rule, let me just do it once quickly. So when you derive this for velocity, derive the about term, this will be 0, negative. Okay, first let me rearrange and write this. It will be 10 minus 10 t to the power minus 1. Why? If you bring it to the numerator or denominator, the sign changes. Now it's plus 1, it becomes minus 1. Now here, this minus 1 comes down, so it will become plus 10. T minus 1 is minus 2. This is the answer. Or you can write it as t square. 10 divided by t square. So you can see they have just written this answer, but always remember to make this power positive, you can just take it down. And again now, minus 2 times 10 is minus 20. Minus 2 minus 1 will be minus 3. So that's how we do it. Now here again, it's the same problems. What you need to do is find the velocity and acceleration, but they have specified intervals. So let's do it. What you need to do, basically derive this. How do you derive? It's the same thing. T comes down. It'll be 16 times 2 is negative 32t plus 40. This is the velocity. What about acceleration? Again, derive this. It'll be negative 32 only. Now, this part, right? You have a t variable. What is the initial time? At which time do you have to solve this for? At 1. See, this is the part A. Now I'm just doing for A. Let me do A first. At t naught equals 1, that means over here you need to substitute the t value as 1. And the answer would be positive 8, right? 32 minus 40 minus 32 is 8. Here, this is itself the answer, minus 32, doesn't matter. B over here, you need to multiply this 2 times, negative 32 times 2, because t naught is 2 plus 40. Now the answer will be 64, so it will be negative 24. Negative 24. Okay? So unit is, it depends on which unit is given, meter per second, meter, so that's it. The 32 minus 32 will be the same for both. You can see over here, where is it? The acceleration, whether it is at 1 instant time interval of 1 or 2, it's the same thing. Because it's just the same, there's no variable, right? But here the first one was 8, next one was minus 24. That's the thing. Now over here you can see the velocity, it was going upwards because it's positive, negative because it's going downwards. Same thing here. The first part can be found out in the calculator. I'll show you. In your calculators, if you press shift and dy by dx, now type this equation entirely. That is 10 alpha x squared minus 24 alpha x. Okay, and what is the x value? X value is 2. Wait, that's 16. See, at 2, interval time 2, its velocity is 16. What about the interval 1? Velocity will be negative 4. But for the acceleration, you can't. So you need to make sure you solve it. Derive this. 2 comes out will be 20t minus 24. And then next one will be 20 only. So the acceleration is 20. So please make sure you solve it up. And that's it. Very simple problems. Make sure you solve more problems. And that's how we do it. If you have any doubts, please post them in the comments. We move on to the question number 11, that is on derivatives. We use quotient rule. This is a very important rule. It will be asked now and then. So here we go. Before we begin, I just want to recall this is question number 11, which is still in MCQ. That means you will have 4 options. So there is a trick which you can use to find the derivatives directly when it is, say, objective problems. I mean, when you have MCQs, multiple choices. So I will teach you that after solving one of the problem. I hope you know how to do the derivations. It's very basic. We have done it a long time before. We have done plenty of times before. So you need to be thorough with it, with all the power rules and everything. Here we are just learning extra about the quotient rule. I'm sure you all know what's quotient rule. Let's apply over here. But I'll tell you a few things. I'll just compare and differentiate between the questions and then I will solve a problem. Look here, look at these problems. Can you simplify this further? You can factor this out. To be very honest, you can factor this out. In the sense, you can get this in terms t something and multiply it with t plus or minus something, some number. You can factor it out. But this will just make more complications when you derive. So just leave it in this simplified form. That's it. You don't go to factor anything, just leave it in the simplified form. These over here, the quotient rule is applied directly, both of these cases. Imagine the numerator is u, the denominator is v. Then the rule is derivation of the numerator above term multiplied with the below term as it is, minus the above term will remain same and derive the second denominator, the second term. And the denominator is squared. This is very important. This is the rule. You should remember this. That's it. Now see over here, it's directly applied. We will come back and solve one of these questions. Now here, look, it is directly applied itself, but they have taken this to be power x half instead of square root. Okay, and then they have solved it. Or you can even remember this formula. It's fine. But now there is one thing. Here, can you see 3 and 6 is common? Can you see that? Only in the numerator. That's fine. You can remove that out. Why it can be removed is it will just help you in your simplification. Because otherwise, everywhere there will be 3 extra 3 will be recurring. And then you will have to remove it out at the end. So just make sure if there are any terms which are common, you just remove it out. Keep it outside. And because they are constant. Look, I'll just remind you, if you have 3x here like this, and imagine you're multiplying like this, what will be the answer? It will be 2 outside, and then we have 3. It's the same thing. Or you just take this 3 out, it will be just 6x, x derivative is 6 itself. Okay, this is not a very good example, but what I'm trying to say is it's better you remove the terms common out. Now say for example over here 2x minus 4x squared. Okay, let me solve this up. Here what happens, it will be 2 derivation of this and this will be minus 8x. Okay, now I can remove common term, that is 2 outside, and what is remaining? 1 minus 4x. Okay, fine. But now what I'll do is I'll remove a common term out at the beginning. This 2, I'll remove it out at the beginning. What remains? You're remaining with x and 2x squared, isn't it? 2 is taken out over here and 2 from this is taken out. Your x minus 2x squared. And what you do is derive this. It will be 1 minus 4x. The answer is same. It's just that you're saving a step. Like, I mean, not saving a step. It'll be more easier in complicated problems. That's why they have removed 3 outside at the beginning. Now, even over here, you can remove 3 outside. Wait, let me just check. Yes, here it's not taken. But honestly speaking, it would have been easier if you had taken 2 outside over here. I'll tell you why. Because you just remove 2 outside and yeah, it's fine. You should have removed 2 outside, it would be easier. But anyways, it's not taken out, but don't worry, it'll be the same answer. I will just solve this with removing 2 outside, okay, and then I will just show you how it is the same thing. Let me just do it. The numerator over here, it is 1 by x, okay. Now I will just remove 2 outside. It will be 3x minus 1 by x divided by x squared plus root x. Now I will write the formulas for 1 by x and root x. I'll just write it over here. 1 by x derivative is minus 1 by x squared. Root x derivative is 1 by 2 root x. Okay. Why I write this is because I'll directly use this over here when I'm solving it. Now here, these two, you can see the above term. Let me just change the color. This one is u, this one is v. Okay. Now let me solve it up. Let me solve it over here. I'll just remove 2 outside entirely. Okay. Now I'm just dealing with these two terms. This is a constant, doesn't matter. Now what happens is it is u dash. So 3, because you solve this, minus times minus 1 by x squared. What happened? I just derived this chain rule. This term and this term separately. That's the derivation. Okay, I will write the formula once again. It's u dash v minus uv dash divided by v squared. I just did u dash now. Okay. And then write the next term, v term as it is. It's x squared plus root x. Now what next? Minus u term as it is, that is 3x minus 1 by x, and derive this term. It will be 2x. And what is root x? It is plus 1 by 2 root x. Okay. And now square this denominator. It is x squared plus root x the whole square. Sorry, it's already there. That's it. I think so you can stop over here. I don't think so it's simplified. Let's just check. They have stopped over here. Yes, they have. Okay. Now here what you can learn is this 2. Now it can be multiplied. Now see over here, it's like this. This is a coefficient, right? When you multiply it, look, this will be a distributive property. It will be multiplied here once and here once. It's up to you to choose the term. You can multiply this 2 over here or over here. If I multiply here, it will be 6 minus 2 by x squared. Over here, it will be same thing, 6 minus 2 by x squared. Only one. Don't multiply at all the terms. Look carefully. These are, what are these? One single term, one single term. So these both are multiplication. That means all when you're doing distributive property, this 2 only multiplies once to any of this term, not for both the terms. That's what it is. So if you do that, then you will get whatever the answer is over here. You can see it's 6 plus 2x because the 2 is multiplied only to this term. And then plus or minus makes, another term, right? Over here also it must be multiplied, and it is multiplied over here. 6 minus 2x. So this is what everything is correct. Now over here from this last final step also you can remove. There is 2 over here common out, 2 here common out. You can remove that. Now if we had taken common term out, it would be like this. Directly you're going to get the answer. Okay. But generally, as a thumb rule, it's better to follow this. Why? Because most of the time, I mean, I can't assure this, but generally there will be a common term outside. Okay. So that's why generally as a thumb rule, what we do is we simplify the term first and then we derive it. Okay. Leave this 2 outside. See how we are left? The 3 is outside as a common term. Doesn't matter you take or no, you will get the same answer. But imagine this is the option. You will be very much confused, isn't it? That's why I would highly suggest you to remove the common term, and then apply the formula and solve it. You can see that's the answer. Over here, I have written everything as root x and 1 by x. What over here it's told 1 by x is x to the power minus 1 and root x is x to the power half. It's up to you. I generally write it like this, and this is equal to, say for example, root x equals to x power half. It's not wrong. 1 by x equals negative x to the power negative 1. So this is the thing. This is how we can solve them easily. Just know the formula. And now here, please do the FOIL method. Make sure you're multiplying these terms. U over here, it will be u squared minus 2u plus u minus 2. And simplify this, will be u squared minus u minus 2. So when you're solving, the numerator is this. Okay, I hope this is clear. We can see the numerator over here is u squared minus u and minus 2. And then you use the formula of the quotient rule and solve it. Same thing here, multiply this 2u over here, because if it was only a constant, it's fine. You can remove this 2 outside. See over here, it's already removed. So you can remove it right now rather than keeping it at the end. Don't multiply this inside. Just multiply u squared plus 3u. And then you need to simplify. So this is how we basically do these problems. All the problems are straightforward. Now, I'm just looking at this 11th one. What would you do is, instead of using the quotient rule, you can use the quotient rule. There's no wrong in that. You can simplify this. Let me just check how the answer is given. Yes, they also have done the same thing. This is easy. See, now you can look over here. Instead of using the quotient rule, because it's only root x, that is x to the power half, distributed, properly, evenly. So x squared by root x plus 3x by root x minus 2 by root x. You're dividing this evenly on all the 3 parts, and then you're solving it up. So when you simplify over here, it already simplifies a bit, and then you can derive it easily with just power rule, no need of anything else. So if you simplify the term and then apply the derivative, it gets easier. Here there is nothing that can be simplified, so you have to use the quotient rule here. So that's how we do it. Now it's tangent line. Okay, now before we go ahead, I'll just tell you the shortcut method. Okay, let me use a complicated problem, say this one over here. Okay, anyone, it's fine. We will do the left one because the right one I had already solved. Here, you need to have your calculators. Okay, let's take out our calculators first. I would highly suggest you just use the quotient rule and solve it by yourself, because this is very important and you have to know this no matter what. For writing and all, you need to know this. But I'm just telling you the shortcut method, because if you're just say you are blank and you just don't understand how to do it, then you have 4 options. You can try and get the answer, but it will take a long time. So I personally, if possible, would not do the would not do the calculator method. I would just do it manually. But anyways, what this method is, you need to assume a x value. It will work for any derivative problem, doesn't matter which, it will work. You need to assume x value. Okay, now the x value should not be undefined, so the denominator over here, so I will just put it in the calculator, mod phi 3, because it's quadratic, right? Denominator, mod phi 3. What is the first term? Phi 0 minus 2. So the number must not be 0.63, this one or this one, negative root 10 by 5. Avoid these 2 numbers. Generally, if you take 1.51, those will be avoided, okay? So don't worry much about that. What I would do is, I generally go with 1.5, but when it's derivative, right? I know this is going to be a huge answer, so there won't be enough space in the calculator to type it out. So let's go with 2, the option number 2, x value of 2, x equals 2 here. Derive, we are asked to derive, so let's just go You can clear your calculator. I'll just clear it because this sometimes lags it. Now here use shift dy by dx. Your x value must be known, otherwise you cannot solve. Yes, but we are just assuming a s value. Let's do it. 3, let me do the fraction, 3x alpha x. When you're typing the question in, make sure you type it in terms of x itself. Okay, root x divided by 5x squared minus 2. And what is the x value? We have assumed it to be 2. Or you can take it as 1.5 as well. Now write this number down. I will write at least 4 to 6 decimals, okay? 0.202227. Now, here then, what you do is, I will show you, you can even change this value. I will change this to even 2.5 or 1.5, okay? And for x equals 1.5, it is 0.5588881. Now, why I don't use 1 is, see, though sometimes 1 is not defined, there are some special problems where you won't get the correct answer. I am not able to give you an example right now because I tried many of these problems with the shortcut earlier, and it was working even with 1. But I know when I was doing my engineering studies back then, when we had math, there were some problems, maybe because the domain was something, maybe it was sign or something. One we used to avoid. Okay, I used to do this method before, and I used to avoid 1 because sometimes 1 would not give you the correct answer. That's the reason. Okay, otherwise 1 will definitely work. For these problems it works, but so just go with 2 or 1.5. Now what you do, this is the answer. Note the answers down. You need to have 4 options. We know the answer is over here. Now put this answer in the calculator, but instead of x, you need to substitute any, the answer which you assumed. That is 2. Now what I'll do is 3 multiplied with this entire term. So what I'll do, I'll just write it out. 5 multiplied by 2 squared. You can consider this to be x. Okay, you can make it x and then calc, but I would just write it 2 squared, it's fine. 2 squared minus 2. Use the brackets appropriately. Then here we have, I have forgotten to open one of the brackets. See this one. There are 2 brackets. Now here 1 minus, I know x to the, I'll just write as it is, it's over here. 2 to the power negative half, that is 0.5. Down, press this, and now close the bracket. If you don't press that next button, it will close the bracket to the power. That is wrong. You need to press next, close the bracket. Then let's do minus, open the bracket. X is how much? Again 2 minus 2, it's 2 times 2, power 0.5, close the bracket now. And lastly, we have 10 times 2, close the bracket, 2 times because there was 2 brackets, divided by, here we have 5 into 2 squared minus 2, close the bracket and square it up. Let's put equal to, this will be exactly this answer. I remember it was 7, 9 and some values. If you rewind the video, you will see this would be the exact value. But sometimes when you solve this, you will get a fraction. Then just press SD and compare. Because when you press shift and d by dx, you will never get a fraction. You will always get decimal. But when you solve like this, you might get fraction. So make sure, don't forget any of these terms. The 3, it should be there, okay? You will get the same answer. I will just show you, even if you take 1.5, it will be the same thing. We got 55881, right? Now, instead of x, the 2 we considered, I'll just change it to 1.5 here everywhere. So here it is 1.5, and then over here the next value, instead of x it was 1.5, and then 2 multiplied by x, again it's 1.5, and lastly we have 10x, that is again 1.5. Here also it's 1.5. Okay, that's it. Now press equal to, this is this exact answer, it's 881. So it will be the same. It works only when you have 4 options, otherwise it will not work. Okay, I hope this is clear. This is for the first part, the 5 to 12 problems. You can easily do it. Just remember the quotient rule and do it. Otherwise, you can even try exploring the calculator method. If it's like a huge problem, imagine the answer is too big and you're just so tired, you can do this. Anyways, so if you're doing the calculator method, this can be directly put in, but make sure you don't have u, everything will be x. Okay, just assume x values. Go with 2 for derivative because 1.5 will be many numbers because you have so many to input, right? It will be just too much. But otherwise, I generally go with 1.5 for other problems, whereas rationals and everything. But if it is, say, derivative, just go with number 2. It's a whole number, it's easy to type in. Now we will go to the next part of the question, that is 19 to 20, 19, 20, 22, and 24. Here we have been asked to write the equation for the tangent line. Again, it's question number 11. Don't go to do everything in detail. Let me first write the equation of the tangent line. What is it? That is given by y. There are various versions of this. I'll write the first one, y minus y naught equals m into x minus x naught. I don't prefer this because then always this will be taken to the other side. So what I would do is this, that y naught minus y naught will be here, it will be plus y naught. This is equal to y. This is basically a slope formula. What is slope? Y is m is equal to y2 minus y1 by x2 minus x1, isn't it? Now take this denominator to the other side. It becomes x2 minus x1 m, or let me write it over here, m backside, m equals y2 minus y1. Now this negative y1, take it to the other side. First, it'll be m into x2 minus x1 plus y1 equals y2. Now it's just that equation generally has one point and one x and y terms, right? So here we're just, sorry, not that one. This we just remove 2 and 2. You can see that it'll be x. So that's it. It's y m into x minus x naught or x1 or x2, anything. As long you understand, it's fine. It's derived from the slope formula. Now tangent line, that's fine. This is the equation, say y equation, okay? If you remember this, or okay, instead of doing all this, because I know everyone will remember m, that's why I'm doing, but we know the point slope formula is this formula exactly, okay? This is point slope formula. Now what next? Here I will tell you what are the things we require. We require x naught, y naught. Whatever is given to us, this is the initial value, x naught. What is that value? That is a naught. X naught over here is given. They will mention it as a value 1, 2, 3 like that. It's 0. So basically x naught, this is a naught, right, is 0. Okay, in this formula. Okay, another version of this is m into what is that, x minus a plus f of a. This is also one more version. There are various versions, okay? Whichever is convenient. If you think, oh, this is easy a, yeah, take it. Or just understand, this is x naught. Now I'll substitute. We know x naught is x minus x naught is what? 0. Or a is 0 given. How do we find this f of a or y naught? Here, instead of x, substitute a, or this is equal to y, right? This f of x means y equals, right? Just substitute the given value. Instead of x, just substitute this value over here. So what happens? It will be 0 plus 1 divided by 0 plus 2, that is 1 by 2, that's half, or 0.5. So a value is, f of a value is 0.5 basically. How? Whatever is given, just substitute in the equation and then solve it. How do we find m? So we are nearly there. This is y equals 2. Only m is missing. That's the slope of the tangent line. That means derive it. Take out your calculators now. We know derivation is finding the slope of the tangent line. So directly derive this given equation. Shift d by dx. Put this in the calculator. Alpha x plus 1 divided by alpha x plus 2. And what is the x value? 0. This is the answer. It's 1/4 or 0.25. Okay, I'm not sure how exactly it is in the the final answer. It generally will be 1/4 and a half, I guess. But anyways, I'll simplify this. Y equals x minus 0 is x. So I'll just write each step. Over here it'll be x plus 0.5. That is y equals 0.25x plus half. Or if it's not like this, then it will be y equals 1/4 x plus half. This will definitely be the answer, any one of this. So you can see it's y equals 1/4 x plus half. That's how we solve it. You don't need to do anything of this derivative and all, because you will be given the x value, directly substitute it, substitute over here. Remember how to get the a value. It will be given, any formula you can use, and this f of a or y naught is just substituting the given x value or a value into the given function and then finding the y value. And then only the slope of the tangent line is by dy by dx, calculated again. So this is how we solve this problem. Same thing over here, it's just that a value is given as 1 or x naught value is 1. So try this by yourselves and you can compare the answer over here. For this part, slope part, you can directly do, see this negative 3/2 from calculator. Make sure you substitute it properly. Try this by yourselves. Okay, now this is an interesting, the last one. It's a bit lengthy because there are different types of problems. How would you solve this? It is not direct because over here, you have been given in terms of functions f of x, g of x, how to solve it, and you need to solve at 2 points, a and b. First, find the derivative of that. You need to know the power rule over here, I mean the quotient rule here, otherwise it's not possible. Quotient rule is given as u dash v minus uv dash divided by v square. I'll substitute over here. That means f dash of x multiplied by g of x minus f of x into g dash of x divided by the square of this term g of x, the whole square. This is the derivative, that is h dash of x. I hope this is clear. Now this is the thing, you need to find the equation for the tangent line based on these. So this is basically y, okay? Y is this part. Now let me write the equation first. Y equals m into x minus x naught plus y naught. Here x naught value is this, or I'll write it as a. You can write it as x naught will be this, or you can write it as a and f of a. And since over here the function is h, I will write h of a. I hope this is clear. Given function, whatever is given. If I write f of a, it will be wrong because we have the numerator as f of a. That's why I did not write f of a. You can write anything else. Now here, what is known? This is known, 1. This will be like this. What is the slope now? We found the slope. Slope is basically this one, h dash of x. What are these values? Look here carefully. Let me change the color over here. And if you look carefully over here, they have given everything. F dash of 0 is equal to negative 1. What is f dash of 1? We want at 1 now. F dash, because we know x. See, the a value means x naught value. All this over here, we have to substitute now 1. Okay, basically we are substituting that. So substitute over here. F dash of 1, what is it? 3. This first part will be 3 multiplied with, what is g of 1? G of 1 is 1 minus, what is f of 1? F of 1, where is f of 1? Over here, minus 2. And lastly, what do we have? G dash of 1. Where is g dash? Okay, this one, minus 2, again minus 2, divided by the square of g1. The a part is all 1. We have to just search for 1s. G of 1, that is 1 square. Now if you simplify this, it will be 3 minus minus will be plus, again minus 4 by 1, it is minus 1. So here the slope is minus 1 times x minus a is 1. And what is this h of a? Substitute in this given value h of 1. Okay, because a value is 1. So f of 1 divided by g of 1. Now what is f of 1? Here f of 1 is minus 2 divided by g of 1, where is g of 1? Here is 1. So it's basically minus 2. So the answer is minus 2. So the final answer for the part A will be, multiply this minus inside, it will be minus x plus 1 minus 2, sorry, minus 2. You can simplify it further to minus x minus 1. Or you can remove the minus sign outside, it will be x plus 1 negative. So this would be the final answer. Let's just check the answer quickly. Yeah, that's the answer. But over here, they have only simplified the right part. See, this minus 1 means minus only, right? Bracket x minus 1, and this is just written minus 2. But all these three are correct. We have just simplified from one form, one form, one form. It depends on what is given. Over here, they have just given the basic thing. So here, this part, can you see this first answer what we got? This is just written as minus. Minus 1 means just minus sign. Minus 1, minus 2. This is it. This is the answer that's given. So this is how you basically find it. At the second point, second part A is 0. It's the same thing what we did. See what we did over here. But everything will be in terms of 0 now. Here, I'll just change over here. This will be 0. This will be new value. Over here, everything will be new value. Okay. We can just solve this one as well. So it'll be, oh, that's just, oh, 1 second. Let me just, no, it's going to take a long time. So I'll write it out again. We don't know what is, y is no, y is that's it. We don't know what's m. We don't know what's, a is, sorry, 0, right? We don't know the other things. Let's solve. So now instead of 1, everything will be 0, 0, 0 over here. So what happens? F of 0 is minus 1 divided by g of 0. What is g of 0? Where is it? 3. So it's negative 1 by third, negative 1 by 3. So h of 0 is negative 1/3. And what about m? You can't solve in calculator. You need to do this. And now we need to substitute and solve it over here. So let's just rewrite it. Everything f dash of 0 now. Everything with 0 because the second value is 0. So what is f dash of 0? You need to search. Okay. It's better to write easily the question in the some way, and then it's easy, or else you can just search it out. It's minus 1 times g of x. Where is g of 0? Sorry, now g of 0 is 3 minus f of 0. It's minus 1 times, last one is g dash of 0. It's again minus 1 divided by, what is g of x again? G of 0, it's 3 squared. Now this will be minus 3 minus 1, because minus 1 is 1, then again minus is there, so this is the thing, and it's 9. It'll be negative 4 by 9. So here it'll be minus 4 by 9. That's the answer. I hope that's correct. Did I miss something? Yeah, it's minus 4 by 9. Okay, now I forgot to multiply this inside. All you do is see over here. X minus 0 is just x. So multiply x over here. It'll be minus 4 by 9x. And this will be negative 1/3. That is the equation of the tangent line when a value is 0. So this is how we basically solve it up. You can see that's the answer. That's it. So these are all the problems. Now this one is again same. Just do it by yourself. Just derive this. You can see the derivation of this is given over here. It'll be 2x times 2x is the derivation of the numerator, g of x as it is. Keep this term as it is, x squared, derive g dash of x divided by g of x the whole square. All the values are there. Substitute, easily solve it. Just like what we have done a while ago. So make sure you try to solve them by yourself. All the answers are available over here. Check your answers. Yeah, and then we are at the end of it. So there are about 3 different type of problems in that. So please be thorough with it. And even the next topic is also similar to this. So it'll be very helpful if you know the exact method. So be thorough and then move to the next topic. Question number 12. It is to find the derivative of an inverse function using chain rule. Now, I will be very, very honest. This is the one topic which I get confused so often, But I'll try to make you understand, thoroughly about this. because it's not an easy topic. It's, to understand this, you need to realize what exactly is inverse, how this is working, and all that. And you need to memorize one formula as well. So I will write things down, try to understand it, but then I will tell you the shortcut method as well. Shortcut in the sense, not that shortcut. You need to know the basic things, okay? But I'll explain in detail what this exactly means, because I am sure many of you are still confused with this particular topic, okay? So now I'll tell you in detail how this works. First of all, here let's read the question and understand. They have told, let me first change the color to brown, okay. F as an inverse G. Okay, so what this means is F inverse is equal to G. This is given to us, okay? And we need to find the derivative of this inverse function G at particular value A. Okay, it's very complicated, right? And they have just given us the function f of x. Okay, and they have told this inverse is G and this we need to solve. How can we do it? There is an important formula for that. The formula goes like this. I hope I'm correct. It is G dash, let me just reduce the thickness over here of the marker. Okay, G dash of any value. Okay, I'll write x. Oh, yeah, obviously G dash of x equals 1 by derivative of f of, and then what happens is, okay, it's G of x. I need to double check this because that's what, comes to my mind, but let me just try this properly. It's derivative of f dash of g of x. Okay, this is the formula. Let me just double check this formula. Yes, derivative. Yes, I'm very happy that I got it right. Okay, now the thing is, in my mind, the explanation for this flows, but it's hard to, particularly explain this one topic. I really don't like to explain this topic. That's me being very honest, because I don't know why, because out of all the topics, this is something that confuses me so often, Now, let us understand what exactly is inverse. So I know this is the function f. Is there f of x? Okay. Now, let me just write f. Okay. Let me go back. And imagine we have x and y values, and the inverse is given as g, right? The inverse g, or that is f inverse basically. What does this mean? If this is x and y, the inverse would swap itself, isn't it? Y and x over here. So if I have x as 2 and y as 3, here it will be 3 and 2. Don't you agree? So what I will do is, because I want to write both in terms of x and y, okay, I will write this as xf, yf, and this as xg, yg. Because always the x value is the first value, next will be y, xy, even over here xy. But since inverse, if this whatever is there is equal to the last term. So now what you need to understand here is, let me just change this. Whatever is this on this value will be equal to this value, and whatever is over here in this value will be equal over here. Okay, from this we can now try to explore few things. G of x, we need to find the derivative of a. What is that value? A is given as -1. This is basically like g dash of x, right? From the inverse, this is related to inverse. So what value do we know? I will erase the top functions x and y. This I'll just erase. Now what value do you know? X value of what? G. X value of g. So I will write it here. That is, a is the x value of g, which is given to us -1. -1 is known. If x is -1, what happens over here in the given function? The y value is also -1. Now, whatever is this value, these both will be equal. So this is the basic understanding. Okay, I'm very happy I didn't get confused when I told that. So now, how can we what can we understand from here? I have the function f that is only over here. This one is related to the inverse. So this a value from the inverse, it's x of inverse. So basically, it is the y value of this function. So f of x equals f of x, when you input x, that must be equal to y, that is -1. This is the concept. Now, if I substitute over here g of the inverse function of -1, I will get some answer which I don't know yet. Okay, but that will be this value. So here we know f of x must be equal to -1. Okay, what is the x value? We have this equation f of x, so I'll substitute over here. X cube plus 4x minus 1 must be equal to -1. Now I need to solve for x. So whatever the x value is there, I will write it over here. That is the concept behind this. So here, now to find this x, there are various values. What you generally start is substitute 0 as x. Over here, if I put 0, it will be 0 plus 0 minus 1 equals -1. So x is equal to 0. Another way is there is the coefficient method. That is basically, you should know what is the leading coefficient and this term, and then based on that you can do it. But generally always start with 0. Even there is calculator method. I'll show you that. That's the easiest method. Let's take our calculators. So here what you basically do is type this equation as it is. Alpha x cube plus 4x. Sorry, I have to press this. Plus 4x -1 equals -1. Shift and solve. What is the x value? It's 0. So only when you press 0, this will be balanced, right? So answer is 0. Okay. So x value is 0. So now this x of the function is 0. We found this was y value was given -1. It's really inverses x, but that is equal to y function's y value. Now if this is 0, then these two are same, isn't it? Xy becomes yx, so this will be equal over here. So just again, these two values will be equal to each other, and these two n2 values are equal. That's about the inverse. Okay, now we know lots of values. Let's try to solve this formula. Is it possible now? Let's try. We need to solve g dash of x, that is given over here as -1. That will be equal to 1 by f inverse of g of x. Now g of what? G of -1 basically. Okay, now this is the thing. What is g of -1? From here you can see g of x would be equal to y, isn't it? That is the main reason why we solve this. So here if you look at the inverses, whatever is the x value for this function will be the y value for the inverse. So g of x basically is 0. See here, if you substitute x, if g of -1 will be equal to 0. So what happens over here? G dash of inverse -1 equals 1 by f derivative of this particular value 0. Now what's remaining? You need to find the derivative of this function, because we have f dash, we don't have derivative. F dash of x is, over here it will be 3x squared plus 4. Now instead of x we need to substitute 0 over here, because this was 0 over here, and g of -1 was 0, and now f inverse of 0 is what? It is basically substitute 0 here, it will be 4. So the answer of f inverse of 0, this entire thing, is equal to 4. 1 by 4 is the correct answer. That is the derivative of the inverse. You can see 1 by 4 is the final answer. Now this is the method to actually do this. This is, I mean, I've told you the entire understanding method. I hope this is clear. Every time you need to understand why we are substituting what. Here, why did we substitute this is equal to -1? Because of these, what's written over here, f, g and everything. I hope this is clear now. This is the exact understanding of this problem. Okay. Now, once you're understood, there can be some tricks to be done. If you are still getting confused with this, just by heart this. Whatever is given over here must be equal to this value. Now, let's do the second problem over here. Let's take out the calculator again. Whatever is given over here, the x value, right? Say it's alpha x to the power 5 plus 4 alpha x minus 2 must be equal to minus 2 here. What is the answer? It's 0. Most of the time it'll be 0, or sometimes it'll be 1, minus 1, something like that. Just try. Here, when you do it, you'll directly get the answer, not to worry. Now, here also x is 0. So, we just have to write this equal to this given a value. So, we know this is equal to 0. So, what does that mean? See, here, we need to solve 1 divided by whatever the answer you get. Shortcut, direct. Okay? So, what happens is, the derivative of this, let me just put it over here. The derivative of this at 0. We got x value is equal to 0, right? Now, f dash of x, where x is equal to 0. This needs to be found out, okay? Now, even another shortcut is by using the calculator, shift and dy by dx. Put this alpha x to the power phi plus 4 alpha x minus 2 at x of 0. Whatever we initially get, this answer is 4. But 4 is not the answer. The derivative g of whatever they ask you here, it's minus 2, right? This will be 1 divided by f derivative, so it will be 1 by whatever the answer you get. So this is it. So I will sum up the steps over here. I'll just do the last problem. Directly within 2 steps, you'll get this answer, shortcut. First step, whatever is given over here. Wait, let me just double check answer. It should be 1/4. Yes, that is 1/4. Okay. Now let me just solve the last one over here. Let's get our calculators back. All you need to do is first, whatever is given to you, alpha x cube plus 2 alpha x plus 1 equals to given value minus 2. Shift and solve. The answer is -1. Here it's not 0, it changed. Now let me just write that. X equals -1. So derive this given function now. Shift and dy by dx. Alpha x cube plus 2 alpha x plus 1 at -1. What is the answer? Phi. The final answer will be 1 divided by phi. Let's just check. It's 1 by phi. This is the correct answer. This is how easily you can solve it up, just with 2 steps. Always the inverse, it will not change. And you have only 6 problems in this particular question. These are the last 2. Over here, same concept. Let me do this last one. It seems a little big, right? Same thing. In calculator, I'll directly do it. One more thing before we solve. See, this formula is there, right? G dash of... You need to memorize that formula. But since it's MCQ, you don't need that. But this is the standard formula. The derivation is not there, but you have to use this formula to derive, okay? Now, without the formula, what happens is whatever answer we get, we just write it below. So step 1 would be whatever is given, that is the square root of alpha x to the power phi plus 4 alpha x cube plus 3 alpha x plus 1. Make it equal to given value 3, shift and solve. What's the answer? It's 1. Now, you can write it down over here. X equals 1. Find the derivative at that particular point, f dash of 1. So what we do is shift and dy by dx, square root alpha x to the power phi. Now, if you have to derive it, would take some time, because it's a square root function. You have to do 1 by 2 root x multiply by entire derivation of inside functions. But it saves time in the calculator. Plus 3 alpha x plus 1. What is the x value? Not this. The answer what we just now found, x equals 1. So here, wait a minute. Doesn't matter. Let's just check the answer. Okay, yeah, it's correct. Okay, I was just a little confused. Now here the answer of this one is 10 by 3. So what you do is, the formula tells us G inverse of any value, say A, will be equal to 1 by, okay, I'm not going to write the formula. It's basically 1 divided by this answer, okay, f dash of A. Now, not f dash of A. Let me write the formula. F dash of G of A. So we had found all this, then it'll be finally f dash of this thing. G of a is basically 1. G of a is 1. So f dash of 1 is 10 by 3. It's 1 by 10 by 3, which will be equal to 3 comes up 3 by 10. Or you can just do this thing inverse of this answer. Answer inverse is 3 by 10. So that's the final answer. You can see over here. That's the answer. So this is how you solve this particular inverse problems. Very straightforward. The calculator method saves a lot of time, but for understanding, I told in detail at the beginning, you can, for understanding purpose, but then you can use the shortcut calculator method. Just those 2 steps, if you remember, you can easily get the answers. That's it in this particular question. The question number 13 is derivatives of trigonometric functions, where you use the differentiation rules. Here, this is again in the MCQ part. That is you will have 4 options. So you can use the calculator method, which was told in the previous video. That is question number 11. Now, before we begin, let's look into the formulas. These are the formula of trigonometric functions. Sine is cosine, and cos or cosine is negative sine. Always remember, whenever there is either it's cosine, cotangent, or cosecant, what happens is you will always have negative signs. Oh, my bad. This I just realized now. There should be minus sign here and minus sign here. Okay. Wherever there is only secant, where is secant or tan or tangent, sine or secant, it's always positive. The formula is like the sine and cos will be opposite of each other, but for cos derivative, it will be a negative sign in the answer. So sine is cos is negative sine. What about tan? Tan is secant square x, whereas cot is cosecant square x, but there's a minus sign here. Whereas secant is secant times tan, and cosecant is cosecant. Instead of secant, we have cosecant, and instead of tan, we have cot. It's very simple if you go through these formulas. You'll easily understand it. Now let's look into one problem over here. Any of this, let's take this is a bit bigger. What you need to do over here, directly use the power rule. It's very straightforward. As you go, it is derive this part individually. 2 comes down to be 8x, that's it, to the power 1, minus 3 is a constant, leave it. Tan 2x will be, tan derivative is secant x, but we don't, I'll write it over here. Tan x derivative would be secant square x. But now instead of x, we have 2x, so we have to write 2x. So the derivative would be secant square of 2x. And we have to do the chain rule. Once we are done with the tangent function, this is done. Tangent function is done. What is remaining? 2x. What is the derivative of 2x? It's only 2. So this is the answer. We'll rearrange and write 2x minus 3 times 2 is 6 secant square of 2x. This would be the final answer. You can see over here, let me just take it out, 8x minus 6 secant square 2x. That's the same thing what we got. The problems are very, very straightforward. You can do the same thing. Now look over here. This is, let me just do this one over here. Anyway, the answer is visible, but I'll just do it right over here. What you need to understand is, I think so there are problems about this in the further problems as well, but let me just do this one. Whenever you have tan to the power 3x, remember like this. This is for the entire function, because tan, the function, the trigonometric function, is powered up. So this is equal to tan x the whole power 3. Okay. But if it was tan x to the power 2, then it is only to the x. Okay. This is how it is. Now, if you solve this, 3 comes down, it will be 3 tan square x. But this one, what happens is, this is not over, chain rule. The power is done. Now solve the inner part. What is the inner part? Secant square x. That's how we do it. Now, what about this one? Here, you need to first solve the outer function. It's like an onion, right? The chain rule. I will put a link on the chain rule to this lesson because it's very important to understand chain rule. I'll just put the link for the differentiation because of the trigonometric function, because in that it's explained in detail. So please, if you want more explanation or more details, click on that link. Now here, this is firstly done. That's secant square x square. Okay. And now you need to do the inner function, that is x square will be 2x. So this is the chain rule. Okay. And now over here, the same thing. See, the 3 is first solved. 3 comes down, tan square 2t. And this 2 over here is another 2, which is written at the end. Okay, because it's the you can write it next to it, that would make more sense. Okay, now what about this thing here? What just happened? Okay, sorry, it is my bad. It is correctly written. Look at this part. I will just solve it over here. Tan cube 2t. So this is basically 3 comes down, tan square 2 times t multiplied. Now the power is done. Power is done. This is equal to tan 2t the whole cube, isn't it? The power is done. Now what is next? The trigonometric function. So multiply it with the trigonometric function, that is secant square of 2t. Then you have to do the last inner part. This is the function remaining. 2t derivative will be only 2. This is how it's done. Now same thing over here. Minus, what happens? The 4 comes down, cosecant cube 3t. Now you derive cosecant. The derivation of cosecant is what? Secant is secant times tan, but cosecant will be, first is minus sign, and cosecant over here it's not x, it's 3t multiplied by cotangent, not tan, it's cot 3t. And this minus is only for this part. And lastly, you have to do the inner function. What is the inner function here? This 3t. That will be multiplied by 3. So this would be the answer. So you can simplify this. 3 times 4 is minus 12. Minus and minus becomes plus. This 2 minus becomes plus. And here we have cosecant cube and cosecant to the power 1. Just simplify this. It will be cosecant to the power 4 3t, and you have cot 3t. So this would be the simplification for this. Even over here it will be 6. Only simplification will be this will be 6. So that's how we do it. Now, how would you do it in calculator if it was, trigonometry? I would highly recommend you not to use calculator because there'll be answers are huge. You will take a long time. Sometimes it might hang and everything. But anyways, all you need to do is let's take out the calculator first. You need to make it into radian mode because it's trigonometry. Shift mode and 4. Now let's put this value, shift dy by dx, alpha x multiplied by cos phi x square. Now what is the x value? Close the bracket over here. Now what's the x value? I will take x to be x equals 2. Now I just put it as 2. It's much better if you take pi and stuff, but anyways, it doesn't matter. You will get the correct answer itself. So the answer noted down is negative 36.109727. Now then, what you do is see the 4 options over here. This is the answer, right? Substitute here cos phi, instead of x you have to put 2 square, close the bracket, minus 10 into 2 square multiplied with sine phi times 2 square, close the bracket. The answer will be the same, doesn't matter what. But if it's not in radian mode, you'll get wrong answer. This is very straightforward. We have done it previously. But what if the value is not in terms of sine, cos, or tan? If it's secant, what do? It's fine as long as you remember secant is equal to 1 by cos, or cosecant is equal to 1 by sine. If it is S over here, it's 1 by C. So opposite of that. If it is cosecant C over here, then it will be S down. So we have to use this. Let's do this. Shift dy by dx. x square is alpha x square multiplied by, now you can't use secant, it's 1 by cos 1 by cos 4 alpha x. And now put the x value over here, 2. Let me solve it. It's 720.243. Let's remember that in the minds. And then let's look into the answer. No, I'll just write it because I'll get confused a bit. Anyways, x was 2 and the answer is 720.2430167. Now then, what you do is type, why I'm writing so many decimal is if another one is very close by 170, so these decimals are required. Anyways, now over here it is 4 into 2 square multiplied with secant. Again, you need to do the same thing. 1 by, oh, cos. Did I put cos just a while ago? I think so, yes. Anyways, 4 into 2, close the bracket. Now, tan is directly multiplied with tan 2, 4 times 2, okay? It's the same thing, 2 times 4 or 4 times 2. Close the bracket and close the main bracket, which I used. Oh, sorry. No, this bracket ends later for the entire terms, right? No, sorry. This is for this term plus. Now I'll write plus 2 into 2 multiplied with secant. Again, it's 1 by cos 4 into 2, close the bracket. And the answer is 720.24301. It'll be the same, doesn't matter what. So this is how you can directly check the answers, provided you need to have the options. Even over here, you can do it by yourselves. But here you're using quotient rule. Even over here, quotient rule and solve it. So in such cases, it's very helpful to use the calculator method. Okay, you can try this. Very straightforward. As long as you're changed to radian and you have substituted all values properly, you will get the correct answer. Please do try to solve these problems as well. Now, if there are two variables, in such cases, there'll be only one variable. If there are two variables, like, we had one case in the inverse one, you can't use your calculator, but always the derivative will be one variable, so not to worry. So these are the answers. You can pause and check the answers. Try it by yourselves. Same concept. Remember the formulas and apply. Again, same over here, but let's quickly see here. This is again, it's just long but very easy. It's just that it'll keep on going. See, power rule first, then cos, then you have to use the this power rule entirely, and then multiply it with square times this thing. Then you're deriving the cos, and then you're deriving the square root. There are so many things, it's just one by one. Sorry, I got confused over here. Over here, we are using the product rule. This one function, this one, sorry, the chain rule, and then there is a chain rule inside a chain rule. I hope this doesn't come. If this comes, just use the calculator method. You'll get the answer. But, this is just a huge one. See, there's a chain rule. This is x. So inside this again, x. And oh God, this just keeps on going. So try it out, because if you look carefully, you'll understand, okay, this is a chain rule. Then inside again, chain rule and another chain rule. So it just complicates stuff. Now, this one's important, these ones. I'll do this because there's a high probability some of these might be asked. Because, they won't ask you huge problem. The same concept is used. It's just a long one. If such problem comes, use the calculator method. It'll save time. But now over here, I'll write these problem. A is sine x square. This is only for x. B is sine square x, that is sine the whole x the whole square. And last one, C, is just sine 2x. Now when you derive this over here, the first outer function will be sine, so it will be cos x square multiplied by 2x. That's it. Here, the 2 is the power rule first. 2 sine x to the power 1 multiplied by cos x. That's it. Then x, we again derive, it will be 1 itself, so we don't write it. Then over here, it will be cos 2x into 2. So these are the answers. See, all these three have unique answers. You can see over here, this was, the 2 is always written first, see the coefficient. So it's 2 sine 2 cos 2x. This was 2 sine x cos x. And lastly, we had the first one, we had 2x cos x squared. That's how we do it. Same concept over here. It is just that we have power half. Same thing, it'll just be, take this as x power half. And then half comes down, x to the power negative half, you can see, because it's square root. And then we write sine root x. So this is the same thing, same concept is translated. Please do try to solve them by yourself. Over here, you have to use product rule. You can see the first one is by product rule, second one is by chain rule, and this one again is by chain rule. See, I'll just tell you, this product rule is very simple. You know that rule is u dash v plus uv dash. That's what is used over here. Now, they have just written another form. I'll solve this quickly. The first term is u and this is v. So u dash would be, this square is only for x, okay? So what we write over here is basically sine will become cos x square into 2x multiplied by the second term tan x plus, now leave this term as it is, sine x square multiplied by the derivative of tan is secant square x. Let's just compare y. Okay, they have just done this term first. See, this is over here and the second term is over here. Only for product rule, you can write this formula anyhow because it's plus, right? You can write uv dash plus u dash v. But for quotient rule, don't change it because it's minus, it will be wrong. Now the next one over here, again, 2 comes down. 2 comes down, the power rule first. Sine of, instead of x, we have tan x. Now that is done. Now do the sine, sorry. It'll be cos of tan x. And lastly, what's the inside function? Tan x will be secant square x. This will be the answer. Let's just check. Yes, that's the answer. And last one over here, same thing. First, what you have to derive is this. Sine becomes cos, but instead of x, we have tan square x. Okay, this is done. Multiply it with, now there is a power rule over here. So do the power rule first, 2 tan x. Now do this outer function, tan function. So it is secant square x. That's the answer. Yeah. And they have just rearranged and written it, but you can write it like that. That's more than enough. So it's just that you should understand, it's like peeling an onion, outer things first and then you come inside. So that's basically how we do it. You can please refer to this and solve more problems on yourself for practice. And that's about derivative of trigonometric functions. There are a few links on the description, in the description down below. You can please refer them as well for more understanding. And if you want in detail calculator method, please refer the question number 11, I believe. Yeah. Question number 17 is to find derivatives of natural logarithmic functions. It's just not log functions in this, to be honest. You have exponential functions as well. Now let's look into the problems. Here, before we go into the problems, let's look into the formulas, the three important formulas. It's very important to differentiate among these two. Okay, this and this. Many times you might get confused with this. Now, it's very easy to recognize e to the power x is exponential function. So if this is given, it's the same thing. Now, what if it is e to the power 2x cubed? What happens now? This will be the same thing, e to the power x cubed, but then we do the chain rule. The outer function here is e, right? This is done. Now, solve this one. That would be, derivative of that will be 3 comes down with 2, it will be 6x squared. So this would be the answer. Very important to remember to apply the chain rule. This over here, in this case, what does this a mean? A is any constant number. So say, for example, it's greater than 0. Say, if you have 0, it doesn't make sense, right? It will be 0 itself. And you can't have anything, sorry, the reason why it's 0, because see, ln over here is a. What is the domain of ln? You can't have 0 or any negative numbers over here. It can't be less than 0. It's not possible. X can't be less than 0. This is wrong. So that's why it should be any positive number. Only in cases like say 2 to the power x. In this case, you have to write the derivation is 2 to the power x, then ln, natural logarithm, the base, not this x, the base, that is ln of 2. This is the reason. If it was x over here, then it doesn't matter. It can be any number over here, a, because you can have a negative number, it's fine. But remember, since this constant is written, you cannot have negative or 0 numbers. So if you have, say, for example, 2 5x to the power 4. What happens now? Look at the base. Base is a constant, a number which is greater than 0, and this is the power x. So the derivative would be the same thing first, 2 5x to the power 4, then ln of 2. This is done, but we have not dealt. See, the outer function is done now. This is the outer function, right? This is done. Now you have to deal with the x, this function. The chain rule applies. Multiply it with the derivative of 5x to the power 4, that will be 20x to the power 3. So this would be the final answer. So this is what we need to employ. Now let's do the problems in this. Here we have, say, 1/3 raised to the power x square. It's the first part. Remember the formula for ax ln a. Okay, so derivation of this is the answer. You must write d by dx, but I'm just written dash. This is the derivative formula. So here we have 1/3, sorry, not x, 1/3 raised to the power x square. So write it as it is. See, 1/3 x to the power 2 ln of 1/3. But don't forget the chain rule, because this is, if this was x, it would have just been 1, so we don't write it. But it's not x, it's x square, it becomes 2x. What about this one here? Same thing. Here, just important thing is, here it is what? Negative x. Keep it up only, don't go to change that. Just solve it like this. Minus x square into ln 4. This is the first part. Now solve the the other function. It'll be minus 2x to the power 1. So this would be the answer. So this is how we easily solve these problems. Okay. Now remember, don't go to think, oh, should I take it down or should I take the new? No, just don't, because it should be as it is. But make sure here what is done, the negative sign remains. First solve this as it is and then multiply it with the derivation of above. I just realized that over here it's rearranged and written, but the answer is same. Okay, answer does not change here. And I am just checking out this. Okay, now what is done here? Why is it changed? If you recall the properties of log, now this is the correct answer. Let me just go back. This is the correct answer, okay? But now you can simplify natural log 1/3. I'll just do this. This other parts are correct. What about this? Now, whenever there's division, this is equal to ln1, the upper function, minus ln, the lower function. Okay? Now, what is ln1? If you recall, it's 0, isn't it? Now, ln, this one is 0 minus ln3. Now this is the part. So over here, this, when you simplify it, you will get minus, that minus sign, and ln 3. So that is the thing. Then other things are just rewritten. So the minus sign is written, but I'm not sure how it will be asked in the exam. Just remember here, I will prove it in calculator as well. Once again, get your calculators out. What you need to do is, see this, ln 1/3. What is the answer? It is so much, right? Now, if you put ln 3, 3, what's the answer? Only the minus sign is missing, isn't it? So that's why if you apply the properties of ln, that is ln 1, see ln 3 will be equal to ln 1, it's 0, minus ln 3. This is the thing. We don't write it in terms of number, we just write this part because this is 0, you're remaining, so the minus sign sustains. That's the reason. And even over here, you can apply the calculator method. Now, say for example, over here, now we got this answer, but in case you want to do the calculator method, you can do shift and this dy by dx, 4 to the power minus alpha x squared. What is x? You just take a value, say 2. Now the answer is negative 0.02166 and so on. Now here, just substitute 2 over here and solve it. Minus 2 into 4 to the power, what is, oh, what happened? I'll just take this. What is the x value we considered? It will be 2 over here as well, multiplied with natural logarithm of 4, close the bracket. The answer is the same thing. If you just go back a few seconds in the video, you will see it's the same thing. I remember the answer. So this is how easily you can check your all the answers. And since this is an MCQ, still 14th question, MCQ part, we can use the calculator method. Please do try to solve these problems by yourselves and you can easily understand better. Now, what about the second part over here? See, this one is easy. Okay, let's solve this because it's a chain rule. Okay, there is complication in chain rules. Let's do it now. First, this resembles a to the power x. So I will write this as it is, e to the power x multiplied by ln of 2. Okay. Now, whatever is to the power, derive that. It is e to the power x. That's it. This is the answer. I think so. There is no simplification. Let's check. Yeah, that's the answer, but it's just not written in this order, but this order is much easier to understand. Now, what about this one? See, there is no other way to solve this rather than using the quotient rule, u by v. That is, u dash v minus u v dash divided by v square, right? So this denominator will be 2x the whole square. What about the derivation of e to the power x? It's the same thing, multiplied with 2 to the power x minus, now leave this term as it is, e to the power x multiplied with derivation of this is 2 to the power x into ln of 2. So this would be the answer. Now we can simplify further by taking these two common out. I'm not sure whether it's done or no. Let me just do it. These two terms and these two terms are same, right? You can take e to the power x, 2 to the power x common out, 1 minus ln of 2 divided by, this is squared. See, now this square means you can cancel it, I guess. This means it's 2 to the power x multiplied by 2 to the power x. Why I'm writing like this instead of writing e to the power 2x? I can cancel this out. So you simplified, right? The final answer would be this much, ln 2 to the power x. Now let's just see. Okay, they have, yes, they have done the simplification. I was not thinking they'll do it, but yeah, they have done the simplification. You can see the final answer is what we got over here, but by simplifying, see, this is split, this cancels, this is distributive property is done. That's how. You can try this directly by calculator and you will get the answer, no problem. I will just show you because there is e in this. Let us use our calculators. Take out your calculators now. Here, let's type this shift dy by dx, and it is e to the power is by shift and this symbol power x divided by 2 to the power x, alpha and x. Now let's take x value of 2. Okay, I know it's defined at e to the power 2, so that's why I've took 2 or 1.5, any of these values. Let me just write it down. It's very, I might forget this value, 5663838. Now what you do is see for the 4 options. Okay, now this is the answer we know, but you will have other options as well. All you need to do is instead of x, put the value which we consider. Over here we had considered 2, so let's solve it. Multiply it with 1 minus ln 2, close the brackets, 2 to the power 2. The answer is exactly the same. Any other answer which is incorrect will not give you the same answer what you derived in your calculator. It will be different. So this is the best and the easy method to solve derivatives, to check your answers. Okay. Now same thing over here. Please do solve by yourselves. The detailed solution is available. This is the equation of the tangent line. We have done this in the last problem as well. Remember, the equation of tangent line is given as y equals m into x minus a plus f of a. Over here it's given as x, so I won't write a. It depends on what is given. I'll write it as x naught, okay? X naught plus y naught. Now, how do you find y naught? Just substitute this in the given function over here. So, how do we solve this exactly? This is again the same thing. We can solve it in different ways. Calculator method, or use the formula a to the power x ln a. See over here. No, this is finding f of a. This is the derivative, f prime or dash. Okay, anything you can call. Now this is 3 power x to the power e ln 3. Then do the derivation of this x to the power e. Now, what is x to the power e exactly? This is power rule. Don't get confused, because e is what? E is just a number, 2.7171819. It just keeps on going, okay? So here the power comes down, e comes down, x to the power e minus 1. This is what happens when you solve this power rule. So you can see this is a, that is 3xe into ln 3 multiplied by this term 3xe power minus 1. Okay, now then you can easily solve it up. Now this is the derivative, right? But since we have been given the x value, what is the x value? It's x naught is equal to 1. Directly use calculator. Using calculator saves a lot of time. So what we do is we will just press shift and dy by dx. Here it is 3 to the power x to the power e, that is shift and this symbol. Now over here e to the power 1, or you can use alpha and this, okay? Or you can press shift and e power 1. Now what is the x value? It's 1. The derivative means the slope of the tangent line. So I'm going to take this value over here as m. Now sadly we will get a number, like a numerical number, decimal number, 8.959. But in your final answer, this won't be there. It will be in terms of LAN or something like that. We will see in a while. Now, what next? What other things we need? Y is unknown itself. Y is y. X minus what is x naught, given as 1, plus what is y naught? Substitute this value over here. 3 power 1 to the power e, that is 3 to the power e. One second. Okay, I just realized what it is. Look, here it is 3. Let me write it 3. This is wrong what I've written. Why? Because I took 3 to the power 1 first. No, you should take 3 to the power 1 to the power e, isn't it? It's 3 raised to the power 1 raised to the power e. What is anything raised to the power 1 raised to the power anything? It's 1. Raise 1 to the power anything in calculator, you will just get 1. Or it'll be 10 or 100 or million or anything, 999, you'll just get 1. So this is basically 3 to the power 1, because 1, this power dissolves over here, and now that is equal to 3. So y naught is 3. This is your final answer. So here we have got 8.959, but in your option, see, that is not there, this is there. Don't worry, put this in calculator. See, other things are all correct, that's fine. What you do is put 3 ln 3 multiplied by e in calculator, and let's see what happens. Here now, 3 ln 3 multiplied with e. You can write this e and to the power 1 or alpha, and this symbol gives you that. It's 8.959, and it goes on. So this is how we can easily solve it, okay? Because you have to write the slope of the tangent line, you must remember this formula and substitute them accordingly. And over here again, you got some logarithm. Okay, now we have to use logarithmic. Looking at this problem, I realized there is no way you can solve x to the power sine x. If it was ex or something, you can try. But how would you solve this? Take natural logarithm on both the sides. See, it's I'll do it in the right side over here. Now this is the actual method. You might have remembered There are different methods as well. But now this given function, right, f of x, or you can take it as y, is x sine x. Taking log on both the sides, you're taking natural logarithm ln on both the sides. Okay, what happens when you take natural logarithm on both the sides? Here it remains like this only, f of x, that is equal to, what happens here is the power comes down. The rule of natural log is, if you have 3 power squared, this is equal to 2 ln 3. Whatever is the power comes becomes the coefficient of natural log. So here the power is sine x, becomes the coefficient of natural log x. Now what next? How would you solve it? What we would do next is basically derive the both the sides. You just derive on both the sides. Over here you put d by dx and try deriving this one, and derive d by dx this one over here. Now here there is product rule. I'll do the right side first. It is u dash v plus uv dash. So what happens over here is derive sine x, it will be positive cos x into ln x, plus sine x remains as it is, sine x multiplied by, what is the derivation of ln x? It is 1 by x divided by, oh sorry, that's it. This is product rule, not quotient rule. I thought divided by v ln x squared. No, it's wrong. It's quotient, product, only so much. But don't forget the left hand side. Now what we do is, what is the derivation of ln x? It is 1 by x, right? But now what is the derivation of ln x square? It would be 1 by x square into 2x. Chain rule, right? Now what about this function here? This is basically like ln y, like implicit function. We know that whenever we do that, it will be y into y derivative, y dash, implicit functions, right? Chain rule. This 1 by y multiplied by the derivative of y. See, if it was x squared, we derive it, right? That's how. So here what basically happens is ln is gone when you derive. This was y dash. It will be 1 by f of x multiplied by f dash of x. This is the actual answer. This is the thing. Now here we want derivation. Derivation means derivative f dash, f prime. So all you do is everything else take it to the other side, only keep f dash of x on one side. This I'll leave over here. F dash of x equals. Now this over here, see, I can see in the left side answer, they have taken common term. What they have done is, instead of writing only x over here, they have taken it whole LCM. Multiply x over here, multiply x over here, divide by x, so you can have the common term. Here there is x, right? So basically it is x times cos x ln x plus sine x divided by x entirely. Now what next? Here we have x sine x. That's it. Oh, sorry, I forgot to tell why x sine x. What is f of x? You take it over here. It is not, I just saw the left side and wrote it by mistakenly. F of x. Why? Because it's in the denominator, goes to the numerator. Now, what is f of x? F of x is the given question. Sorry, this one we are solving. It is x sine x. So that's why we write, instead of f of x, x sine x. And then this term over here can be written the same thing. So this is how we basically solve a problem using logarithm. We have to take log on both the sides because we cannot solve x to the power sine x. Look, e is, we did power rule for e. Why? X to the power e. Why did we do power rule? E comes down, x to the power e minus 1. This is a value of 2.7 and so on. The x value, whatever is raised, the power must be greater than 0, isn't it? It must be greater than 0. Or it's greater than 1 also, because 1 also, it doesn't make sense to have that. So that is the reason it should be a number only. You can't take any term like this, trigonometric function. No, we don't have the rule for that. It's clearly mentioned in the power rule. It should be a number. I think so. It's greater than 1. The number must be greater than 1. but we use the negative exponents also, we translate it. Okay, don't worry, we can use the same thing, but not other than numbers. So this is not a number, that's why now here this is a polynomial function, that's why we have to do the same method what we did just now, and then you can get the answer. So this is how we solve it. Here there are more questions. Please employ the same method, the same thing over here. What do you do? Take ln on both the sides. You can see over here that this power comes down x, ln sine x. Left side it's x, f of x ln. But now derive this. It'll be 1 by f of x multiplied by f dash of x. They write it together as f dash of x by f of x. In fact, when you derive ln f of x, it'll be 1 by f of x, then multiplied with the derivative of this. That will be up right in the numerator, so we write it like this. And now when you derive over here, you must use the product rule and solve it. So the product is term is x and one more term is ln x, and then you easily solve it and rearrange it. Or even over here you can use the calculate method. Just make it to radian mode and solve. Assume x anything, any value, write it down and then put the same value of x. Say if I have chosen x as 2 when deriving with the calculator, use the x value as 2 over here. So this is the thing. Please do solve, go through these problems, very straightforward. Do solve them by yourselves. Now, even over here, it's the same thing, this is the same concept. It's just that there are terms. As long as you know each term thoroughly, then it is very easy to solve any of this. If you're still getting confused in this, even though you understood it, but you can't get it right, then I would suggest you to do the calculator method. Okay, here it is just that. You need to take ln x. This comes over here. The derivative of square root is 1 by 2 root x. Then this is product rule over here, and then this is rearranging. This denominator comes to the other side. So this is how we basically solve the topic number 14. Please be thorough with the rules. Understand what function it is. Recognize the function and then apply the formulas accordingly. We are now in the last question of the MCQ part. 15th one is the last one. 16th to 20th will be the writing part. So this is about inverse trigonometric functions. They have also told about implicit differentiation. I don't think so there is implicit in this, but let me just let you know what this is in a short explanation, and then we will go to inverse functions. And I'll put a video for implicit derivations in the in the description, so if you want you can click on it and understand more about it. Here we have a few formulas. That is the inverse trigonometric formulas. That is sine inverse, cos inverse, tan inverse, cot, secant inverse, cosecant inverse. You need to remember these. I don't think so this will be given in the exam. You need to remember them. Now the easiest I personally feel is tan inverse. Okay, because tan inverse, it's better you write it down, you'll understand it quickly. Tan inverse x, it's just 1 divided by, for all the three things. I will tell you about this negative sign in a while, but it's always 1 divided by what? In this case, in the case of tan, you can write it as 1 by x squared, or you can write it as 1 by x squared plus 1. It's up to you, but generally you will say 1 plus x squared. Okay, that is the form. Next, over here you can see some have negative sign. Why is that? The same thing that was said before holds. Whenever you have cosine or cotangent or cosecant, there is a negative sign. Only when it is co. But otherwise, for sine, tan and secant, it's only positive signs, positive ones. But now what if it's a sine or a cosine? The answer is almost same, only the minus is different. So I'll write it as cosine inverse x. It's again 1 divided by. For cosine and sine and secant and cosecant, there is always integral. Okay, square root. In this case, sine, it's just 1 first. Why? Because x is negative, x squared. Whereas in terms of secant inverse, x, it's 1 by, I will tell the other part in a while, square root x square is positive, whereas 1 is negative. This is the main difference in these. So somehow try to remember sine, it's just one number is first, then minus x squared. Here you have x as well, modulus of x. That means this number, it can't be a negative number. Whatever, even if it's negative 3, it will be positive 3. So this is the answers. I mean, these are the formulas. Please try to remember them. They are very important and crucial to solve. Let's look into problems now. Sine inverse x cubed plus 1. We know the sine inverse formula. Sine inverse x is given as 1 divided by square root of what? 1 minus x squared. Now all you do is substitute the same thing, but instead of x, put this term. It'll be 1 divided by square root 1 minus, instead of x, instead of x term, I have used the bracket and write x cube plus 1 the whole square. Okay, because x squared. Now instead of x we have this, so we write it. But it's not over. Chain rule, derive this one. It'll be 3x squared plus 0. It's 3x squared only. This is the answer. What about this one? Same thing. 1 by square root 1 minus square root x the whole square multiplied by 1 by 2 root x. That is the derivative of square root x. Now this cancels. You can write it as 1 minus x, 1 by 2 root x. I think so. This is it, or the simplification. Let's see. Here 3x squared is up above, and square root 1 minus x squared plus 1 the whole square is written. Here it's the same thing, 1 by 2 root x and 1 minus x. Okay. Wait a minute, this is some error over here. There's no, there's square root. Yeah, okay, there is square root. Now look, what they have done is, what we had done, 1 by 2 root x is separate. This x is taken inside this. So this multiplied by this term. Okay, x multiplied by this term. Because when you take them inside, these both are multiplying each other. Okay, they're not adding. This two terms, bracket, multiplied by this term. That's it. This is how you simplify. Even over here, you can easily use the calculator method. Take a random x value, but remember that, say 2 you take, and then substitute x as 2 here and solve, you'll get it. Okay, let me just show it to you. Let me do it for this problem. You need your calculators for this. All you need to do is shift dy by dx. Sine inverse is given by shift and sine square root alpha x. Okay, close the bracket. Okay, there are two brackets open, two closed now. I will take it as 2. It's already in radian mode, otherwise you have to press shift mode and 4 to make it to radian. Okay, the answer is now this is a good thing. Why? The domain is of x for sine inverse is x can be only from -1 to 1. Okay, I think so. It's mentioned somewhere. See over here. It can't be anything other than that. Why? Because inverse domain is basically the range of sine function. The range of sine function is -1 to 1, but the domain of sine inverse is basically the range of sine, that's -1 to 1. So I'll take 0.5. Don't take 2. My bad. Or let me take it as something more complicated like 7.5. Okay, even this is possible. But if you go more than 1, it's not possible. So I'll write it down. X is equal to 0.75. And what is the answer we got? 1.154700. It goes on. Now check the answer. What was the answer? Here, all you need to do is substitute x as, instead of x, you put 0.75 multiplied with 1 minus 0.75. Close the bracket. And that's the answer. It'll be, oh, wait, sorry. The answer is 1.547. That's it. But you are getting in 2 root 3 by 3, but that's fine. But if you press SD, it'll be the same thing. What happened is I by mistakenly pressed the wrong button. I'll just do it again. It's 1 by 2 root 0.75. The answer was not exactly visible, but the answer will be saved. So you can use ANS to check the answer. Now this is the answer, 1.1547. That's what we got. This is how we can check any derivative problem. If it's trigonometry, you have to press it in radians. That's it. Please do these by yourselves. Over here there is the method, but okay, look here. There is chain rule. What happens is cos inverse is there, right? You apply the cos inverse instead of x, this 2 by x. Then you need to derive 2 by x. That's minus 2 by x squared. That's the thing. And then if you can simplify, you simplify. Minus and minus becomes plus 2. And this x, what they have done is this simplification. It's very simple. The thing is, here, both the sides, you're multiplying by x squared. Okay? Multiply and see this. Take the common term. I will just do it 1 minute. I'll just do this part, how they have simplified this. So square root 1 minus 4 by x squared is there, right? And over here, upside will be positive 2 and there is x squared outside. So what's happening? What basically can be done over here is you can take common term in the sense this will be a common denominator and you multiply this x squared minus 4 because this already has it. Otherwise, another way to understand is you multiply and divide this by x squared. So it will be x squared by x squared and x squared common, you get this factor. And I'll just write the denominator, this is x squared. Now take this denominator outside because square root, right? Basically you can write this outside, but square root and square cancels. You will have x squared by x, that is equal to square root of x squared minus 4 because the denominator is taken out, it will be 1. Okay, so this and this cancels. You're remaining with x square root of x squared minus 4, not plus 4, sorry, minus 4. This is the answer. So that is the simplification. I mean, it's up to you, but it depends on the options. Okay, so if this is not there, yes, you need to go further to simplify. Here as well, it's same thing. Please be careful with the chain rule after using the tan. It's very simple, 1 by 1 plus x squared. After that, make sure you use root x derivative. It's 1 by 2 root x, and then simplify and write. Same thing over here, it shall be minus 1 by x squared, simplify and write. Now it's a little different. I will solve this problem over here. What's different here? Square root is the outer function. So first, what is what is square root derivative? Square root x. It's 1 by 2 root x, isn't it? Now instead of x, we have all this, but still it's fine. 1 by 2 root with all this information, write it over here. 2 plus tan inverse x. Multiplied with, this is the answer for square root. Now there is this term to be solved. Derivative of 2 is 0. What is the derivative of tan x? It will be 1 by 1 plus x squared. So this is the final answer. I hope this is clear. So that will be the final answer. It's 1 divided by 2, 1 plus x squared. It's a factor, right? So it's written 2 times 1 plus x squared. Then square root 2 plus tan inverse x. That's it. And here it's again chain rule, but just that it is e to the power x. Now, what is the derivative of e to the power x? It is that same thing, tan inverse x. Then chain rule says derive this. It will be 1 by 1 plus x squared. That's it. This is the answer. Okay, you can see this is up. This is the denominator. So even over here, now you can see that they are trying to get the difference of secant and secant inverse. Let's do this. Do you remember the secant formula? Even I'm rusty. It is secant times tan, I believe. Secant times, I'll just check it anyways. It's mostly secant times, yeah, it's secant times tan. Okay, let me do it. What you do over here is apply, this is the constant, so keep it aside, just leave it. Now solve it. What do you solve? Secant is secant x times tan x. Okay, but now we don't have x, so it will be secant x to the power 4 into tan x to the power 4 multiplied by, what is the derivative of x to the power 4? It is x cubed, 4x cubed. Now this 4 times 4 is 16x cubed. Then these two terms cannot be simplified. Secant x to the power 4, and then what is there? Is it? No, it's hanging. Okay, it is tan x to the power 4. This is the answer. Now let's do the secant inverse. 4 is a constant, leave it aside. What is the inverse of secant? It is 1 divided by, I'll write it over here, secant inverse derivative d by dx is 1 by x outside root of x square minus 1. Not 1 first. For sine it is 1 first. For this it's x square minus 1. Now we write over here, what is x? It's not x, it's x to the power 4 here. It's positive, so it's fine. Then square root of x to the power 4 the whole square minus 1. This is the answer. Now we have to simplify this. Oh, sorry. Did I finish? No, this is done. Secant inverse is done. Derive 4x cube. See, even over here we had this. This is the same term, this is the same term. Only the middle term is different. So how do we simplify this further? It will be x to the power 4. Wait a minute, we can simplify this. X to the power 3 cancelled, this 4 cancelled. So you're remaining with only x over here in the denominator, because x power 3 and x power 4 cancels off. X is remaining, square root. X 4 times 2 is x to the power 8 minus 1. And 4 times 4 will be 16. I'll directly write it, because I have to write it otherwise entire thing again. So 4 times 4 is 16. This will be in the numerator. This is the answer. Okay, so this will be the, let's check the answer. It is 16x cubed. This is the answer. Here it is 16 divided by x to the power 8 minus 1. Though it's the same thing, but it's inverse, and this is not inverse, it's entirely different derivatives. You can see the difference here. Same thing over here, sine inverse and cosecant inverse. Only thing is over here, it has, it's all inverse. You have to just use the formula and solve it up. Very simple. Sine inverse. Cosecant, you will have a negative sign. That's the thing. This is very simple. Cosecant inverse. Just write the formula. That's it. Nothing else over here. Okay. Over here, please remember to do the chain rule. And always remember, you can even do the shortcut calculator method to solve this as well. That's the end of the question number 15. And we have completed the part A in this point of time. Please do stay tuned. I will try my best to do the remaining videos as soon as possible. And please do revise, solve more problems, practice more problems. That's the most important thing. And last request, if you have not yet subscribed to my channel, I do kindly ask you to subscribe to it. It would mean so much to me. And thank you for all those who are subscribed. If you have any doubts regarding the questions, please post them in the comments. For that particular video, just post it below in the comments. I'll try to get back to you very soon. Not maybe on the same day, but I'll try to get back to you very soon. All the best, guys. Bye-bye for now.